we're trying to get our live stream up and running. But I'm going to officially start our symposium today. I'm going to actually start recording. And we are going to get started with Pia. Pia is a UX researcher. She's going to talk to us about how I'm hearing myself somehow. I don't know how this is happening. One second. Okay, this is terrible. One second. Oh, sorry.
Okay, so I would take over then. Maybe Katelyn, you can give me a little check if you are hearing me, then this technical setup is correct. Okay, perfect. Then I will start by sharing my screen. And you see now all my presentation, is that correct? So in presentation mode. And then I don't want to lose time and just start my presentation. So thank you. I want to tell you more about UX research. And first of all, I would like to introduce myself, of course. I'm Pia Blumauer. I'm a UX research manager, and I am working at Scopus Nova. Actually, you found me here in Germany. We are sitting in Hürth, close to Cologne. And Scopus Nova are the experts for UX research and usability testing. And we are founded out of a market research group. So it was founded like 26 years ago. We were starting with market research. Now we have different companies. For example, HR survey experts. We have data science experts, mystery research, communities, and us, the Scopus Nova. We are experts for UX research and usability. And this is why I am talking here. And to get a first impression what UX actually is, I would like to share with you our mission at Scopus Nova. And I think then it seems quite clear, or you get a kind of an insight what UX actually is. So we at Scopus Nova, we think we are all users. So every one of you, every one of us, we are all users. So we use products online or offline, we use services, but we don't just think that it's important or it's like enough to just use them. We really want to experience them. And we at Scopus Nova, we want to capture, understand, and improve this experience, that it's really getting an experience to use a product, to use a service. And this is our mission. So I structured the talk today in 3 sections. So first of all, I want to explain to you what is actually UX, which UX methods should be used when. So I will give you a brief introduction to methods, and how does a typical UX project look like. So let us begin with what is actually UX. UX is the abbreviation of user experience, and user experience is somehow the top part of a pyramid. You can imagine that you have to go some steps before reaching, or before a product or a service is reaching a good user experience. So there are some preconditions. At the very low level of this pyramid, at the very main precondition is, of course, accessibility. So whenever a product or a service is not accessible for you, of course, it doesn't fulfill your needs, you can't use it, and now it's totally not realistic to have good user experience when your product or your service is not accessible. So this is the main precondition. Another condition to the way up to good user experience is utility. So whenever there's a product you don't need, then you don't use it. Whenever there's a service you don't need, you will not use it. So this is another precondition on the way to user experience. And we have usability. And we should, of course, distinguish here usability and UX. So usability is somehow a quality attribute of the user interface, covering whether the system is easy to learn and efficient to use, if it's pleasant and so forth. But it's different, or it's a different definition compared to user experience. User experience is not only the fact if something, a product or a service is easy to learn, easy to use. User experience is more the emotional part of the usage, means kind of the joy of use. So I hope this is not too theoretically. And if yes, I have some examples for you. I think this example makes really clear what good user experience is and what bad user experience is. So good user experience is, for example, this error message. This is really an example for good user experience. I hope you all have now a little smile on your face, because the little figures are looking kind of silly to us. And if you then see, it's just an error message. So it's like the typical message, page not found, but you have to smile a little because it's kind of with bright colors. There are some small figures, and this is really what user experience, good user experience is about. Then I, of course, have an example for bad user experience. And remind yourself of the pyramid I just showed you. Here, this is accessible. Of course, I'm standing in the elevator here. This is, I need it to really get to the upper levels of a building, for example. But it's not usable for me. I don't understand how to use it. It's not easy for me to learn how to use this elevator interface. And this is why this can't be good user experience. I don't have joy while using it, of course. So how do you develop products with a good user experience? And in our opinion, this should always be iterative and in this kind of circle. So I think the first step of a product development is always an idea. So you have ideas, and to make the ideas tangible, you should build a prototype. So you build it, you have something to click, something to interact with, or to touch, for example. But then we think it's very important that you integrate the user or some of the user groups. So after building a prototype, it's really important to measure and to get user feedback on your prototype. So you have to involve the user, because with this user feedback, you can learn in the end, and you can improve your idea, overwork your idea, and overwork your prototype in the end, test again. And this is how iterative, good user experience research should work. So this is kind of the circle of product development, which should be done with the goal of having in the end really good user experience. So to sum that a little bit up, I want to give you some user experience research principles. As I said before, important in that circle I just showed you is the user. So always put the user in your focus. You should really talk with your user. You should talk with people of your user group whenever you are developing a product. So it's really important to ask the user to gain understanding of the user needs. But however, it's also important to observe your user, because sometimes it's not easy for users to really talk about their user needs or to talk about things which goes up in their mind. But when you observe them, you can see if your user interface works, if your product works, or is there a button which is not comprehensible for the user. These are all aspects you can gain from observation of your user. And in the end, a really important thing, always when you do iterative user experience research and iterative product development, you should do mistakes, and mistakes are good. So you have to have the mindset that you can learn from your mistakes, and you can better move on if you make mistakes than if you don't. So we put that in a high complex mathematical formula for you. So we think that the best principle is to have, of course, own expertise in UX and UX research and product development. You put or you add some user feedback on it. The best is really to put your ego away, because as I said before, mistakes are good. So whenever there's an ego, this clashes somehow. So when you have your own expertise, you have user feedback, and you put your own ego away, this is the right path for, in the end, gaining good UX for your product or your service. Okay, then I will deep dive a little into some methods we could use to really conduct user experience research. And I think we can structure this a little. So overall, we place all existing UX methods in this coordinate system. So we have, on the one hand, we have the behavior. So whenever you are interested in what people do, you have to use UX methods which focus more the behavioral part of the interaction, for example, with a product. And on the other hand, we have the attitude. So whenever you want to know what people think, what people say, then you should choose some methods which focus a little bit more attitude and opinion. And we have another line here in our coordinate system going from qualitative research to quantitative research. So when you want to know why and how people do something, then you should use a method which is more qualitative. For example, in interview, you should talk to your user. And whenever you want to know how many or how much users do this or that, or say this or that, you should choose quantitative research. Or in other words, when you're at the right beginning of your product development, it's really important to explore some things. And this means you should better choose qualitative research methods. And when you are, for example, right before pre-launch or right before launch, then it's important to really validate your hypothesis. I give you some examples for UX methods, which are like located here in that coordinate system. The one we do the most are moderated UX and usability tests, and for example, focus groups. But you see here as well, for example, eye tracking. There you can observe, so the user gets like special glasses, and you can observe the gaze behavior and develop some heat maps, for example, regarding the eye movement on your website you just developed. Then there's, for example, A/B testing. Then there's also unmoderated UX and usability tests, more quantitative than moderated UX usability tests. Then there are focus groups, which are kind of a group discussion of your of persons of your user group. And then there are diary studies, for example, which focus a little bit more the long-term usage. Then we have card sorting, where the user is asked to categorize some topics. And we have the online survey. I think you all know the online survey. But I will briefly give you a more detailed look into some of the methods. So first I want to explain to you moderated UX and usability test, because we do this the most and it's really easy to conduct. Whenever you whenever you want to develop a product, then you can just do face-to-face interviews with people of your user group. Each is lasting, for example, around 60 minutes. Of course, there's sometimes also interviews where which are conducted about 90 minutes or 30 minutes. However, in these interviews, we always focus the interaction with the product. So we observe the user while he or she is interacting with your product, for example, and therefore we gain the user feedback. Of course, in times of COVID, it's also sufficient and really easy to do remote UX and usability tests. And remote UX and usability tests just work like with kind of with video tools like Zoom, like this one here, or with Microsoft Teams. So there are a lot of video conference tools you can use. And via screen sharing, you can interact with a participant, and you can talk about, for example, an online website, and you can also observe. So remote usability tests are really easy to conduct. So the advantages of remote usability tests are that spontaneous sessions are, of course, always possible. No travel or room costs at all. And participants are in familiar surroundings, for example, at home, and anyone with an internet connection can be reached. So this is quite easy to do. But on the other hand, there are some disadvantages when you're thinking of doing UX usability testing remote. Of course, then you have just like tech-savvy participants, and it's like a little bit less personal contact. That results in less interview depth in the end when you compare this to offline UX and usability tests. And then there are, as I told you, there are unmoderated UX usability tests. You can imagine that you develop kind of an online survey, and in that online survey you define special tasks, or you define exact tasks the participant has to go through via using your product, for example. And so this is kind of a fast setup, low costs, and it's another advantage is that it's really scalable, because you can it's a lot more effort to really have an interview with everyone, but here you can easily have 50 or 100 participants. But a disadvantage is that you cannot ask how or why did someone do something. And in the end, the data analysis reduces the efficiency advantages you have maybe upfront when setting that up, because you have then generate, of course, a lot of data, and you have to analyze this data, of course. Then there are focus groups. These are really like group discussions with 5 to 7 users of your user group. It's kind of interesting because the group dynamic is as well an advantage as it is a disadvantage, because you can imagine there are some participants or some users, some people who get inspired maybe by others and gets even more creative than alone when being in a group. But others who are maybe a little bit shy gets even more shy when they are in a group, and when there is, for example, a dominant participant, which is always who has always a strong opinion. And of course, compared to face-to-face interviews, you have less time for each participant, and such focus groups are not sufficient for sensitive topics. You can imagine that not all people are willing to share, for example, health problems or that kind of topics. And then we have card sorting. This you can do a little bit more qualitative or a little bit more quantitative inside an online survey, or with the participant within an interview, for example. So when doing card sorting, you let the user or the participant categorize different categories, so that you in the end have a perfect structure of your app navigation, for example, or of your navigation structure of your online shop. So you really let the participant sort categories, for example, of an online shop, like female fashion, male fashion, women, men, and then, for example, accessorize or this kind of stuff, so that you have in the end the perfect arrangement which comes from user feedback, and you can take this arrangement of categories and translate it some kind of in your navigation structure of your app or your online shop. So an advantage is that you have in the end a cluster of categories really out of the user's perspective, and you have concrete wording suggestions. But a disadvantage is, of course, that you don't have, you don't have a finalized website structure. It's only the beginning, only the categorization. And for participants, it's sometimes really overwhelming because you're not interacting with the product. You're just speaking theoretically about categories. And this is sometimes difficult for some participants, for some people. Okay, so this was the brief deep dive into the different UX methods. So now I want to explain to you how does a typical UX project look like. Actually, it's kind of comparable when customers come to us. They have always request like, how can we optimize user experience, or how can I optimize user experience of my app I've just invented. So the requests of the customers are kind of always going in the same direction. And of course, we know how to optimize user experience. And I will show you how we did this in a project we had with a waste management company. So in the beginning, there was the waste management company, and they had the request, how can we optimize user experience? And you can imagine that the waste management companies has really a lot of products and services offered for their user. And they were really interested in future ideas. So they wanted to invent new ideas, new products, new services for the future, so that they still stay kind of modern. And yeah, this was the overall request in the beginning. And what we did, we first conducted workshops to create ideas. And we conducted the workshops with the employees of the waste management companies. And in the end of these workshops, we had kind of, I think, 70 ideas, which we prioritized, so that we, in the end of the workshop sessions, we had only like 8 ideas. And these 8 ideas we discussed within a focus group. So we invited real users of the waste management company, and so we invited the real target group of these ideas, and we presented them the idea concept, and they assessed it within a group discussion. So at the end of this focus group, we had the user feedback, so that we could optimize the ideas based on this user feedback. And what we did then was we did another workshop to develop prototypes of these ideas. So we really built, for example, part of an app in this case. And after that building session, we again invited some users out of the target group, and we did UX usability tests to really test the prototype. In this case, we did it offline. And you know here, or you see here, that we in different steps we included or we involved the user feedback and the user him or herself. And this is really the clue when you're thinking about how to gain good user experience. And this is the thing you have to focus when you are inventing or developing new products and services. So always involve your users at certain steps in the way of product development. Okay, so do you have any questions?
I'll also check the live stream.
Mm-hmm.
Not seeing anything on the live stream. I do have a question though.
Okay.
I was wondering, when you're talking about focus groups,
Mm-hmm.
how do you choose who's in that focus group? Do you look for any kind of diversity in the focus groups, or how do you go about creating those?
Mm-hmm. So like the foundation is always the specific target group of the product you have to or you want to test. For example, when you have a finance app, which is managing your depot and your stocks and so forth, then you would invite people who are using or who own stocks, so that they have kind of an imagination how that could work in an app. So it does not make sense to maybe invite someone who don't do that finance stock management. So this is important, but within that target group, as you said, we are looking always for a good mixture of people, that they are diverse. For example, the gender diversity, that the age is diverse, that you don't only ask young people, you don't only ask elder people. This is then important, but first step is kind of defining your target group, and within the target group, you want to then ask with a certain diversity.
Awesome, that's really interesting and good to know. There was another question in the chat. How would one go about requesting data that one may need to build an app? So I think, Fernando, if you want to clarify a little bit, are you talking about like from the focus group, like if there's a request that you have for like an app, how would you go about to do that? We'll just see if he can clarify a little bit.
Yeah, this would be helpful, because I'm not sure if I get the question right. So what kind of data do you mean when you're thinking of building an app?
Not sure. Say you wanted to build a safety app to keep kids safe.
Okay.
So how would you go about figuring out what kind of data you would need to build that app?
So what kind of requirements the app should fulfill?
Yes.
I would ask the target group. So I would ask parents, for example, and parents who are interested in a safety app, maybe in general. And then I would really do interviews and ask them what they need in the app, what they can imagine, what is important when thinking about safety of their children, what did they had maybe in the past dangerous situations, which can be solved with the app. And this is how you can understand the user group more and more in detail, and then you have the picture or the imagination how to build the app and what features should the app offer, what functions should the app offer. Then you I would suggest to then build a prototype, and in the end you should test the app again. And this is then the kind of iterative research we would suggest and we would recommend here. No worries. Thank you for that clarification. I hope that that was helpful. Was this exactly this what you meant? Okay, perfect. Thank you.
Great. Well, I know that we have our next speaker just about ready. Are there any other questions before Pia heads off? I think that might be all. Thank you so much, Pia, for your time. I think this was a really informative talk and should definitely help us in the future with our UX research. So thank you so much.
Yeah, I hope so. I hope so. Thank you. And if you want to copy contacts, please do so. You can visit us online as well. And I just want to thank you and have a great day. Bye.
Bye. Thank you. All right. So next up, we have Dr. Laura Kreidberg. I'm just making sure that she's able to join from her tech check. If you just give us a moment. All right, one moment here. All right, I see that Dr. Laura Kreidberg just joined us. Hi, Laura, how are you?
I'm good. How are you?
I'm very good.
I am trying to start my video here and it says host has stopped your video.
Let's see if I can change that. I cannot. That is interesting. Oh wait, I can, it just won't. Okay, hold on. I will work on that. If you would like to start with your introduction though, I will work on.
Yeah, sure. I think I can still share my screen. So let me just get right into it. Hopefully you can see my screen even if you can't see me. All right.
Oops, sorry about that, dog.
No problem. So how about that? Can you see my screen?
Yep, we can see it.
Okay, cool. Yeah, if you can't see my face, that's all right. Yeah, so thank you so much for inviting me to speak at this event. I'm excited to talk to you about some of the exciting new developments in our study of the atmospheres of extrasolar planets. So this is a quick talk, so I'll get right into it. Probably a lot of you are familiar with exoplanets at some level. These are planets that orbit stars that are not the sun, so planets around other stars. And the very first exoplanet was discovered in 1995. And since then, we have discovered over 4,000 other exoplanets around other stars. I'm showing in this figure on the right how many planets are discovered every year, and you can really see how much the pace of discovery has accelerated over the last couple decades. So if you break all this down based on how many planets we have found and how many planets and how many stars we have searched, we know that pretty much every star out there has at least one planet, which is so exciting. The importance of this discovery was recognized with the Nobel Prize awarded in 2019 to Michel Mayor and Didier Queloz. I want to just make sure that you all can hear me. I can't see anybody. So can I get like a...
Yes,
okay,
we can see everything.
All right, just checking. I wanted to make sure I wasn't just talking to empty space. All right, I'll see if I can start my video too.
Yeah,
nope.
I'm looking up how to start the video, but everyone can see your screen and hear you just fine.
Okay, cool. Good. So, right. So here we are today. We know that almost every star out there has at least one planet around it. And we've learned already that exoplanets are a lot more diverse than the planets we know and love in the solar system. So here is a plot showing the mass of the planet versus how far away it is from its host star. And the points are color-coded by how they were detected. You'll see the solar system planets in black. And just to note a couple of really interesting populations of planets that we've discovered so far, we've seen a lot of planets with very short orbital periods. They're very close to their host stars, which makes them very hot. I think the current record holder is a planet that orbits its star in less than 7 hours. And so that's so hot that the surface of the planet is expected to be melted into lava. Probably not a very nice place to live.
Laura, you can start your video now, by the way.
Okay, cool. Let me do that.
There
Hello.
you go.
Cool, that makes it easier. So we've also discovered a lot of planets that are intermediate between the Earth and Neptune in size. We're currently debating whether these things are like scaled up versions of the Earth or scaled down versions of Neptune. So there's a lot of discussion right now about what they should be called. We've also seen really huge planets, as much as 10 times the mass of Jupiter. And these things are really on the border of what we could normally consider a planet versus what we would consider a star. There's also a whole bunch of oddball planets. I won't get into all of these, but just a couple of my favorites are planets with very eccentric orbits. So rather than being a circle, it's like an oval. And some of them get very, very close to their host stars and then zoom around and move far away. We've seen another class of planet that is very appropriately named super puffs. And these planets are so large that their average density is similar to that of cotton candy. And there's also a whole part of this space that we haven't yet had the time or sensitivity to explore. And that includes most of the solar system planets. So I think there's still a lot of really exciting stuff yet to be discovered. Okay, so now that we've found all these planets, one of the most exciting next steps is to characterize their atmospheres in detail. By studying the atmospheres of planets today, we can learn about their formation conditions and how they evolved over their lifetimes, what their atmospheres are like in some of these really extreme environments, these short orbital periods. And ultimately, our really, really big question that motivates myself and a lot of other astronomers is whether we can search the atmospheres of Earth-like planets to find signatures of life. So really quick, I'm going to get you up to speed on how we actually characterize the atmospheres of planets. For planets that pass in front of their host stars, this is called a transit. A little bit of the starlight will filter through the planet's atmosphere during the transit. It can get absorbed or scattered there. At wavelengths where the atmosphere is more opaque, more of the starlight is blocked. And so this technique is sensitive to the chemical composition of the atmosphere, the temperature structure, and also the presence of clouds or haze. To make this a little bit more intuitive, here's a really cool picture of the Earth taken from space. That's the moon in the background. This is an infrared image, so it doesn't look exactly the way it would look with our eyes. If you move a little bit farther into the infrared, just 1 micron farther red, you can see that the Earth looks different. It looks bigger. And that's because there is a lot of absorption by ozone in the upper atmosphere. And so this is exactly the effect. If you toggle back and forth here, this change in size is exactly the effect that we are searching for extrasolar planets. Okay, so in my work, I'm very privileged to use the Hubble Space Telescope for a lot of what I do. Hubble is a fantastic facility for atmosphere characterization because it's out of the way of Earth's own atmosphere. So there's no way we can get mixed up about whether the atmosphere we're seeing is on a distant planet or right nearby, close to home. This is what raw Hubble data looks like. And perhaps of interest to you guys today, this data is publicly available for free on the Space Telescope archive. If you Google Space Telescope Science Institute Hubble data, you'll find the link where you can download images just like this. This is a spectrum of a hot Jupiter. And the light is dispersed from bluer to redder light, left to right. And we also smear out the light along the detector so that we don't saturate Hubble's really sensitive instruments looking at bright stars that were not really in the, were not what Hubble was designed to look at. It was designed to look at very faint, distant galaxies. So Hubble data are pretty messy when they first come down. You just download this from the internet. And if you measure the brightness of the star over time, you get something like this. The different data, the different colors correspond to different times when we went back and looked at the planet 3 times in this case. There are big gaps in the data, and that's because Hubble is orbiting the Earth. And so every hour or so, Hubble is actually behind the Earth and you can't observe the star that you're interested in. But if you look carefully at this, you can see that there's a pretty big drop in flux in that 3rd chunk of data. That's the 3rd orbit. And indeed, if you clean this up, this is the very same data that's been post-processed through the careful work of a graduate student. In this case, it was me. You can see a beautiful transit of a hot Jupiter that's passing in front of its parent star. Okay, so for the rest of the talk, I'm going to walk through a couple of really exciting discoveries, and then I'll finish up with where I think we're going from here. So one discovery that I'm really excited about is evidence for clouds in exoplanet atmospheres. We know that all of the solar system planets that have substantial atmospheres also have some type of cloud or haze. And so a big question for exoplanets is, do they also have clouds, and what kinds of clouds are they? Typical signature of clouds is a very flat spectrum for your planets. We'd measure the planet to have almost identical radius over a big range of wavelengths, and that's because the clouds are blocking the transmission of light through the atmosphere. So here's a really famous example. This is a mini Neptune. It's about 2.7 times the radius of the Earth. It's also pretty toasty. It's 550 Kelvin. And we measured for this planet a very, very flat spectrum, so flat that there have to be high altitude clouds or haze in the atmosphere to explain the data that we measured. The clouds would have to be very, very different from the clouds on Earth. One weird thing about them is that they have to be very high up in the atmosphere. This red blob on this figure is showing the pressure level, how high altitude the clouds are. And they have to be about 2 orders of magnitude lower pressure than the clouds on Earth. And so that's much, much higher up even than the highest flying airplanes on Earth today. Not only that, but the clouds have to be made out of weird stuff. So this planet is, like I said, about 500 Kelvin, which is too hot for water to condense into clouds like we see on Earth. But at these temperatures, you can get condensation from minerals like potassium chloride or zinc sulfide. So we think maybe that's the culprit for the flat spectrum on this planet. Just for fun, this is what color the planet might be. For 2 different cases. So it's orbiting a smaller, redder star than the sun. So if you illuminate the planet with red light, you get this top row. If you illuminate it with sun-like light, you get the bottom row. But for most of the plausible cloud cases, the atmosphere would be kind of a brown or green color. So maybe not the most beautiful planet of all. Okay, so I want to talk now about a different type of observation that is really informative about planets. This is my personal favorite kind of data that we can get. And this is called the thermal phase curve. And the idea here is that as the planet orbits its star, if it's very close to the star, the gravity from the star holds one face of the planet, always facing the star, just like the moon has one face that's always pointed at Earth. This is called tidal locking. And so in this case, the planet has a hot side and a cold side. And as it moves around through its orbit, we see different faces of the planet. So here we have the hot side rotating into view. Pretty soon the planet will come back around and be eclipsed by the star. So you get this characteristic drop in brightness. And then the day side rotates back out of view. And so with this type of data, we're really sensitive to the climate of the planet. We can tell what the temperature differences are in different regions, different longitudes of the planet. And so I applied this technique to a rocky planet and measured a phase curve that looks like this. So just like you saw in the cartoon in the previous slide, here in this plot, you can see an increase in brightness over time. That's as the hot day side rotates into view. There's this big drop in the middle as the planet passes behind the star. And then as the day side rotates back out of view, you get a dimming again. This is data from the Spitzer Space Telescope, which is also publicly available. And so what does this actually mean for the planet? Well, in this case, we think that the temperature difference between the day side and the night side is so extreme that the planet is likely to have no atmosphere at all. The idea here is that if you have a thick atmosphere on your planet, like Earth or Venus, it is good at circulating heat. So you can have wind blowing from the day side to the night side that helps homogenize the temperature difference between the two hemispheres. But in this case, this planet has a temperature difference of at least 500 Kelvin. In fact, the night side temperature is consistent with 0, which means that little to no atmosphere is present. And so that's a little bit sad because I'm personally rooting for atmospheres on all these exoplanets. But it's really cool that we've been able to make a measurement for the first time that can tell us yes or no, the planet has an atmosphere, or in this case, it does not. Okay, so the last frontier I want to talk about is our search for water on planets outside of the solar system. And this is a really interesting question, how much water planets typically have, because we think water is not only an important building block for planet formation, but also an essential ingredient for the presence of life. And so a lot of my work has been focused on searching for the signatures of water absorption in exoplanet atmospheres. And here's a case that I like a lot. This is a spectrum of K218b. I call this planet an Earth cousin, not an Earth twin, an Earth cousin, because it's a little bit bigger than the Earth. It's about 2.7 times Earth's radius, but it has almost identical temperature to the Earth. And lo and behold, if you measure the size of the planet at different wavelengths, you see this big bump that I'm pointing to with the arrow. And that bump is characteristic of water absorption in the planet's atmosphere. So this is a very strong detection of water on a planet that is in the habitable zone. Not only that, but we think that water is in general very, very common. Here is a kind of a family portrait of a bunch of planets with well-studied spectra. Most of these are big planets like Jupiter, but they're ranging all the way down to the size of Neptune. And we have found signs of water on, I think, close to 20 exoplanets at this point. And we're pushing down to planets that are similar in size and temperature to the Earth. So far, no water detected yet on a truly Earth-sized planet in the habitable zone. But we're working on it, and it's really heartening to see that we find water in a lot of other planets that are a bit bigger or a bit hotter than the Earth. So to give you a feeling for what is next, we've already made enormous progress in our study of exoplanet atmospheres with Hubble, with Spitzer. We're working now on getting a complete census of all of the planets that are nearby, that are easiest to study. So Kepler did a deep search in a fixed patch of sky. We've now moved on to the TESS mission, which is a recent NASA Space Telescope that was designed to survey the entire sky, searching for planets around the nearest and brightest stars. In just a couple of months now, the James Webb Space Telescope is scheduled to launch. And this telescope has been decades in the making. It is the successor to Hubble, but it is bigger and better and more powerful in all kinds of ways. So I'll show a little teaser of the type of data we can expect from James Webb a couple slides from now. And then finally, over the next decade or so, we're making progress from the ground. And there's also a dedicated atmospheric characterization mission being launched by the European Space Agency close to the end of the decade. So lots to look forward to. And just a couple of examples. Here is the type of data we're expecting from James Webb. On the right, I'm showing a picture. This is what James Webb looks like in the lab. It's a 6.5 meter diameter mirror compared to Hubble, which was just 2.7 meters, so much bigger collecting area. James Webb will also have a sun shield that will block out any heat from the sun and allow us to search for the signal from very cold planets, cold meaning similar in temperature to the Earth. So we expect that James Webb will really push forward the progress on characterizing the atmospheres of Earth-sized planets. And here is some simulated data for a hot Earth for a couple of different atmosphere models. We don't actually know what to expect for these atmospheres because we haven't been able to explore them ever before. So we use the solar system as inspiration here. Here we use Earth, Venus, and Titan as models. And so these atmospheres would have different dominant chemical constituents. So an Earth-like atmosphere would have a lot of water. Titan would have a lot of methane, and Venus would have a lot of carbon dioxide. And the black points are simulated data from James Webb, and you can see that you can start to distinguish between these different models. So we'll be able to get a first idea of what the composition of Earth-like planet atmospheres is. We're also really pushing forward from the ground, and here's a cool simulated data set from the extremely large telescope. This is something that is being built in Chile with first light expected for the late 2020s. And with a 30-meter diameter mirror, it is possible to directly image an Earth analog. So here's the picture on the left is showing some simulated data where that little white dot to the right of the yellow X is the heat coming from the surface of a nearby Earth analog. And finally, this is my last slide. A really big question that I talked about at the beginning is detecting biosignatures in the atmospheres of Earth analogs. So we'll see a lot of progress over the next decade about are there atmospheres present or not? If there are, what are their main constituents? Is it a CO2 atmosphere? Is it a water atmosphere? But the next level of detail is a huge, huge, huge challenge. And we think that if we looked at the Earth from far away, the smoke and gun evidence for life would be disequilibrium chemistry, and particularly the simultaneous presence of oxygen and methane in the atmosphere. Normally, those two things would react with each other to form something else. But in our case, we have life that is producing both of those gases in abundance. And so this is the type of signature that we're interested in searching for on exoplanets. And to do this, we need a next generation space telescope. So there are a couple of mission concepts that are currently under discussion. But I hope that one of these is selected so that over the coming decades, we'll be able to build up a sample of 50 or even 100 Earth analogs with really fantastic spectra, so that we can learn about what our place is in the universe, whether Earth is really special or whether there are a lot of other planets like ours that also host life. All right, so I want to leave a couple minutes for questions. I'll stop here, and I'm happy to chat for a couple minutes before our next speaker.
Well, while we wait for any questions to come in, there was a a question, but I'm not sure if it's super relevant. But someone asked about the wavelength of the ocean.
Okay.
I think they're referring to like an ocean on a planet.
Mhm.
What would that look like? Or can you tell us anything more about wavelengths of oceans?
That's a good question. There have been some studies about what ocean glint would look like if you have like forward scattering off of a reflective water. And that's something that may be detectable in the far future, not with any telescope that's currently being built, but maybe next generation. Um, yeah, so in general, when you look at the atmosphere of a planet, you don't see all the way to the surface unless the atmosphere is very thin. So if you had an atmosphere like Earth's, you wouldn't see all the way down. And so you wouldn't be sensitive to those ocean features, but rather the gases that are in the atmosphere.
Awesome, thank you. I'm gonna double check the live stream one more time. Okay, I have a question. I'm wondering, in astronomy, there are so many things that you could possibly study, right? You know, we have stars, we've got planets, we've got asteroids, meteors, lots of things. What made you choose exoplanets and this type of study? And really, like, how did you get started finding the Max Planck Institute for Astronomy? I know that's a large question for
That is
only a
large
few minutes,
question.
but
Yeah, I can try to give a quick answer. Yeah, I mean, I what like what attracted me to exoplanets is that there's so much that's unknown. Like it's really rare in science to have a field that is this new. And so people have been working for a long time on galaxies. They've been working for a long time on like the origin and ultimate fate of the universe. And I love those questions too. But I was most interested in tackling something where I felt like the biggest discoveries were yet to be made. And that is, I've like with exoplanets, I talked a lot about all the things we're looking forward to. And I feel like we've made a bunch of progress so far, but there will be like one telescope after another for the next 10 years at least, which will really open our eyes to what exoplanets are like. So I thought that was really cool to work on.
amazing. There are 2 minutes left. I'm not sure if you're able to maybe a good way to get in contact with you, or if anyone wants more information on the Max Planck Institute for Astronomy.
Yeah, so you can see my Twitter handle in the bottom right-hand corner. So that's always one way to get in touch with me. You can also contact me by email. So my email address is just my last name, Kreidberg at mpia.de. You can probably tell by my accent that I'm definitely American, but I moved to Germany in July of last year to start a brand new department that is all focused on exoplanet atmosphere characterization. So we are like we're hiring. Yeah, my vision for my department is to bring together a critical mass of exoplanet atmosphere experts. So that's observers, that's theorists, that's instrument builders, that's people who work in the lab, because these questions are interdisciplinary and really challenging. So I'm excited to be building a team here in Germany to work on it.
Awesome. Well, thank you so much for your time. This was an amazing presentation. Yeah, thank you so much for taking the time out of your day to speak at our symposium.
Yeah, my pleasure. Happy hacking. And,
yes, thank you.
And thanks again for inviting me.
Thank you for coming. All right, guys. So we do have our next speakers lined up. So we have Riccardo and Francesco. They are both here from Italy, and they will be talking to us today about PoliSpace. And PoliSpace is a student approach for enabling the growth of the Italian space workforce. They're both going to present together. And then afterwards, Francesco is going to talk about a little bit more about his company at 9:30, and I'll leave that to him to talk about himself. But beyond that, I do see that they are on the call. So Francesco and Riccardo, if you'd like to take over, go ahead.
Yeah, sure. Thank you so much for your introduction, and thank you for inviting us today. So as you said, I hope you can see the screen. Welcome everyone. Today we are going to talk about PoliSpace, which is the first space association of Politecnico di Milano. So a bit of an outline. We will be presenting the history of PoliSpace, then highlight the structure and some stats for the association. Then we'll be explaining the departments, so the internal functioning of the association. How do we enable the space workforce in Italy, but also around the world, and our CubeSat team, and then conclusions. So as you can see, the history of PoliSpace starts in 2020. Me and two fellows decided that something was wrong in the university, because we were not able to make practical activities. And in fact, this is found also in literature. You can see that 42% of Italian students are prepared with insufficient practical experience. So what did we do? We actually spread a survey amongst Politecnico di Milano students in order to understand the needs of this new framework in which to work in. And we obtained a very good response, more than 800 applications, and we obtained 96% of participants that were interested in a space club at Politecnico. So this gave a big boost to the project, and we started actually designing the structure and the logo that you can see on the right. The logo is strongly symbolic, so there's a planet representing the internationality, the Milan Cathedral that represents the place we are lifting off from, and you can see the arrow. It's actually the wheel to explore space, and the hexagon, like solidity of the association. As you can see in this timeline, on September of 2020, we had our first board meeting after we spent basically all summer recruiting people. Then we had a lot of stuff like recruitment for a challenge, several webinars, but we will be talking about this actually later more in detail. So let's say something about the structure. So the structure of PoliSpace is shaped as a small, medium-sized enterprise in order to actually deal with all the different aspects of the space domain. So as you can see, we are divided in executive members and ordinary members. Executive members are basically the leads of the association and are divided in 5 departments: human resources, marketing and communication, legal, project, and business and finance. All of these departments have a head which joins the board together with president, myself, treasurer, and secretary. So the ordinary members can be actually active or passive depending on their will. So they can join what we call temporary divisions, which are basically the projects that PoliSpace incubates. We for sure have also a relationship with external entities. In fact, we invite you to reach out to us in order to establish a collaboration. As you can see, we try to manage to have a balance in the gender. This is a hard task because it's the STEM field is strongly biased, but at the same time, we are proud that we can keep such balance somehow. As of today, we are more than 130 members spread in different sections of the association. So let's talk more about the departments themselves. We have a legal department, as I said. So what does it do? Basically, it handles the bureaucracy, it deals with legal issues in the pre-launch phase, because our plan is to launch in space and we need a lot of legal support for it. And of course is responsible for the GDPR provisions and other legal things. Then we have a project department. So the project is actually split in permanent and temporary divisions, as I said. So the permanent divisions are basically the activity organizers. So they organize all the webinars and the tours and visits to companies that we might have. And then we have temporary divisions, which directly corresponds to the incubator projects, basically. And we have also in the permanent divisions the Space Explorer, that are basically the project manager of all the projects we have incubated. Basically, they also manage the technical aspects for the incubator project. So if the incubator project needs some expertise, they reach out to these guys and they provide this supervision. And then we have business and finance, which is a very interesting one, because they deal actually directly with companies external to PoliSpace, which is a student association, non-profit. So they have a content manager for each company, and they are in charge of build sponsorship bundles, playing fundraising in order to obtain benefits from from companies and give something in exchange, which usually is workforce. And they also manage this project as a service protocol that will be explained more in detail later. So basically, the company reach out to us for a project, and we can give some workforce to have it developed. And the other two departments we have are marketing and communication and human resources. Marketing and communication is divided in 4 sections. So photo, video, copywriting, infrastructure, and social and graphics. Obviously, photo, video actually takes some recordings and some photos in order to keep the memories of the association throughout the years. Copywriting is a very interesting one. These guys are in charge of updating some news on our website, of handling the newsletter, and they also write actually the captions for our social posts. Whilst the infrastructure is basically the IT manager, so they manage the internal communication of PoliSpace. They manage the website, they manage our communication platforms like Slack, Teams, and our clouds. And then social and graphics, self-explicative, but these guys are amazing. So they actually prepare all the presentation, including what you're seeing now. They deal with video editing. They are behind the scenes when we organize webinars, and they post on social media and actually reply to any question you might have. The Human Resources Department exists because we gave this asset to PoliSpace as a company. So what we asked for is actually a CV and motivational letter to hire you. It's not that easy, and only Politecnico di Milano students can be part of PoliSpace. So they make a screening, meaning that once they receive the CV and motivational letter, they give a mark for it. And if you're successful, you undergo the process of recruitment. Of course, the Human Resources Department is in charge of checking the health of the association from the open roles point of view, and also from the morale standpoint. The recruitment process is basically standardized. So actually students submit the CV and motivational letter, they got this evaluation to access the executive member panel. Otherwise, if you want to enter a project, usually there's a test before the submission of your docs. As of today, we received more than 600 application in overall. And now I'm leaving the floor to Riccardo to let him explain more about how do we deal with the space waffles.
Yeah, thank you very much, Francesco. So the main goal of PoliSpace is to enable the creation of the space workforce of the future by filling the gap between the professional world and academia. And while this is most beneficial for the PoliMe neighborhood, the significant number of international students that are present in the association and at PoliMe ensures that the influence of PoliSpace is very much a global phenomenon. So this PoliSpace approach, by bridging the gap between these two worlds, is threefold. As you can see on the screen, we have the outreach and training, the industry exposure, and the hands-on experience. So starting with the training is mainly conducted through scientific articles that we publish on our website and webinars that we provide almost once per month during the academic year. And while the majority of them were open to everyone and were done through the software StreamYard and then published on our YouTube channel, we started organizing some closed events done through WebEx where only PoliSpace members were allowed. Here in the screen, you can see the list of our webinars, and some examples of open events are the one with the founder of Moonshot, Troy McCann, on how to create a successful space startup. And we actually had just one closed event that was with Giuliana Rotola about space law. Next, please. Thanks. So the PoliSpace network started from the personal networks of its members in the early days of development of the association. And through this personal networking and heavy social media presence, the association was able to gain further connections in larger companies and build the portfolio of supporters and collaborators it possesses today. The current sponsors of PoliSpace are split into two main categories, companies and organization. Starting with companies, I can give some examples. Firstly, Sidero Space. Sidero Space is an Italian company that is developing a new generation CubeSat launcher, and they allowed us to deliver our CubeSat in space in one of their first launches. And since commonly the most expensive part of the development of the CubeSat is the launch itself, this is a really fundamental sponsorship for our project. Then we have Primospace that has a shared network of knowledge with us. We have Hisatan that gives us a thermal control software for the Mars Sample Return mission and the CubeSat projects. I will talk about these two projects later on in my presentation. And then we have like ANSYS, who gives us numerous licenses for software packages for the CubeSat to meet the ESCC standards. And then we have some organizations, as I said before. Firstly, obviously, we have Politecnico di Milano, which provides spaces, labs, and supervision on projects. We have the Intercollegiate Engineering Alliance, that is a cluster of engineering alliances, associations from prestigious universities, which provides us networking opportunities. And then we have Astrospace. Astrospace is one of the most important Italian websites about the aerospace sector. And they agreed to publish specific articles from PoliSpace on their web domain. And this helped us to reach numerous institutions and businesses and obtain new partners and support. And yeah, one of the drivers that led to the association establishment is to provide students with hands-on experience. These projects have the unique attribute of being organized by students for students. So the Space Tech team, as Francesco said before, is responsible for the organization of these projects, for which we select members from Politecnico di Milano based on their academic experience, soft skills, and enthusiasm. So these hands-on projects are carried out in 3 ways. PoliSpace members can propose a project they are interested in through a specific page on the PoliSpace website. And after a successful evaluation of the proposed activity, PoliSpace will provide support to them in building their team and delivering the expected outcomes. Another way to join PoliSpace hands-on projects is by applying for a position. In fact, we regularly open new calls for applications that are related to the programs selected by the SpaceX team, and students can apply and, after being selected, work on that project for the whole duration of it. Lastly, as Francesco mentioned before, companies can ask us to develop a specific project for a non-critical activity. PoliSpace will then take the responsibility to structure a team and start working on the task given, saving the company time for developing the project and recruiting the people. In exchange for our commitment, the company can give us components or funds. An example of a hands-on project we have carried out is the Mars Sample Return mission. We have recruited a team of bachelor polymorphy students to join an AIAA competition, and their task was to develop a project for a space mission to collect samples of Mars ice from the planet and take them back to Earth. Actually, we are really proud that a paper about the project was accepted for presentation in the upcoming Mars Exploration Symposium at the International Astronautical Congress in Dubai. So at the very beginning of the association, a survey was done among all the students who supported us, and we asked them which project they wanted to see developed by us. The results showed that they chose the CubeSat as this project. And for this reason, we have started settling the team for the CubeSat, and the structure of this team is shown here in the slide. We have the leadership team that consists of 5 team leaders, 3 system engineers, and 1 project manager. Each team leader was assigned to a different system that are attitude and orbital control, structure, onboard data handling, electrical power, thermal control, and guidance and navigation. The CubeSat leadership team, following at first the roadmap above mentioned, performed further research on the proposals given by the Space Tech team and came to the final payload configuration, which included 3 different missions. In-flight testing a special type of solar cell provided by Cambridge University, a structural battery supplied by an Italian startup, and a water vapor propulsion system designed and built by the company's Streamjet Space Systems. For this reason, our CubeSat was named 6S, over spinning sun-synchronous satellite for station keeping, structural battery, and solar cell testing. We always receive full support from the university regarding laboratories, access to facilities for meetings and working sessions. So talking about our future steps, PoliSpace this year will be involved in the Rascal competition, an annual challenge organized by NASA. In our case, the association will take part in the competition, supporting the team from the Embry-Riddle University, led by Professor Davide Conte. Space Tech will organize a new call for application to give students the possibility to apply for a number of international projects include ESA-Fly and Launch Your Thesis programs, T-Tech competition, and AIAA undergraduate and graduate design competitions. Next, please. So, after 1 year of activity, the PoliSpace approach results can be seen in this slide through collected data of the mentioned activities. As said before, we incubated 2 projects, the Mars Sample Return Mission and the 6S CubeSat. And for all the position we have opened from the very beginning of the association, we received more than 600 applications. Right now, PoliSpace counts 132 members with different roles inside the association. And moreover, with more than 10 nationalities among our members, the PoliSpace family shows to be multicultural. For this reason, even though the association was born in an Italian environment, the PoliSpace approach is having an effect on the workforce in a global manner. So thank you very much for your attention. Right now, we will leave 5 or 10 minutes for some Q&A section. If you want to reach us after this presentation, we'll leave in the screen our website and our email address. And thank you again for your attention. Francesco, I don't know if you want to add something right now.
Yeah, thank you, Riccardo. I just wanted to say that you're very welcome to reach out to us for any question, both now and in the next days. Just bear in mind that we are always open to partnerships with any companies, and we can see what we can provide in terms of workforce, in terms of interested students and brilliant minds. So thank you still for your attention.
All right. Does anybody have any questions? You can either ask in the Q&A or in the chat. And I will take a look over at the live chat. 1 second. Well, there goes my Slack. Okay, I don't see anything coming in, but I do have a question that I do like to ask people who run organizations such as PoliSpace. But what inspired you to kind of get started in this and to be so involved in this? Was this something that you dreamed of when you were younger? Was this something that came to light later in life? But what inspired you to get involved in PoliSpace and to continue working with it?
This is a very cool and valuable question. Thank you. So basically, it was not a dream. It was just a need. And I think that it's so successful because we really targeted a need. When we started our university path, we were pretty convinced that we had the chance to work on practical projects. But then it turned out not to be true. And this is a big limit of the Italian university sometimes, in the sense that there might be a crowded course that does not allow professor to bring you in the lab and to show everyone how things works in reality. So we just grasped the need and we asked ourselves what we can do to actually improve this situation, to make students feel they have this hands-on experience that, you know, sometimes it's required from companies that want to hire you. Sometimes you find in a job offer like 3 years of experience required. Well, not all of us have the chance to get these 3 years of experience, but at least in this framework, you can train yourself and reach some milestone for your engineering skills to develop. So to finalize the answer, it was more a need than a dream, and it started developing, this need started developing once we joined university. But the passion for space was always with us, like it's a constant. And I think this is also for Riccardo. I don't know if you want to add something.
Yeah, I'm really happy that you decided to find this association, because as a university student that found this opportunity with the Politecnico di Milano, with a Politecnico Milano email, I found this opportunity, and I really wanted to be part of this amazing association, because yeah, I found really the need of get closer to the professional world of the space sector and do something more practical about this. So yeah, for this reason, thank you, Francesco, because this this association is really important for the students.
Yeah, I'm definitely jealous that my university didn't have something like this. Definitely would have been helpful over by me. Well, congratulations, guys. This is an amazing organization, an amazing opportunity for students. I'm not seeing any additional questions coming in right now, but I don't know if you guys have any last thoughts before I introduce Francesco's talk.
Yeah, I just want to say that, of course, we cannot welcome students from all around the world. I mean, students enrolled in other universities rather than Politecnico. But of course, you can interact with us. If you go on our website, there is a section, and you can become an external collaborator for the association. This means that you can offer your expertise for the projects of PoliSpace to be developed, and you can actually be called on demand and become officially an external collaborator for us. Moreover, if you have a company and you are interested in a partnership, just send an email or just compile the form that you can find on your website, and we'll be promptly replying to you. Thank you so much for listening to us.
Yeah, and thank you so much for inviting us to this event. We are really happy to have this opportunity to share and present our association to this audience. So thank you very much.
Yeah, thank you guys for coming. Awesome. All right. Well, it looks like we do have 2 minutes. So Francesco, I don't know if you need to get a glass of water or anything, or if you're ready now for your next talk.
No, I'm pretty ready. So if you want, we can start.
Awesome. Okay, yeah. So Francesco is going to continue to talk about and I want to make sure, am I saying it right? Is it Walle?
Yeah, it's Walle. Yeah.
Walle. Okay. So Francesco is going to be talking about Walle, which is a project that works towards an advanced air mobility ecosystem in Italy. And so Francesco, I will let you take the floor.
Thank you so much. Just 1 sec to share the screen.
Sure.
You can see it.
Yep.
Perfect. Okay. Again, hello everyone. I am Francesco. I am the CEO of Walle Mobility, which is a company based in Brescia, Italy. And again, thank you to Katelyn and all the organizers to host us today. I'm happy to be here, explain to you what ecosystem we are trying to create in Italy in order to enable urban air mobility. Go vertical, go up. This is our motto, and you will discover why in a few minutes. So, how many times did you experience this scenario? So this crowded scenario, this traffic jam, this problem, and I'll tell you a story. So basically, the idea of Walle was born when I was trying to travel to the airport from the city center. So I decided to take, you can see on the right, like metro, and then I went for a taxi. But at the end, I found myself to be like the guy in the bottom. So looking at my flight departing without any chance to take it. Why? Because I was late. We were stuck in the traffic jam, and I saw my flight departing, and I was like, oh, now there's a problem. How can I try to solve this problem? What is the solution that can bring me from this point to the other without waiting all the time, stuck in the traffic jam, and make sure that I don't lose my flight another time? So this is not the only problem we have in the world. We have several problems that are related with, for example, world population. So by 2050, we will be more than 10 billion on Earth. And the 2/3 of these people will be living in crowded towns. This means that our mobility system will strongly influence the way we move and the way our city will appear in the future. Another relevant data is the hours lost per year. For example, if we take Milan, in average, a citizen will lose 226 hours stuck in traffic. And this is more than a week, guys. So you're wasting 1 week of your year just waiting in your car and maybe listening to radio and wasting your time. $87 billion is the lost productivity before the COVID era due to traffic jams. So this means that it's more than $1,000 per driver. These are astonishing numbers to me. And 50 billions are the tons of CO2 that we emit every year worldwide. So very serious problem. But this very serious problem has my minor problem of losing a flight have a unique solution. And this solution is to establish a service based on high shuttles for cargo and passengers across the nation. This has been done in the US, but the mission of Walle is to enable this transport system in Italy. How? So we'll have a fleet based on VTOL technology. VTOL stands for vertical takeoff and landing capabilities. This means that these vehicles can lift off and land on very, very reduced spots, but we will see later because they have this vertical flying capabilities. And then these vehicles will be flying in the 0-300 meter altitude range. And of course, at a competitive cost. We see later what does this mean. Walle will also deal with vertiports management. Vertiports are the spots I was talking to you before about, and most importantly, will be guaranteeing speed, comfort, and low emissions. So let's see more about the service that Walle provides, Walle Air. So Walle Air is a service that has a triple mission. So you can access a cargo service, you can access an airport shuttle service, and a city's connection service. Let's explore more. So cargo service will be the first to be launched in 2024. This service is aimed to connect strategic logistics spots across Italy. So we have very, very big logistics area across Italy and also across cities that need to transport their goods daily. So our aim is basically to connect these spots such that they can improve their logistics. A second service, it's the airport shuttle. So basically, you could move from the city to the airport like it's a shuttle, so it's point to point. And this service is meant to start in 2026. Whilst for the city's connection, we mean to connect the neighborhoods of a city efficiently enabling faster and greener travels. So we have a fleet that enables this operation, of course. It's a multi-partner, it's a state-of-the-art and certifiable fleet. Our main partners in this side are three. RCO, UK-based company developing X-Craft. Jaunt Air Mobility from the US with the Rosa aircraft, and Manta aircraft. It's a Swiss-based company. So what are the missions of these different eVTOLs? So VRCO X-Craft will be capable of cargo missions. It's an eVTOL. This E stands for electric. So it's, of course, fully electric. And it's unmanned. So it will be remotely piloted. The payload that is enabled by this aircraft is 180 kilos. So we don't aim to basically low weight transport, but we aim to more massive one. The speed that this aircraft can reach is 230 kilometers per hour. So covering a good actually range, so like 200 kilometers more or less. The Jaunt Rosa instead will be accomplishing two types of missions. So we'll be having the cargo missions and the city connection missions and hyper shuttle missions. So this is more versatile aircraft we have as of today. It's a good point. This aircraft is actually certifiable in Europe. And we'll be able to import this aircraft as soon as it gets realized in a final way by 2024, which is the year of launch of our hyper shuttle service and cargo service. So this aircraft is manned, and it's in the very first time it will be sold as a hybrid, but company is trying to go for a fully electric solution. We have a payload of 640 kilos or 4 seats and a speed of 280 kilometers per hour. As you can see, the difference between these two kind of missions is in the range. So when you have fully electric capabilities, your range actually decrease quite a lot. But the airports are always in this reduced range around the CA, so we'll be able to accomplish the mission as well. Regarding Manta, Manta is a very high-speed aircraft, which can range up to 1,000 kilometers. So this will enable actually flights to nearby cities. Most important highlight is that, Manta is an eVTOL also. eVTOL means that it can exploit a short path to take off rather than having just a small pad. This could be versatile as a solution, as you can use very small streets in order to take off, maybe. So apart from the fleet, we have started some example routes across Italy that we can exploit, and I'm showing you some of them. For example, airport shuttle from Milan to the airport of Malpensa has a range of 45 kilometers with car. Now, normally you will take more than 40 minutes to get there with car. And it will cost you with a taxi 120 euros. Well, you will be surprised. This price is the same for our service, and it would take you only 15 minutes. Yes, just 15 minutes to reach the airport from the city center. The service for near cities, for example, here we have Bologna-Venice, airport to airport near city. The range is quite high, and the estimated time of arrival is 40 minutes. But still, what our aim is to enable connection that before were not possible with an agile strategy. So you might get stuck in the traffic during your travel to the airports. So we find this service, it's really valuable, and so do our customers. The cargo service, for example, on Rome, between two main logistic area, which could be the Fiumicino Airport and Civitavecchia Port, we have a range of 55 kilometers, an estimated time of arrival of 20 minutes, and a competitive price with the other I mentioned before, so 120 euros. But let's see, what are these pads that enable our flights? Vertiports. So you have already seen some scenes I put in background, and you can see also here, this is actually a render that the Zema group from Italy designed for Walle. You shouldn't think about vertiports. This might be a mistake. Like this is the vision structure of the vertiports. The real lights are in the front of the slide, so vertiports will be for sure strategically distributed across Italy, and they will enable transportation between out-of-service locations as well. On the right, you can see some examples that they already made. For example, airport to train stations, or coast ports with islands. We have more than 800 islands in Italy. City center with outskirts, and logistic facility, as I explained before. A vertiport might be defined as very small landing and takeoff spots, so it's like 50 by 50 meters. It's not that big. And our aim is to design a modular and scalable design for mostly two reasons. The first is that we have multi-partner fleets. So our aim is to actually welcome all the different manufacturers that want to collaborate with us to bring the ecosystem in Italy with just operators. And the second motivation is that this approach will increase municipalities and real estate owner assets. A third advantage coming from vertiports is that we might integrate, as you can imagine, shopping centers, food and drink chains, and in this way, customers that go to the vertiport, they can relax or travel fast to their destination. It depends on their will. How does Walle at this point enable this ecosystem in Italy? Well, we have several companies and several institutions that deal with Walle in order to bring this ecosystem in Italy. As you can see from this slide, we have manufacturers, infrastructure, municipality, location, airspace management, and vertiports. On the manufacturer side, I already explained, we have the streaming partners, but we are welcome to, and we are open to discussion with everyone. For the municipalities, we have some partnerships in finalization with the cities you can see here, but we're still talking with some more. And for the space management, which is one important thematic of the topic of the European mobility, we already have a partnership with Aereo, with D3. Aereo is based in the US, D3 is based in Germany, and we are talking with actually national organization in Italy that deals with the airspace management. Regarding infrastructure, we are part of a consortium. It's called Future of Flight Simulator, that is trying actually to bring concrete perspectives on this sector. And Skygate, which is based in Turin, which is a cluster of airspace companies that are trying to boost the development of UAM in Italy. About locations, we are talking with Aeroporti di Bologna, and we have a partnership with Milano Innovation Districts in order to establish one of the first spots in the neighborhoods. And of course, as you can see on the back, this beautiful design of vertiports designed by Zima Group. Let's go a bit for looking at the business model. So the business model is very, very, very simple. We are aircraft operator. We don't manufacture drones. We just sell tickets for air seats. And the price of these tickets has been estimated between 2 and 3 euros per kilometers per passenger. So this was on which my estimation was based for the routes between Milan and the airport, basically. Our business model is going to evolve. As I said, we are planning to manage vertiports, and we're planning to create a drone pilot academy. So drone will be piloted at the beginning, and we will need experts that are able to drive them. The result is that we will sell services to the incoming operators. So we have strategy behind that. As of today, we have achieved some milestones, like we have more than 30 routes under examination. We have, of course, interviewed our customers, potential customers, to understand their needs. Of course, we are building an AAM ecosystem in Italy, as I showed before. We are members of this consortium, Future of Flight Simulator, with UK-based company, other European companies, trying to bring the urban air mobility in the whole Europe, not just in Italy. And most important, our business plan is not based on fancy things or fancy numbers. It's based on real data coming from our partners. Based on this, I would like to tell you, what does it take? So we are searching for an installment of 2 million, but our final goal is to go for 80 million euros. Even if you are a startup, this is a need for us, because we have to guarantee some results. And the results you can see on the right are the certificate of airworthiness. So we are trying to become basically a flight company, a flight management company, and we will be establishing with this installments our habitable fleets, and we started planning the vertiports location strategically, and we will position ourselves in the market. The target of the request is, of course, investment companies, corporates, and business angels. And on the bottom, you can see the timeline. So as of today, we are setting up the service and actually offering our services to airports and municipalities that want us to, and even corporates that want us to understand how to install a proper urban air mobility system to exploit their businesses or to improve the mobility in their cities. From 2024, as I said, we're going to establish the cargo service. From 2026, we'll be having passenger service. And from 2028, we plan to have intercity transport. Our target for today is the Milano Cortina Olympics, Winter Olympics of 2026, to showcase our technology. Of course, apart from all this serious stuff, actually, you should know why to invest in such a company and what's most important as of today for the urban air mobility ecosystem. So why to invest now? Basically, the investor trusts aircraft manufacturers, and you should know there are more than 300 manufacturers in the world. But trusting manufacturer is not enough. So you will need operators. Without operators, there's no market. Of course, the aircraft will be certified. This will be depending on the roadmap of each manufacturer, but for us, it will be between 23 and 26. And this is also in compliance with the European organism that gives provision for the airspace called EASA. EASA has ensured that they will complete the legislation for this airspace by 2025. Just to highlight, the drone provided by JAUNT is really certifiable. It's ready certifiable in the European framework. So it's ready to fly, basically. Then understanding the final use market requires, of course, research analysis, and this research should be done before the market explodes. And this explosion is actually, this boom is foreseen to happen in 2030. And finally, the agreement with municipality needs time. So the sooner one moves in this sector, the better it is. Just let me show who's behind this awesome organization and the adventure we started last May. It's a bold team, as you can see. And it's a team composed by myself, Andrea Ferrante, CFO MBA, and very seasoned startupper, Marco Pugliese, entrepreneur and helicopter plane pilot, which serves as a CEO, Alessandro Lazzari, legal, based in Turin. It's a super networker. Guido Parisenti is a PhD, aerospace engineer. He launched satellites, and it's our CTO, of course. Carmine is a researcher at Politecnico di Milano. It's a deep learning expert and a software engineer. And then we have Andrea Tessera as our CMO. He's a senior executive and is very, very, very good at marketing. Plus 2 advisors from the commercial side and the law aspects. Said so, I want to thank you for your attention in this presentation. I hope you enjoyed, and you can see our contacts here. So info@wallemobility.com, and wallemobility.com is our website. So if you want, just reach out, we can have a talk and we can expand our businesses. Or simply, if you're just interested in us, go on our website, you can subscribe to the newsletter, or you can follow us on our social media. Thank you again for inviting us.
Thank you, Francesco. This is really interesting to see kind of where our future is headed in terms of transportation. I mean, we hear about these things all the time, the new, drone type things that are going to transport us from place to place. But this is the first time that I'm actually seeing it, tangibly, something that it actually sounds like it's going to work. And you've proven that there's capabilities here to go forward. So this is very interesting. Does anyone have any questions for Francesco? If not, I definitely have a couple. I will also double check our live stream quickly. If there are none, then so a lot of your work and research has gone into, obviously, Italy, where your proof of concept is going to take place, but are there plans to expand this or bring this to maybe just major cities across the world?
Well, thank you for the question. Basically, we are trying now to focus on Italy because we really think it's a fertile terrain. It's a place in which people are starting to discuss about urban air mobility. The International Organism for Air Management in Europe I started a path in 2019, maybe a bit later than FAA, but still today they published the roadmap they have for the next 2 years to enable the urban air mobility ecosystem in Europe and especially in Italy. So we would like to start from here, but as I said, we have international partners and we are always open. And of course, if someone is watching from, I don't know, other nations, and if you want to call us, we can actually see what we can do in terms of cooperation and in terms of studying the application of a urban air mobility ecosystem in your city or in your nation as well.
Awesome. I apologize in advance for my dog barking.
Don't worry.
The other question I had is, so since you are focusing on Italy right now, is there, if there were to be another corporation or company that's interested, let's say here in New York, in doing something similar, would you be open to working, you know, hand in hand with another corporation doing the same type of work as you?
Yeah, for sure. I mean, you know, these markets is not existing at the moment, in the sense that there exists a lot of design of the vehicles, and there are lots of companies that are interested in becoming also operators. But at the end, we have no customers. And since this scenario is so early stage, I wouldn't say one company can be close to another. We should instead make a network of companies and cooperate with each other in order to achieve our final goals, that at the end of the day is the mobility of the future. And I think everyone that is in this sector really believes that this is an asset. So this is really the way we'll be moving in the future, the way in which we will be transporting goods in a very efficient way. And this might be also the solution to the overcrowding of our cities and to traffic jam and to all stress that we accumulate in our lives.
Yeah, that's really interesting. I know we only have about 2 minutes left, but one final question for you.
Sure.
I know you said that the reason that you decided to start Walle was because of you sitting in a personal traffic jam that you were in. But I'm curious, did you have previously any experience with this type of work before Walle, or have you been kind of learning on the go?
This is a very interesting question. Actually, no, I did not have any work experience before Walle, and it was so interesting to join a group of people that actually I started talking with after my bad experience. So I started questioning myself, and then I found out some, you know, through some friends, some of these guys, and some other guys connected me with the others. So there was a year of standby before starting really the company in May of this year. And during this year of actually not standby, but let's say backside work, we get to know each other. And I learned from the other fellows that they are very well experienced and they have sometimes worked for really big companies. So I'm actually training myself and enhancing my management skills.
Awesome. Well, thank you so much, Francesco,
Thank
for
you, Katelyn.
presenting and telling us about Walle. I think this is really interesting. Yeah, thank you so much for attending.
Thank you, and bye everyone. Have a nice day and have a nice week.
Thank you. All right, next up we have Robert Johnson, and Robert is an entrepreneur, an advisor, a space advocate, and an author. And he will be talking to us today about where do we go from here? So we're going to learn a little bit about how space is becoming easier to access and how there are ways for us to participate in where we go from here. And with that, I will let Robert take over.
Great. Thank you so much, Katelyn. And my last name is actually Jacobson. Robert Johnson was an old blues musician who I also love, but that's okay. Good morning.
I'm so sorry.
No worries. Not a worry. It happens to all of us. Good morning, good afternoon, and good evening, wherever you all are from. Thank you, Katelyn, and Space Apps NYC and the Space Apps team. I would love for everyone to take a few seconds to put in the chat at any point where you're calling in and joining us from today. I'll try to take a look maybe during the talk so I can get a sense of where you're all coming in from today. So first, when you think of space, what is the first thing you think of? Maybe it was a science fiction story, maybe a memory of your childhood, or an impression while looking up at the night sky. But for perspective, there was a time when not too long ago, there was the idea of even walking on the moon or flying a helicopter on another planet like Mars, or even something as simple like speaking to you today through kind of a relatively low-cost video stream was not really able to be realized yet. But why space, and why am I interested in it? Well, for me, space is not just a place, but it's this open frontier for the imagination, as well as a domain for research, work, and exploration. Because I'm an entrepreneur, an investor, a writer, a musician, advocate, activist, and aspiring Homo sapien. Space is a wonderful and rich place as a canvas to work from. And I was able to find my own place in this new space economy through mostly non-traditional ways, in large part due to my own tenacity and creativity. And there's endless possibilities for you out there. With your imagination, grit, skills, space can provide a lifetime of abundance and fulfilling personal and professional exploration and achievement. And simply by choosing to show up today, no matter where you are, you're already, and if you're participating in this weekend's challenge, you're already participating in the space sector. However, the world we currently live in is in crisis, and there's seemingly endless challenges. However, there's also immense beauty and countless opportunities. We live on the best spaceship in the universe, Earth, and please don't ever forget that. This new space economy that is emerging and growing is an opportunity for us all to grow more individually and help each other. And I love that the previous speaker, Francesco, talked about cooperation and collaboration. And I love that this year's theme for the Space Apps Challenge is the power of 10, because there's a lot of interpretations of that. Could be the 10 is you in the community, 10 international space agencies here to help support you, 10 awards. But you might feel a bit anxious about this weekend's challenges or perhaps the future. And uncertainty is scary, and I can empathize with you. But you are the voices of the new space future, and it's your turn to create, contribute, and lead. So there's two takeaways today for you. I'm going to take a quick sip of water here. My mouth is dry. One, space has never been easier to access. And two, space could be humanity's ultimate business plan that could help lift billions out of poverty, or of our most vulnerable out of poverty, and solve some of our greatest challenges. Many times, Western countries and cultures might think we have all the solutions, and I can assure you we don't. I'm currently in a Western country, in the United States of America. But we in the West can be very skeptical, which dampens our creativity and innovation. But you have your own passions to explore and challenges to solve. The US and Russia didn't really start from zero with their respective space programs. In fact, they had the benefit of leveraging former Nazi space engineers after World War II, and to some extent a strong university system. But part of this current new space movement is about democratizing the access to space and starting as a grassroots, ground-up effort. Because you have the ability to succeed, thrive, and make your own mark. However, it will require creativity, zeal, and cooperation. And if you're saying there's little, if any, space activity in your respective home country or region, I challenge you today to change that. Remember, just by participating in this weekend Space Apps Challenge, you are a change maker, and this is your story to write. No matter which challenge you select, though, there are all equally valid ways to participate, add value, and potentially make a difference. But what are some of the factors that are contributing right now to this increased activity and interest globally in the space sector? It includes, it's not limited to, digitization of almost every sector, increased investment in space, more governments, businesses, and NGOs are recognizing space as an area of critical strategic importance and high value. The use of space technology is becoming more ubiquitous and becoming a requirement for space technology-enabled nations to thrive. But space is not a monolith. It's not a centralized or homogeneous power. The space industry is broad, interdisciplinary, which is in part why and how more emerging nations could participate, benefit, and thrive more by leveraging the space domain. At a high level, the space economy can be thought of as a satellite and non-satellite, or government and non-governmental. And last year, 2020, it was estimated that the global space economy was about $420 billion. But we can still break the space economy down into additional verticals. And although launch is a popular theme, the industry is much more varied and nuanced, and also includes things like rapid launch, communications, space-based data, microgravity research, space resources and mining, space land, which you can think of as like R&D, industrial centers, spaceports, manufacturing on terra firma, robotics, novel applications, space-based energy, in-space services, and stations crewed and uncrewed. I go into these verticals with much more detail in my book and a weekly newsletter I put out, along with topics such as investing and funding in the book Space is Open for Business. But what ways can space technology and development help support the emerging countries and regions and other rising economic powers? They include infrastructure development, resource management, think of like food security, deforestation, overfishing, forced labor issues, disaster risk prevention and response, improving policies at a local, regional, national levels, improve communications and internet connectivity. And one could surmise that there could be serendipitous and other tertiary benefits, which I go much further into topics in my book, but just kind of giving you an overview today. And what are some of the potential downstream benefits for up and coming countries and regions? They include a more educated population, better jobs, which equals better wages, which equals more taxes collected, which governments like, and increased domestic product. As a topic I'm sure most of you know of or heard of, there's potential second order effects for society and countries that will occur from increased connectivity to the internet. And some of that new internet connectivity could be coming online from satellites that we're hearing about, projects such as OneWeb, Starlink, Kuiper. But they also include reaching populations in remote areas for things like classes, courses, remote learning, interactivity, remote training. And there's been some studies backing up to why this is a good thing. The UN found that over half of the world, 52% of the world still lacks access to the internet. And 90% of those are from developing or emerging countries. And it's been shown that just having access to the internet for a country could mean a 2.5% difference in the entire country's GDP. But what else does increased connectivity mean? It means more students in underserved areas could access things like STEM or STEAM education in closer proximity to their own homes instead of having to travel far distances or abroad for education. And in parallel, as those people gain more skills and create companies and jobs or gain employment, they might be able to remain in their region, strengthening the labor force and creating more economic growth and opportunities. So one example about some connectivity through satellites and a positive benefit is that the Indian Space Research Organization, known as ISRO, its acronym, is using satellite technology to provide health services such as telemedicine to connect remote hospitals to specialty hospitals. But let's go back to you out there in your role. And again, if you're just joining us in the chat, please put in the chat where you're calling in from today. Would be great. Would be really great to understand where everybody's calling in from or watching from. My belief is that developing a local or national space ecosystem or community can really be initiated or activated by you. It's long-term work, but it can be started today, even in the most modest ways. And in this effort to participate in the space sector is not solely limited to the engineering or other sciences. We also could include and should include the business and management schools, trade and vocational programs, high school and primary schools. And we can improve on making space more inclusive and open to all. The benefits for expanded inclusivity include creation of additional employment opportunities. Both STEM and space-related fields are growing and essentially driving economies. And I'll share a story of how STEM in particular is making a difference in one emerging country. There was a former university student named Juliana Huerta Mercado who had very few hands-on science opportunities in her native Peru. She ended up starting the NGO called United Technologies for Kids, where dedicated University of California, Berkeley students would travel to Peru or Colombia every year to teach Arduino technology and 3D printing for a month. Afterwards, they learned that over a quarter, it was something like 26% of the students that they had served changed their majors to a STEM-related program after participating in this program. So I'm now going to shift slightly and share a few ideas and strategies for you to build your respective new space ecosystem. One thing is start thinking like an entrepreneur, or sometimes I like to say an astropreneur, even if you're not one in the literal sense, even if you're employed or in a university setting. Consider starting a chapter of Students for Exploration of Development of Space. It's known as SEDS, whether you're enrolled in a university or not. Think about creating a makerspace or accelerator. It's in a perfect time to develop modest infrastructure that can inspire and prepare the future builders and engineers. As you're keenly aware, and I'm keenly aware, there's always financial constraints, but this is where industry, through partnerships and donations, could help. And as a direct message to those out there who are non-engineers, want to maybe help start one of these, if you can help develop the partnerships, it's not only going to help you with your own respective career, but serve as a guiding light for your peers, community, and the countless ways to engage with the sector. You could start by reaching out to, there's plenty of NGOs out there that might be open to partnership opportunities to get you started on whether it's a makerspace, accelerator, incubator. And if there's any policy or lawmakers who perhaps are listening, consider providing loan forgiveness for space-related scientists, such as physicists and engineers, after X number of years of working in the industry. And the message to maybe some of the sponsors or established and thriving space organizations, please continue to provide subsidized and free discounted access to space. One example is the UN Space for All initiative. And I provide many more useful insights and resources in my book, Space is Open for Business. I want to reiterate that this is not a passive activity waiting for industry or trade to knock on the door to contact you. It really does start with you today. If you're participating in this week's Space Apps Challenge, you're already participating and demonstrating a willingness to step it up and participate. And no matter what the result is, continue forward. Do not give up. It's your time to shine no matter where you are. And I don't really care what degree you may or may not have earned. Space Apps is a great example that space is attempting to be more inclusive, less restrictive, and more open. And believe me, they'd not pay me to say this. I promise you that. There is no better time to apply your gifts to this wonderfully fulfilling industry that's changing and hopefully improving our world. Gifts and talents that we each have are broad and varied, so don't let anyone tell you you don't have a gift or the ability to contribute. Space as a movement and industry really does need you. And although the boundary of space is only about 100 kilometers above sea level, we can't see it. And it's easy to forget that accessing space is still difficult and out of reach by many people in their respective nations. Some of the expected growth from the space economy is looking to serve emerging markets. So there's great opportunities on both sides. However, I can envision where emerging countries start creating their own innovations to participate not just as customers, but builders, makers, founders, visionaries, leaders in this new space economy. And there's plenty of room for new bright stars. I was recently listening to a keynote given by the renowned biologist, Dr. Roger Payne, who discovered the whale songs amongst humpback whales, who said, quote, "Cooperation is how nature evolves fastest." I'm going to repeat that again. Cooperation is how nature evolves fastest. So look around in your geographic, your academic, virtual neighborhood for allies and partners. You are the emerging voices and future leaders in a global industry that is changing our world and perhaps our solar system as we migrate further out into space. I like to think of it as space migration. It's time for you to be bold and courageous with your ideas, and please follow your dreams no matter how far out in the solar system they take you. We are all passengers on spaceship Earth and citizens of this wondrous solar system. Each of you has the capacity, though, to be part of the crew leading the journey to make space open not just for business, but for all of humanity. Thank you very much, and I wanted to leave ample time for questions and a chance to interact with any of you out there. And I'll bring, I guess, Katelyn back over to you.
Yeah, of course, this is right when my dog wants to start barking again. Sorry about that. Thank you, Robert, so much for your talk. It's very inspirational to know and hear how we can get involved, just ourselves as normal individuals with our own individual skill sets. Does anyone have any questions before I start unloading my questions for Robert? I will also double check our live stream. All right, back to Zoom. All right, so I have a couple of questions. So in the very beginning, you were talking about things that need to happen to further already developed countries in the space industry. And one of the things that I kind of giggled at was getting everything documented, all of our space industries getting all of our old things documented from all those years ago when we used to write everything down, or they were typewritten and we need copies now. How long do you actually envision that process taking for countries like the US?
Oh gosh, I've never really thought about that in terms of knowledge transfer and wisdom. I had heard at some point that in the Apollo program they had lost a lot of critical documents and paperwork, and just people passed away. So I think it's important to capture the wisdom of our elders, those who might even be retired and out of industry, because they still have wonderful things to share. There just could be a way for, whether it's led by corporations or NGOs, just to interview and get stories from those who are no longer maybe working actively in industry. I mean, we do have some pretty advanced things like OCR, so I think there's ways to kind of grab things like paperwork. I don't know about things that might still be on microfiche. But there are, but it is an important area. So in terms of timing, I mean, it could take decades, but all this stuff is finite. Microfiche and paper and digital files are easily lost or destroyed. So I work with a group called the Arc Mission Foundation, whose mission is to back up knowledge and culture of humanity, and we're scouting some of the most advanced forms of data storage technology available. We flew a disk that's in the glove compartment of Elon Musk's Tesla Roadster. We installed the first lunar library as part of the mission with Space IL that we put about 35 million plus pages of Earth civilization on a nickel disk. It's the first and only and largest library on the moon. And so I do think this is of probably critical importance is to capturing knowledge, wisdom, legacy in many different formats and thinking about redundancy and mass duplication. So, but I think it's going to take time, and I don't know what sort of priority it currently is.
Yeah, that makes sense. You also talked a lot about the establishing new countries in the space industry and how they're getting started, and you even shared the story in Peru. I'm wondering, for someone like myself, and I know many colleagues out there who are interested in space, but not necessarily in the space industry, and our skill sets are not so much in demand here. Is there a way for us to get involved maybe in other countries to help them get their space programs off the ground, or an organization maybe that you know of that helps out in that way?
Yeah, great question. I don't know of a specific one that it probably exists. I think, for those who are maybe of college, who are somehow affiliated in or thinking about going to college or the recently out of university, SEDS is probably a great program to start a chapter there, because they try to bring in people from various backgrounds to those chapters, and you could probably have there's ways for mentorship. I sense as maybe collaborating and cooperating with an existing, there's lots of organizations around STEM that are working with other countries or regions, and just establishing, a space vertical or a space related project for that country. So I think it's do a little bit of landscaping, see who's involved in that country. If you're starting with a country or region, and maybe work backwards.
Yeah, that's good advice. And I have one other question for you. So I haven't read your book yet, but I have read little bits and pieces of it and a couple of reviews. And you seem so passionate about, opening space for business, exactly what your book title is. I'm wondering if maybe you can tell us a little bit more about your background and where this passion came from, and how you came to discover it.
Certainly. I was born and raised in the state of Florida. I went to space camp, and then, but at the time, the path to becoming an astronaut seemed more about, joining the military. It just seemed very arduous and about following a lot of orders. And I don't think I was a great order taker, following all the checklists maybe at the time. And I went off to do other things. And I did get to see some space shuttle launches. And then it was in 2004, or maybe shortly before 2004, around that time, I had heard about this X Prize. And the first X Prize was to get a human to space privately funded. And there was some more minutiae to the rules. It was to get to the border of space, about 62 miles above sea level, or 100 kilometers. It was piloted, but they had to carry, I think, the equivalent of weight of 2 to 3 people, and do this twice within a couple weeks. Well, I ended up going to the very first flight on it was the pre-competition flight, June 21st, 2004, because the other flights were essentially late September, early October. And I went with a buddy, and at the time I'd been working in sort of 2 very different areas, in real estate and music. Actually, I studied music and business in my undergraduate studies, and was kind of doing some, nothing related to space. And my buddy and I drove out late one evening on June 21st to see the first launch. And we go out to the Mojave. It was just the airport at that time. There was no spaceport yet, or it didn't receive that designation yet. We saw Spaceship One fly, and it was a very grassroots event. There were people there in RVs. Look, there's no no one had smartphones. There's no Facebook. It was just people kind of they kind of heard about something was happening approximately at this time. They showed up. I remember very vividly that at sunrise, it was very windy, and then they brought out a white knight, the carrier plane with Spaceship One. Eventually, it took off. Spaceship One launched. It came back, and it was just an amazing moment. And I really felt transformed. That I knew this was a historic day and I wanted to be involved. I didn't know how. And it sort of continued, it sort of was a catalyst for a path for myself.
That's amazing. And that's very inspirational for a lot of us, and myself included. The same story as you, went to space camp and definitely was interested, but had no idea how to become any kind of astronaut. And so ended up going a different way. And here I am kind of working next to NASA. So same kind of story here. So very inspirational. I'm not seeing any other questions. Let me just double check one more time. But we did have some people log that they were in New York City, and we also have someone else tuning in from the UK.
Fantastic.
And I know that we also earlier we had someone from, I forget where already, Sri Lanka.
I visited Sri Lanka. I was there about a little less than a decade ago.
Oh wow!
Yeah.
Okay.
And I got to spend some time. I actually visit the estate of Sir Arthur C. Clarke. He was dead at that time, but I did get to visit his estate, and that was a really cool experience. And had a wonderful visit to Sri Lanka. Very fond memories.
Amazing. Yeah. So we definitely think that later on we'll end up having more countries come through, but for now that's the answers that we got. But if you have any maybe last thoughts, or maybe how people can get in touch with you if they have questions later on or something like that.
Certainly. So the book website where I have a little community there is spaceIsOpenForBusiness.com. And they can also just find me through robertjacobson.com, and that is spelled, my last name is Jacobson, and robertjacobson.com. I have a weekly newsletter, do a podcast community I curate. I'm on the social media channels. You can find me on Instagram, Facebook, and Twitter. My Twitter is maybe a little more difficult to find. It's 62 Mile Club. That's the number 62 Mile Club. And any last thoughts? I would say, as a proper activist, I would probably say free Lolita and Tokate, the orca down in Miami, and also free Kiska, the orca in Marineland. It wouldn't be. And we have to remember our cetacean friends out there who are in captivity. And I want to thank you all so much for your time today. It was wonderful. And space is not just open for business, but is open for all of you. And I'm happy to be of service to you all today. Thank you.
Thank you so much, Robert. We really appreciate you taking the time to talk to us. It was definitely inspirational to me to hear about all the ways that we can get involved. So thank you again for your time.
Oh, wait. Thank you so much. Bye-bye, everyone.
Bye.
Bye, Katelyn.
All right, guys. So next up, we have Lisa. Lisa is from the company SourceGraph, which I'm sure I will let her explain. I'm sure that's part of her presentation. But what Lisa's going to talk about today is an introduction to Git. And this will be a little bit of a workshop, as I think most of you tuning in and maybe watching this recorded later know in the engineering, computer engineering and coding industries, most of our work is committed or saved in some way, shape, or form to GitHub, which uses Git. And so Lisa is going to take us through the ecosystem and some terminology and how to commit to a team project. And with that, I will let Lisa take over.
Hey, thanks so much for having me today. I'm really excited to be here with you all. Yeah, I'm Lisa Tagliaferri. I work at SourceGraph as Director of Developer Education. SourceGraph is a great tool to start to understand code to learn how people are using code in open source repositories to get lots of examples, and also could help you search across all of your own repositories as well. Awesome. So I'm going to share a little bit of a presentation, and then we'll go into our workshop section. Awesome. So yeah, a little bit about me. I've been working in open source and education and tech startups for a while. I have a few free resources if you're just getting into coding. There's one book that's How to Code in Python, another about Python machine learning project. They're all free, open access, and they're accessible online. I'm also building out a open source learn platform with SourceGraph, where there's going to be lots of resources around Git that you could check out later. And also you could play with the SourceGraph tool there. So I wanted to give you a little bit of a background about open source, since you're all going to be contributing to open source during the hackathon. So the rise of open source repositories has been really tremendous over the past few years, really. And one place where there are a lot of open source repositories is GitHub, which is a platform for collaborative software development. So this chart shows kind of the extreme increase of software repositories hosted on GitHub from 2008 through 2013. Important to note that GitHub is not the only place to find open source repositories. GitLab is another popular tool, for example, but this is indicative of the rise in software made available through open source licenses. So I know open source is something that we talk a lot in tech, but what is the exact definition of open source? So open source software is software that's freely available to use, redistribute, modify, and it's typically shared via public code repository hosting service, such as GitHub. Projects that are open source encourage a transparent process that is advanced through distributed peer review. Open source projects can be updated quickly and as needed, and offer reliable and flexible software that is not built on locked proprietary systems. I think that open source is something that's really important in science and research. It helps people be able to replicate the work that is going on, and it helps people check and make sure that things are going as expected, and also helps people to contribute as well. So why is open source important? It lays the foundations and provides libraries for a lot of other software. Open source software is used in productivity apps. It's used underneath entertainment apps like Netflix. It's used underneath social media apps like TikTok. It's also used in cars, and it's also used on Mars. There's lots of great articles out about how the Mars rover used open source software. There's Python going around on Mars, for example. So really lots of great projects to check out and to understand the open source ecosystem more. So if you thought that those 10 million repos in 2013 was a lot, as of January 2020, GitHub reports having over 40 million users and more than 190 million repositories on its platform. At least 28 million of those repositories are public or open source. So there's been extreme growth in this space, and GitHub is a popular tool. So we're going to go into the workshop portion, and we'll go over some of the words as we go through. So we're going to be working with this repository that's the Cloud Haiku repository, which is an educational repository that I developed for the Hacktoberfest yearly celebration of open source, which we happen to be in the month of October, which is awesome. And I've been maintaining this project for a number of years that helps people kind of learn the mechanics of contributing to open source. And so if we will go into, if you don't have everything set up already, you could go and inspect this repository, which is at .com/do-community/cloud_haiku, but we'll go through that again in a minute. This is the front end of the website. So if you contribute to this repository, which you're certainly welcome to do so, this is an example of how your work will appear on the site. It's a Jekyll site that serves static markdown files. So if you don't have one already, I would recommend that you go to github.com, create a GitHub account if you don't have one, or if you have one already, to go ahead and log in. This is the GitHub homepage. You could create your account right at the top right corner there. The other thing that I would like you all to do is to download the desktop app for GitHub. So this you could get from navigating to desktop.github.com. Then you can download the GitHub desktop that's relevant for your machine. For me, I'm using Mac OS, but you could also download for other machines. And then once you have all of that set up, to go on to navigate to this repository. In this case, it's this github.com /geo-community/cloud_haiku. So I'm going to share my entire screen now so that we could talk through this. And if you don't have this, if you don't have everything downloaded already, don't worry, we're going to go through it now. We have more videos and tutorials to help you if you miss anything, so don't worry. Awesome. So here is the GitHub repository. It's github.com/do-community/cloud_haiku. So when you're in this repository, and I'm logged in now as my username, what we could do is go ahead and clone this. So the way to do that is to go to this green button that says code, and you could, if you prefer the command line, then go for it. But we're going to open this with GitHub Desktop right now. And then once you click that, and you have GitHub Desktop set up and ready to go, then you'll be able to pull all this code into your local machine. So doing a git clone means that you're just cloning that whole repository. That means that all of the code that exists on that repository you'll bring locally to your own machine, and everything exactly as it is on GitHub will be exactly how it is on your local machine. And it's, depending on how big your repository is, it could take a little bit of time. What is important about Git and GitHub and things like GitLab is that it allows you to do version control, and it also allows you to collaborate. So with version control, you can kind of roll back all of the changes that you've made, or you could kind of try different features at the same time and see which one is the one you actually want to implement. So Git kind of exists across different kinds of branches of code, and I could show you more resources so you could learn more terminology after this demo. But basically, Git allows you to collaborate really effectively on software projects. It allows you to push code pretty often so that people can test your code and give you feedback. And it's not just code. Documentation is really, really, really important for Git repos. It's really important for onboarding new users, and it's important to remember what you actually implemented to begin with. So if we look at my file system here, we have these. I have a lot of Git repos, but the one that I just cloned right now is this Cloud Haiku repo. We could see, if we look on the GitHub URL, that we have a few different directories. We have a few different files. We have README files. We have a little bit of data files that are in YAML or JSON. And those are all here now on my local machine. And once you clone this repository, they'll be on your local machine as well. And we see that we're on the main branch. Everything looks clean. We can fetch again to make sure there's been no changes. But what I want everybody to do, if you're following along, is to now create your own branch. So you could call it your username if you want. I'm gonna call it my username plus today's date, and then we'll do space apps, but you could call it whatever you would like. So now what this means is that I'm in a different kind of branch from the main tree of this Git repository. So in this branch, any changes that I make are going to be on my machine only, and then I'm going to commit them to the main project once I'm satisfied. So if you go through and read how to contribute to this haiku repository, we're going to use Jekyll format. We're going to write a haiku, and of course I always forget to have a haiku ready to go, but we're going to go into whatever code editor you like to use. We're going to create a new file. We're going to go ahead and save it into our Cloud Haiku repository under _haikus. So right in here, we click, well, I didn't call it anything. So this untitled one, we'll call it Lisa Space Apps.md. So everything in here is a markdown file, and it needs to be a markdown file for it to be rendered properly on this project. And we're going to open this again, and we're going to copy basically what it says on this README. So we just need to make sure that this format is here so that it kind of Jekyll pulls everything in as we expect. So we go into VS Code. So the layout is haiku. The title, we'll call it NYC Space Apps. The author, put your own name, and then we'll make a quick space haiku. So NYC Space Apps, and haiku format is 5 syllables, 7 syllables, 5 syllables. Fun to learn, get together. Commit and deploy. Okay, so here's a very, very little haiku. Don't judge me on my poetic ability under pressure. So what happens now? So we have this haiku. We created this new haiku. We have this definitely in our _haikus repository, and we made this change. So on GitHub, the GitHub desktop program, we're on this new branch, our own branch. We see that there's one file that's been changed, just this haiku file. And then we're going to create a commit message. So we're going to say that we added Lisa Space Apps.md, or you could say I added, the NYC Space Apps haiku. And then we're going to click commit. And the commit means that we're going to stage this, and we're going to stage it, and then we're going to publish it. So we do publish branch, and then we're going to see when we reload this GitHub, when we reload GitHub on the browser, we'll see that we have this recent push that we made. We published the branch. So what we're going to do now is we're going to do a compare and pull request. So a pull request is when you're asking a project to pull in your code, you're requesting that they pull it in. It's always a good idea when you're working with open source projects to give as much context as you can, like especially if you don't have a relationship with the maintainers already. In this case, I'm the maintainer, you know me, so I know what to expect your haiku. So you could write like, I'm adding this haiku. Please, thanks. Yeah, thank you, adding a haiku. So if it were, when you're in your hackathon, you're probably going to be all working really closely together. So probably writing these messages won't be as important while you're getting everything off the ground. If you end up open sourcing your project and accepting contributors publicly for a while after that, then you may want to have some kind of like format for people to enter into your project. In this case, this is our educational repository. So now as a maintainer, this is what I see. So since it's Hacktoberfest, it's a popular time in the repository. So I see there's lots of pull requests right now. This is the pull request I just made. So me as the maintainer, what I would do next is I would look at this markdown file. I would make sure that it's in the right directory, that it's in the right format, that all of this looks good, that it's in the haiku format, and hopefully it is. And if it's not, I'll fix it later. So then I will do the merge pull request. I will confirm the merge, and then you would get the feedback that this was merged. Now that since it's my branch and I merged it in, I would delete that. When you're doing a project with others, I would recommend that other people review your code, not to merge in your own code. It's always a good idea to have a second set of eyes on things. And what's nice about GitHub is that it allows for lots of reviews. So here's an example. What I could do is request changes or approve or give a comment. I could go in line and say, like, can you make a change here? And then, I could also have a local copy of this and preview it in a development environment. So I definitely recommend doing all of that while you're going through your own software project here. So if we go back to code, we'll see that this pull request has merged in. We'll see it under haikus. We called it, is it not in there? Maybe we called it space apps. All right, so Lisa space apps was merged in. We see it here. This is what it looks like in the GitHub repo. The raw version looks a lot more like what we did in our VS Code. And at this point, we could check to make sure that everything looks good on the main site. So this is the main site that we talked about. Probably we could search for our contribution, and we could see it. It's live. It's ready to go. And that's the great thing about open source, is that you're able to share your code very quickly. You're able to push things live. The code on your machine is not going to help other people. So push early, push often. And I'm just gonna share a few different things if you're excited about open source, or I'm very excited about open source, and some more resources for you. So this is what we went through. As I mentioned earlier, October is the celebration of Hacktoberfest. If you don't know Hacktoberfest already, I encourage you to go to hacktoberfest.com to sign up. You may be able to get a free t-shirt for your contributions, but the main thing is that you're able to contribute to open source, and you're able to progress our technological innovation as a society. If you're very interested in open source after the hackathon, there's lots of other resources to start to learn how to be an open source contributor. It's really important to get more folks into open source, because open source is so important to software development writ large, and having more voices there will only make open source better. Finally, if there's some, I know we went through this very quickly. We have a number of resources on learn.sourcegraph.com that are Git related. So this is how to add open source software project to SourceGraph Cloud so that you could start to inspect other software repositories. You could also index your own repositories. And we have a number of Git resources that will take you through a similar workflow that I just did for you today. So how to commit code to Git, some kind of overviews of what diffs are, what staging and unstaging, and what branches are, and what are Git commits. So I invite you to look through this again. I'd be really excited to read your space themed haikus, and I'm here for any questions.
Thank you so much, Lisa. I do have a question that I've run into a couple of times. With Git, if you are, let's say, writing your haiku, and let's say you forgot to put the HTML break in, and you had just committed it without that break, and then you go back and you're like, okay, let me add the break, and then you commit again. How does like a double commit like that work?
Yeah, that's a really good question. Let's see, I could go back to show you really quickly. So what's really good about Git is that you could commit as many times as you want into your pull request. So if, let's say, let's make a new branch really quick. So if we do exactly, and the break is a nice to have actually, as long as you have two spaces, it will render correctly, or I guess just one space and a return. So then if we do this and we wanted to do like add, we're removing the breaks, remove breaks. So then we would commit this, we would publish. And then if we go back to our cloud haiku, so if we go back here and we do compare and pull request, and we have this pull request, so that we have a conflict here, which may happen too. But what you could do is go back to here. You could kind of understand that there's a conflict, or I didn't do something quite right. Then I could go back into here. I could add back in these breaks and save it. And then I could just commit this back in and push it. And then this will automatically update my pull requests, and then I'll be able to merge the pull request. And then you see that both of those commits are in there. I mean, even if you decide that like that poem is not really what I wanted to write, for this project, or if you notice that you're writing documentation, you have a typo, or you're programming in Java and you forget your semicolon at the end of the line, which definitely happens, you see that there's something wrong when you're inspecting it, or your reviewer notices something is wrong, and you could just make a new commit. Somebody else on your team can also make those fixes too.
Awesome. Thank you so much. Yeah, that's something I run into a bunch. So very helpful for me. Let me just double check our live stream really quickly. All right, I'm not seeing anything from the live stream, and it seems like we're quiet in the actual webinar. So I think that might be it for questions. I guess, is there anything else that you wanted to kind of maybe plug for Hacktoberfest? Hacktoberfest.
Yeah, I mean, I like Hacktoberfest. I'm not very personally affiliated with it today. SourceGraph is participating, but if you're interested in open source, and since you're building open source software anyway, it would be great to get involved. I think it's a really great program to raise awareness about open source. And I mentioned earlier that SourceGraph is a tool for searching code, which is it's pretty awesome. Like you could, if there's something that I mean, I was actually using it to kind of look at error messages yesterday. So you could see how people are handling errors in Python, for example, if you're coming across errors. If you're since you are building open source software today, you could add in your repository so that SourceGraph indexes it so that other folks can search your code too. So here I added my own repos. So the Cloud Haiku is there. People can search haikus as while they're searching things, and you could see how a lot of people are implementing different features. It's a good way to kind of, especially if you're learning like a new programming language, to get up to speed. And the other thing about the Hacktoberfest is that there's a number of resources available. So if there's anything that folks missed, just I know it's a very fast workshop. If there's anything that folks miss, Lynn Muldrow has a great video that'll walk you through this again. There's a number of tutorials that are available too, like even for things like if you're having problems with your pull request and need to like rebase it, there's lots of resources available to help recover from those issues.
Awesome. Well, thank you so much. Someone in the chat said awesome. This is really cool. I'm really excited. Later on, we do have another session and later to go into a little bit more detail with SourceGraph, who is one of our official sponsors. So thank you, Lisa. So we will later on, if you're watching now and you are interested in learning a little bit more about SourceGraph, you should go ahead and check our schedule because I forget what time it is. Do you know what time he's speaking tonight?
I think it's 5:30. 5:30.
Okay, yeah, that sounds right to me.
It's later this evening.
I think it's 5:30. But just double check our schedule. It is in the link in the YouTube, and it should be in the link that you got here if you're in the webinar. So yeah, thank you so much, Lisa. I appreciate it. This is definitely helpful. It'll be helpful to our participants as well when we post our video. So thank you so much.
Yeah, have a happy time coding, everyone. Excited to see what everybody builds.
Yes, thank you.
Thank you. Bye.
Bye. All right, so I believe right now we are just waiting on our next speaker. So I'm just gonna take 1 second to send a quick email. Just give me like 2 minutes and we will be continuing. Okay, we just got an email that they're in the green room. All right, so we are just doing a quick mic check, and Karen, our next speaker, will be over. I can start her introduction. I think that would be helpful. So Karen Lopez is a data nut. I'm sure she will be able to tell you a little bit more about that in her talk. But she's going to talk about managing your time so that it doesn't manage you. And especially during a hackathon, I think this is very relevant for everyone for this weekend, in general, in your daily lives, at work. Managing your time so that it doesn't manage you is something that's so important to all of us. So during this talk, Karen is going to share her experiences in mentoring and judging hackathons, including tips about what order to approach the challenge throughout the weekend. So things like getting started, assigning roles, deliverables, so things that need to get done no matter what. Demos, using open data, just like we just heard Lisa talk about open source data, and the judging process, and then subject matter experts. These are all things that Lisa just spoke, that Karen's going to talk about in her talk. We're just making sure that she is headed over. Just 1 second. All right, I think we just gained one Karen Lopez. Hi, Karen, how are you?
Hi there, I'm doing okay.
So I heard that you were in the green room, so I just did your quick introduction with the title of your talk and what you would be talking about. And I did mention that you are a data naut, and I'm sure that we do have some people who either are watching now or will be watching the recording that are interested a little bit in the data naut. I'm kind of speaking for myself. So if you could maybe start out by introducing yourself and a little bit about that and what you do, that would be great. And the floor is yours.
Yeah, and just one more thing. So I have 30 minutes and I leave time for questions at the end. Is that how it works? And you help answer the questions if anyone's having any other issues?
Yeah.
Yeah, okay. So let me get my screen shared. Oh, hold on. Okay, I need like 5 screens.
I find myself doing that a lot too.
Okay. See my screen okay?
Yep.
Okay, so I can start?
Yep.
This is perfect? Perfect. Thank you all for joining us for this pre-hackathon symposium. I'm Karen Lopez. I am also a Space Apps Challenge ambassador for the overall universal global event, as well as I help with judging, and I'm a NASA data naut. A NASA data naut is a program that was started by NASA. It was an offshoot of the Space Apps Challenge when it was started when the CIO of NASA, as well as the people who were putting on the Space Apps Challenge, realized that there was an underrepresentation of certain types of people participating in the hackathons, some based on gender, some based on other underrepresented peoples. So they started this NASA Data Naut program, which right now is currently on hold as NASA is very busy with all the commercial crew things happen, plus the Artemis mission to go back to the moon, plus a lot of other things that are going on at NASA. But the program was a volunteer program. I'm a volunteer with NASA. I don't work there. To help a class of people who were new to NASA open data to learn how to use it, as well as to learn how to code, to learn how to do data science, to learn how NASA data works. So there were 2 intakes a year of about 50 people from all over the globe who would attend a series of workshops on every few weeks to learn about open data, to learn about data management, data literacy, to learn about rocket science math, to learn about planetary sciences and earth sciences and a whole bunch of things. And then teams of data nauts would get together along with mentors like me and NASA data scientists and NASA engineers to build a project or to do research into the data or help develop metadata for the data, ontologies, all kinds of things. That was a really interesting program. And so it is normally open to people of all skills, all types of data literacy. It did have a focus on code, but it's not necessarily all about code. So we're going to go ahead and if you have questions about the Data Not program, you could go ahead and ask them in the Q&A or the chat, wherever you're putting your questions. And I'd also recommend that you get your questions in now. Don't save them to the end. I'll be answering them at the end, but please ask them along the way. So my talk is about how you should manage your time during the hackathon itself. But let's talk about it. My role in my real job as a consulting company I own is I call myself data evangelist, sometimes a project manager. But I'm thinking right now the project management parts of the issue. And that is, you might think that your goal for this hackathon is to build the world's best software application with web architecture at web scale, and to do the best coding and to do all that. And I'm here to tell you, as both a judge in several hackathons as well as a mentor, that that's only part of your goal. Because this is a hackathon, you'll need to prepare a pitch, almost like you were pitching for funding. But instead, you're preparing deliverables, a vision, an explanation, and lots of information in your submission in order that all that hard work you did could be judged by people who've never met you, may know nothing about the code language you're using, may know nothing about the frameworks or architectures that you're using. And the Space Apps Challenge website, and including the New York City one, but all of them include a lot of information about how you're supposed to do that. Your actual project, that is, building software, building UI, doing art, building an ontology, could consume so much of your time this weekend that you forget about the actual deliverables that you're supposed to provide. Remember, at the end of the weekend, you are delivering a project submission package. Yes, there might be software. Yes, there might be art. Yes, there might be demos, but it's the entire package you'll be judged on, not just code and not just anything that you build. It's often stressful all through the weekend as you realize you're running out of time, or something you thought you could do, you can't get it done in such a short period of time. And the judges understand that. They understand that to build an incredible application or a perfect thing of art takes time. That's why they're going to ask you a lot of questions about what is your vision? What is your mission? How would it work? How would people use it? What would the impact be? What costs, benefits, and risks would implementing your proposed solution or idea or concept or art, what would come with it? They're going to judge what you did over the weekend based on all of those things, not just the thing that you built. One of the biggest mistakes teams make is waiting to prepare all of that evidence, all of those deliverables, until the last minute. And we're all like this. I am a professional procrastinator for certain. But my biggest tip to you, and you're going to hear me say this a lot during this presentation, is that you cannot wait to the end. You'll be tired if you're working on a team. Maybe you're tired of talking to each other. You need to start submitting your results on the first hour you're working. That sounds crazy, but you can actually start writing some of your submission things very early in the weekend. So there's always a countdown at the end of the hackathon, always. And you'll be getting reminders in Rocket Chat and from your organizers that it's time to make sure you're submitting. Do not ignore those reminders. And as a good project manager, I want to tell you that you start with the end first. Start planning for what your deliverables are going to be. Some of the challenges will make sense for you to have a demonstration that you have to prepare. So if you're using a screen recording tool, or you're going to stand in front of your camera or use your phone, make sure you understand how to use those tools today, because you don't want to be messing with how do I upload an iPhone video to Google instead of iCloud, or how do I get the sound fixed on this video. You'll want to understand those things now. Now, the demonstrations you do are really short. I think they're 30 seconds. I mean, really short. If you go way over, no one will see the rest of your demonstration. So make sure that you understand all the submission guidelines, and there are facts and documents out on the Space Apps Challenge website to give you hints about that. Your deliverables, of course, will vary based on what sort of project you're doing. If you're building art, chances are you'll either submit the art digitally or a photo of it or a performance of it, one of those things. So it depends on what you're delivering, will depend on what the format and the content of what you upload. Your project demo, because it's so short, if you're doing an application, you want to demo the things that will give judges the best understanding of your vision for what you've built. Not necessarily a lot of details about how it all works. You're really pitching this solution to people so that they understand it best according to the judging criteria, which is also available on the website. You have to use the submission process in order to do these things. And so it's really important. I help with some of the judging and screening the submissions to make sure they're complete. And I can't tell you how many people I know worked really hard on their projects, but didn't get their submission completed. And that's all the judges are going to have. So some tips about how judges look at your submissions. Completeness is really important. Don't skip questions. If anything, if you think a question doesn't apply, then say you don't think it does. It doesn't apply to your project because this. But I'm here to tell you, the judges are looking for your thoughts for every single question that they've asked you to answer in your submission. The other thing judges are going to look at is the challenges themselves. List what the goal of the challenge is. So they're going to look closely at your submissions, mostly at the words you provide, on how well it fits the nature of the challenge. So even if you've built the most wonderful database-driven web scale architected solution, if you haven't met the sort of request of the challenge, then the judges aren't going to be able to give it a lot of points for that. So they're going to look at the completeness of your submission and how well your proposed solution and vision fits that challenge. They're also going to look at things like innovation and inspiration. And that means that if your submission looks a lot like an existing solution out there, they're going to want to know, why is this different than something that's already in place? They're going to look at the impact of your solution on society, locally. I have a slide coming up just in a second about what that impact might be. And the other really important thing that a lot of people forget in their submission is there will be a question about what space open data did you use? The whole point of this hackathon in the Space Apps Challenge is to leverage NASA and the other 9 space agencies' open data in your solution. And not just as a little thing on the side, but it has to be core to what your solution is. Even the art challenge needs to have somehow leveraged NASA and the other space agency data, and also other open resources they might have. So there's open code in some places, there are images, so not just numbers and letters, but you have to realize that open data might include sounds, might include videos, might include images. So those are all really important to consider. The submission form will ask you to list the open data you used. And then a good judge is going to see, oh, I can see how that data appears or is utilized in the solution as you described it in your submission. So if you don't communicate that link between the data you used and what your submission is, the judge might miss that importance of it. So you literally have to show them in the part about the open data how you used it. So I just went today and looked up what the global awards are going to be. So there are things like best use of science, most inspirational, and then there are these new ones. I love these new ones. Best storytelling, the best way to connect people, the best art and technology, and local impact award. So while you're thinking about how to solve the challenge, if your goal, not everyone's goal who participates in a hackathon is to win a global award, but if your goal is to compete at the global level for awards, make sure you understand what the awards are. This best use of technology, that's really broad. Best use of data, really broad. So there's certain things that you could, words and ideas and goals and visions that you could put in your submission that would help judges understand, oh, that's a really great use of data. Oh, I can see how that would be a huge local impact on this. So it's not, the judging isn't, is your coding style following an international standard? I mean, if you did that, put that in your submission, that makes it a stronger submission. But the awards are based on these criteria here. So as a classic NASA saying, failure is not an option. The other way to really hurt your chances in the hackathon is to not follow the rules. Now, there are rules about conduct, very, very important. There are rules about when your submission has to be finalized. There are rules about how many people on your team. There are those sort of what I call administration rules, but there are also rules like you have to use open data and open resources in your solution. That's a rule. And if you don't do that, then your submission won't be passed along for other judging levels. Make sure you answer, I'm just going to keep saying this, make sure you answer all the questions completely. Another thing to do is that, you know, there might be answers or questions in there that you think are asking the same thing, like what's the difference between your project vision and your project goals? Well, those are great questions. They aren't the same thing. If you feel like you just need to copy and paste the same answer in all the boxes, that's not going to help your submission. So if you don't understand the question, come into Rocket Chat to get help either from ambassadors or the subject matter experts to help understand what they're looking for in those questions. I also think it's really important. I mean, technically this is a competition, but I think it's important that you ensure that you enjoy your time. So if you're getting stressed, if you're getting tired, if one of your teammates has disappeared, just sort of let it float away in microgravity, come back to what your true goal, what you stated at the beginning was your goal. And your goals might change and your ideas might change and your vision might change, all okay. It's just, don't let that get you down. Come into chat, ask a question. That's why we're here. So I did mention, I'll mention again, you must use open data and open resources from the space agencies that are participating. And there's my lovely Canadian Space Agency, just putting a shout out for them as well. So the most important thing is study the challenge, the details of the challenge, understand the nuances of what they might asking for. If you are participating, let's say in the ontology challenge, your deliverable needs to be ontological. It can't just be some code that kind of hints around what the challenge is. So I'm a data architect. I consider my job mostly data forensics. And I'm here to tell you that if you have a vision of an app you want to make, finding the data that's going to help you do that is going to take longer than you think. So after you've studied the submission form to understand what you're going to have to provide at the end of the weekend, now you're going to start looking for data. And you might need help finding data. You might find out that the data that you're for sure exists doesn't exist. You might have to find it from other open data sources. So a question that comes up all the time is, can I use like national or state or local government open data? Yes, you can, but you still have to use the space agency data as part of your solution. Understanding the data you find is going to take you longer than you think as well, because you might not understand what each data item means. You might not understand that there are many ways of describing a location on a point on the Earth. You might not understand that there are certain acronyms and terms and codes that are common to rocket science or planetary sciences that you don't understand. The way you can get help with that is there are often metadata documents, so documentation around the data to explain what it is, what its limits were. A lot of times there's not, but sometimes there is. And then you can also ask the subject matter experts in Rocket Chat, but you'll want to start trying to get those answers earlier rather than in the middle of the night when the SMEs, subject matter experts, might all be sleeping. Data set owners in the challenges might not be available when you are to answer these questions. So we can help you with that, but we can't guarantee we can get those answers. So the sooner you get the questions is, the more likely you'll get an answer. And I also want you to remember that data is weird. 35 years I've been working as a data architect, and I can tell you it's weird. So there was this news story a while ago about a 17-year-old guy in the UK found flawed data on the ISS, on the space station. And he noticed with data that if an energy detector had no data, there was a negative reading recorded, a -1. But you can't get negative energy, so it was a flaw. And the press reported that even NASA experts could not explain this. Well, I'm here to tell you that putting a negative number for missing data is very common in data sets rather than putting a 0. These are null values, null indicators. There was no energy reading. No energy reading is completely different than a 0 energy reading. So I knew this story, the media got it. I mean, it was a great story. But the media probably didn't realize that a -1 usually means missing data, not -1. So you'll run into these fun data facts as you work with the data. You need to budget time for understanding the data. Understanding the data is really important for your solution, what you're building, to be correct. So I have a recommended process for you that you should start with finding the data and resources for your challenge, understand the data and ask questions from the subject matter experts, understand the submission questions, maybe even appoint a team member to be responsible for gathering that data during the whole time you're working. Assign responsibility to each team member to answer certain questions. Plan for how you're going to demo your project. This is even before you build it. Set time boxes for each phase of your project that says, like, for the next 4 hours, we're going to find data and understand it and understand how to access it and how to use it. And for the next 2 hours, we're going to build screen user experience mock-ups before we even build them. Like, time box your stuff. If you get it done early, that's great. Have a break or start your next time box. Then once you've gathered all these resources, start your project. Develop your demo and answers as you go, and submit your project, giving ample time to submit it in case there are issues. So you'll need to show how your solution works. You have to understand the tools you're going to use to record your demo and know how to use them before you start. Really important. The other mistake that a lot of teams make is you're going to be required to upload your deliverables someplace on the internet that everyone can get to. And it's very common for teams to accidentally upload it to a site that needs registration or a login to get to. That's not going to work for the judges. It's not going to work for everybody else. So you need to test the links that you provide to the judges to make sure that they do not require a login. That might mean starting an incognito or in private browser session to get to the resources to make sure it doesn't have a login before it. People will reach out to you if your links aren't working or they're broken. But if you don't respond in time, then the judges won't have access to your deliverables, and that will make it nearly impossible for them to judge your work. Use all the help that's provided to you. There's all these guides and frequently asked questions on the website. Make sure you meet all the criteria that you've time boxed, and start your submission now and leave time to finalize it at the end. So ask your questions in Rocket Chat. Ambassadors like me are here to help you. Make sure you've fully shown how your project would work. Make sure you fully expressed how you're meeting the challenge, and then give yourself a great high five when you're done. So that's all I have. We've got a few minutes for questions. I hope to get to meet you all on Rocket Chat.
Thank you so much, Karen. That was super informative, not only for space apps, but for hackathons and even real life in general.
Yeah, I use these tips in my own job. So
yeah, I'm sitting here thinking about my last review and how some of these tips could come in handy now. But we did have some questions. I know the answers to them, but I think they were geared towards you. How many years or how many times a year does the hackathon run, and how do you put through an application? And then what is the age range, if any?
are we talking about the hackathon or
Yeah,
Data
the space apps.
Okay, for space apps. So normally it's once a year. I know last year there was a special COVID one because the Space Apps Challenge was delayed or canceled. I don't know what the right word was. I think it was just delayed. And I believe so I know kids can participate, but I think only with a parent or guardian. And to sign up for a team and you can participate as an individual, you go to spaceappschallenge.org, right? Did I get it? Is it org, right?
Yeah.
To go sign up for your team, and you can sign up with your local event, even though it's all virtual this year, completely virtual. So there's no place to go for your local event, but you can also sign up for the Universal Challenge, which is the part I'm helping with primarily. Awesome. Did I get that right?
Yes, you did. Yeah, it's you can have any ages, you're right. Under 18 just has to have parental supervision.
Yeah, and there are a lot of kids that participate even in the coding parts, but I especially love the times when kids have participated in the hardware challenges where they have to build something. That was really
cool. We had a couple years back, we had, I think, a 9-year-old, and she built a prototype of her. It was to clear the ocean of pollution.
Oh, nice.
It was like to catch things, a net type device, and she actually built it with like straws and things that she found.
Nice.
And it was so amazing. So
yeah,
very much looking forward to it.
At the Toronto Space Apps Challenge, we had a child and his father who made like a Canada arm that worked with his arm, and I thought that was really cute.
That's cool. That's awesome.
Someday, if I retire from being a mentor in this program, I'm going to try some art challenges because I like art and data together. I think that would be cool.
Amazing. Yeah, I do too. I wish I was more creative. So I'm going to have to I'm gonna have to get more into the creative challenges at some point.
Yeah.
But I don't see any other question. Oh, wait, we do have one Q&A. Oh, I love your username from Anonymous. That was the only other response that we had. So thank you so much. I really appreciate you taking the time to not only present here today, now and later,
Yeah.
but also your dedication to space apps and the NASA programs in general. It's inspirational to myself and I'm sure our participants. So thank you so much.
Yeah. Thank you. Have fun.
Thank you. All right, guys. So our next presenter is Mr. Wade Minter. Wade is a tech executive as well as the NHL announcer for I believe it's the Hurricanes. Wade, am I wrong?
You are correct. It is the National Hockey League's Carolina Hurricanes.
There you go. It's that announcer voice that I haven't heard in so long.
It's been a while.
Wade is going to talk about why you, and yes, you, should support junior developers through his experience as a longtime hiring manager. He's going to share some actionable techniques to help you recruit and retain and promote new developers. I know personally, I've been looking at jobs that they say 6 years experience. And I'm like, how am I supposed to get experience if no one will hire me? And so this talk I heard a few years ago in London, and it was so inspirational to me that I wanted to bring it to our symposium today. And Wade, I'm sure, has made it even better over the years. So Wade, I will let you take it from here.
Excellent. Thank you, Katelyn. It has been way too long. Thank you to everybody out in the audience for having me. The topic is why you, yes, you, that's right, I'm talking to you, that person on the other side of the screen, should support junior developers. It's a passion project of mine, something I feel very strongly about. And I'm looking forward to sharing that with you today. It has not a ton of relevance to NASA, but hey, it should still be fun. So a little bit about me. I am coming to you from beautiful Raleigh, North Carolina. I do actually have a small tie to NASA. In 1997-98, I was a system administrator at NASA Goddard Space Flight Center in beautiful downtown Greenbelt, Maryland, until I got sick of DC traffic and left for Raleigh. But I've been hiring software developers for well on 15 years now, and I have seen a fair number of things that I think we should clean up as an industry. And so I made this talk to go over those. I will probably be snorting at you because it's allergy season in North Carolina and my immune system and genetics are weak. Sorry about that. But this is me. This is also me. I do a lot of other weird stuff. I play hockey. I announce hockey. I do improv. I'm a professional wrestling ring announcer in addition to all the tech stuff that I do. Multidisciplinarians of the world unite. So now that I've told you a little bit about myself, much in the style of Humpty Hump, I'll tell you a little bit about this dance. There is some terminology that I will use here. The terminology I will be using is the term junior developer. That term is not often considered great, but we don't have another good term for it. Other terms that have been used to illustrate the same concept are entry-level developers, early career developers. I'll use the term junior developer because we as an industry haven't settled on an alternative. But just know that that's what I'm talking about. Junior in terms of career progression, not in terms of necessarily ability. Also, it's an interactive thing. If you got questions, ask me questions. I may answer them. I will also leave time at the end to answer them because I've been thinking about this for a long time. So in the words of Admiral James Stockdale, who am I? Why am I here? I've been hiring folks for a while, and I've got peers who've been hiring folks for a while. And I see a lot of things that I think need to be better. People don't want to hire junior developers, and that is problematic for a lot of reasons. Number one, we need to hire junior developers because if you don't have junior developers, you don't get senior developers. I don't know a lot, but I do think I have that concept of linear time down. People who are working with new entry-level developers coming into their organizations don't know how to support them, and junior developers themselves have a hard time trying to find that first job. And so In this talk, I talk about some things I've seen, things I've heard, and things that I think we all can do collectively to make this a better place for everyone. Now, hiring managers, if there are any of you out there in the room or on the live stream, this is directed at you. I'm not sure if you knew this, but developers are expensive and hard to find. It costs a lot to hire a developer here in the US, and everyone is got lots of job offers. It is a crazier time than I've ever seen in my 25 years in the industry. Glassdoor tells me that a senior software engineer on average nationwide makes about $130,000 a year. I say that is crazy low. Even in Raleigh, which is a very kind of mid-level market in terms of salary, you're getting a lot more than that if you're a senior developer. And, you know, the total comp of folks out on the West Coast, also pretty high. Also, recruiting, it's hard to do, and it's getting harder. If you are an experienced developer out in the world, you're probably going to have multiple job offers as soon as you say, hey, I'm thinking about lead. And there it goes. It used to be back in the before times that you could have pockets of geography where that wasn't really happening. But with COVID and everyone moving to remote work, now you're competing with developers nationwide and or worldwide. There's a lot of money flowing into the tech market, and that money's got to be put to work. And people put that to work by hiring developers to build new things. So it is definitely a seller's market in terms of developer talent. If you want to poach a developer from some other company, you need to have a compelling pitch. You got to give them something that they don't have already, and that's getting harder and harder to do as everyone keeps upping the ante. And all of that being said, it is very hard to hire experienced developers, but a lot of companies will have their jobs go unfilled for months, if not longer, before they consider hiring an entry-level developer. Why is that? Why are we not getting our work done? Why is the only way to progress to poach somebody who's already done it from another company? And I hear a lot of excuses when I talk to hiring managers about why they don't want to hire entry-level developers. I'm going to reveal a few of these excuses and tell you why I think they're wrong. If your hiring manager thinks differently, then I don't know, they can come talk to me, I suppose. So in the early stage startup community, where I spend a fair amount of my time, I hear, oh, we're too small to hire an entry-level developer. And there is an element of truth to that. However, I hear companies that are way too big trying to use this excuse, and I think that's not cool. In my view, having been out in the industry for a while, if your development team is, let's say about 4 people or more, you can absorb an entry-level developer into that team. If you're under about 3 or so, then fine. I will let you use that excuse. I won't judge you too harshly. But if you've got about 4, you're starting to specialize, you're starting to get some structure, you've probably got an existing product. That is a great time to bring in someone new to help you out. If you're using the excuse of we're too small, you probably have budgetary concerns. So unless you can find technical founders to work for nothing but equity, which is possible but not probable, then budget is going to drive a lot of your decisions. And if you can find someone who can work with you and help you build your product for a budget that works for you, all the better. I also hear from folks that they won't hire entry-level developers because our work is too hard. We are so smart. We are doing such cutting edge, brilliant, next level technology that, bless your heart, which we say in the South, no entry-level developer can possibly come in and understand what we're doing. And yes, there is legitimately cutting edge work that requires advanced degrees, specialized knowledge. That is a thing that happens out in the industry. I doubt your company is probably doing that. Most of the internet is built on taking something out of a database, putting it on a screen, doing some stuff to it, and putting it back into a database. That's a lot of what the internet is built on. So if you're trying to use the excuse of, oh no, our work is too hard, we can't possibly bring in an entry-level developer, really kind of think about it. Are you? Are you really, or are you actually just believing your own press releases, which is really one of the more dangerous things someone can do? If you look at it yourself honestly, you probably have some work in there that is not necessarily cutting edge PhD level work. And it still has to happen in order for you to have a product. In general, being honest internally with yourself about what you do will help you make better hiring decisions across the board. But if you're trying to use the excuse of, our work is too hard for an entry-level developer, try to have a reality check. I think you'll be surprised at what you find. I know that most of my friends who I ask that question to, and they try to explain it to me, tend to come to that realization. And another excuse that I hear from hiring managers, and this is the one that actually kind of gets me a little hot under the collar, is entry-level developers aren't in it for the right reasons. And quite often, this is used when you're talking about developers coming into the industry from a non-traditional background. All you people coming out of Stanford with your bachelor's of computer science, you can sit down. They probably are not saying this about you. But if you're coming from a non-technical career, if you're coming through a code school, if you're coming from a self-taught background, you will have people out there in the hiring world who say, oh, I'm not going to hire you because you're not in it for the right reasons. And when I press them on this, because this is a somewhat confusing statement for me, it usually means that from the hiring manager's perspective, people are coming into the tech industry because they want money and not, I guess, for the pure altruistic love of the game that the rest of us do. True story. I've hired a lot of developers over the years, and I have never been in a situation where I have recruited, interviewed, vetted a developer candidate at any level, put together an offer package for them, got it approved through the management chain, presented that offer to that candidate. They go think about it. They come back to me and they say, Wade, I love the company. I love your mission. I think it's a great team. I really wish I could join you, but I'm going to have to ask you to give me $50,000 less than you've offered. It doesn't happen. That is not a thing. We are all in it for the money, and you can debate whether or not there is any ethical consumption under capitalism. But if you as a hiring manager are poo-pooing an entry-level developer because they're not in it for the right reasons, you need to go check yourself, because I think that is a very toxic idea. Developers coming into your company from outside of the world of kind of pure myopic tech tend to have a perspective that is very different than folks who have focused on engineering their whole lives. That perspective will help you build better product. I guarantee it. And the way you get those folks is you get people coming in from outside the industry. You find a good code school. You find a program in a community college. You find people who had previous careers and are now kind of tech adjacent and want to get into development. Support those people. I promise you, you can take this to the bank. You will build better products. Now, if you are on an engineering team and your engineering team may or may not be getting entry-level developers into it, there are things that I hear from you as well. First off, we don't have time to babysit a junior developer. There's this idea that there's a mythical developer out there who you can bring into your code base, you can bring into your company, you can bring into your processes, and day one, they understand everything and are super productive. And I'm here to tell you that person doesn't exist. I've been in software development for 25 years now. I have come into code bases left and right. I have moved around. Every time I move, have to take time to ramp up. So this idea that a entry-level developer, a junior developer, is going to require babysitting where a senior level developer will not is a false idea. Everyone's going to take time. Senior developer will ramp up faster, but they have learned how to ramp up faster through the scars of their career. If you have the ability to bring in a junior developer to your team, and you have the ability to help them level up, and you have the ability to explain to them why your code base is set up a certain way, why your processes work, it will help you as a team understand your own processes better. If you have to explain something to someone else, it makes you think about it. If you have to think about something like that, then you will understand it better. If you don't have time to explain your processes or take a look at your code base, you probably got bigger problems at work, and maybe you should work on those instead of trash talking junior developers. Because the truth of the matter is, in any technology company with an existing product, not all the things you do are senior developer work. There's work that is absolutely core for your highest experience, most valuable developers. You should have them working on that. If you don't have a good mix of senior level, mid-level, and junior level developers, you're gonna have to take people who are up here and have them work on things that are down here. The basic blocking and tackling of keeping a software application up and running requires all sorts of different types of work. And if you're taking a very expensive, hard to find senior developer and you're putting them in a rotation to handle rote tasks, that's not really a great use of your senior developer money. However, an entry-level developer who is trying to figure out how to get into the industry, how to contribute to a software thing, that's going to be learning for them. That's going to be new. They're going to be excited by that. They're going to want to contribute. So if you assign the right work to the right people, everyone is going to be more productive. Your mid-levels are going to have a chance to start growing and mentoring. Your seniors are going to have a chance to lead. Your juniors are going to have a chance to learn. And everyone's going to be excited about the work that they have to do. So find the work that is suited for entry-level developers. I guarantee you it's there, and assign that to them. If you bring them into your company, you will be able to assign the right work to the right people. And hiring entry-level and junior developers is a great way to make your engineering team more diverse. Through 30 or 40 years or so of systemic neglect, the ranks of the senior engineering world have been kind of thinned out of folks who don't look like me, with or without hair. We've built a very significant monoculture by driving out women, minorities, people who are outside the socioeconomic spectrum. There's not many of them out there, and that is unfortunate, and that is a problem that at least we're starting to recognize. But I can't make that senior developer who left the industry 20 years ago magically reappear. We drove her out. That's on us. So if you're hiring at the senior and kind of mid-senior level, your choices are pretty slim in terms of having an engineering team that reflects the world at large. However, lucky for us, the ranks of people coming up into the industry much more reflect the world at large. You have a greater variety of race, gender, sexuality, socioeconomic spectrum, age, all of those things that make the world what it is. And so if you're hiring people who are coming in with no experience, and you do, and I hope you do, value the fact that an engineering team that looks like the world at large will help you build products for the world at large, it's a lot easier to make the hiring choice of someone who will bring that added level of perspective into your team. Developers with non-tech life experiences are amazing. Some of my favorite developers have come through that world. And if you go looking for them, you find them, you support them, it will pay off in spades when you're having discussions about how to build your product. And for junior developers themselves, for those of you who are looking for your first job in the industry, those of you who want to get into the industry, those of you who are at the hackathon because you're driven by a desire to get in the tech world, there's some things for you as well. First of all, realize that none of this comes easy and natural to most everybody. Having been around the industry for a while, I can assure you that hell is other people's code. And when you leave the training program that you're in, whether it's school, whether it's a code academy, whether it's your kind of self-taught tutorials, you're almost certainly not going to be in a position where you are building brand new things from scratch like you were in school. You're going to be maintaining other people's stuff. And that is a whole different ballgame to do that than build something new. Decisions that were made years before you are going to be at the forefront of your mind as you try to figure out how this code works, how to get the thing done that you need to get done. And as you look around the room, you'll see developers who've been doing this for quite a while. And just understand that everyone you see, no matter how good they are, was once at the same spot you are, trying to figure out how to make this stuff work, trying to compile something, trying to build something. We were all there. We all started at the same place. And some of us had a different type of aptitude than others, but none of us are any different than you are. And honestly, the biggest difference between a junior or senior developer is the senior developer has been through those lessons. They've learned, they figured out how to optimize things. They've made their mistakes, and they know those kind of innately. You haven't yet, but the important word there is yet. You'll get there. Getting that first job as a junior developer tends to be the hardest thing. Once you're in the club, you're kind of in the club, and it's weird, and it's kind of an anti-pattern in our industry. But getting the first job is very, very hard. Getting the second job is much easier. Getting the third is pretty trivial. So to get that job, number one, try to put yourself in the position of where a hiring manager will understand that all of those things that I said they've got in their head working against you are not problems for you. Find open source projects that you like, that you care about, that you're driven by. Submit PRs. That shows that you can work with a team of people that you don't know yet, have a technical discussion, make changes, get your code accepted, which is what you're going to be doing every day with inside of your team. Build something. Have a project that you've built. Talk about how you were able to make the trade-offs in scope. Talk about how you ran into problems and how you solved them. The more you can talk about the things that you have done to build and ship real product, the better it's going to be. If someone throws out a trivia question for you in an interview and you don't know the answer, admit you don't know the answer, but then try to talk about how that relates to something that you do know. Recruiters in the front door, they're very hard to get into. There are a lot of bad resumes coming through. Use your local network. Find people who are out there in your community who know people who know people. Have a coffee with a hiring manager. Have a breakfast with a CTO. Figure out how to use your network to avoid going in the front door where you're going to get overlooked, and at least let them know who you are. And one of the best interviews that I ever did when I was hiring was somebody came into my company for an interview, and they had built a small API client against our company's API. That showed they knew what we did. They knew how to make our product a little bit better. They leveraged the tools that were available. That is a underrated way to get yourself noticed. It doesn't have to be big. It doesn't have to be fancy. But if you can show you can build something additive to the company's product going in the door, you're going to stand out. And then once you're on the job, find people to help you. Find somebody who, in your department or not, who's willing to kind of take you under their wing. Find somebody who will let you vent to them. Be kind to yourself. You're not going to know everything day one. You're not going to know everything day 100. But understand that you do belong in the room. Try to put the self-doubt aside. You're a developer. You're a developer by building stuff. That's really the only qualification. And if you've done that, congratulations, you're in the club. And then for everyone else, there are lots of different ways to get into this industry, and there's no one path that guarantees success. Whether you're a CS major from Stanford or a CS major from William & Mary or a code school graduate or someone who just taught themselves, all of us have something to bring to the table. No one is going to be significantly better than the other in all circumstances. Play to people's strengths. Use whatever it is that they've done in their life to help you build great product. And so structures for success, things that I've seen that work really well. Have a gradual ramp up. Don't expect them to be shipping production code day one. Do discrete achievable tasks within a section of your code base that's relatively isolated. They're going to make mistakes. Let them. If they try something that doesn't work, that's awesome. They tried something. Have regular meetings with your entry-level developers. Give them constructive feedback. If you do code reviews on them and there are things that they need to fix in their code reviews, find something positive in every pull request. I guarantee you there is something there that you can point to and say, yes, that is good work. And don't expect anyone to be great on day one. And so if you're into this sort of thing and you think, I want to do this, but I don't really know how, here's a concept you can use. It's called a support engineer. They are a hybrid of a developer and customer support person. They work in your code. They're a product developer, but they sit with support because support gets neglected all the time. And they are the bug sponge. They fix what they can, triage what they can, and escalate the rest. Starting off, they won't be able to do a whole lot. I guarantee you by about 9 months of doing that, number one, your tech support people will be very happy because finally somebody's paying attention to them. But you're going to have a great engineer because they've been in all the dark, sticky places in the code to fix bugs because that's where the bugs live. And in 9 to 12 months, they'll be ready to join your regular product development team, have them train their own replacement, backfill that, and boom, you have an instant, reproducible, sustainable developer pipeline inside your company. And guess what? Happier customer support people. So my closing thoughts, you don't get senior developers without junior developers. That's linear time. And eventually us senior developers, we're going to get old. We're going to leave the industry. And if we as an industry are not supporting new people coming in, we're going to have a problem. Senior developers, they're expensive. They're hard to get. Junior developers, they're more affordable. You can find them. I'd rather have a developer working on something than not have a developer work on something. It's a mercenary world out there. Developers get poached left and right. If you are an employer who has the reputation of growing expertise inside your company, giving people an opportunity, letting them level up, it's going to be easier for you to recruit, and you'll also be able to have better odds of retaining your people. And plus, you might be helping your future self as well, because guess what? This industry is terrible to older people as well. And that junior developer you hire today might be the person who's given you a job when you're 50-something. And out of enlightened self-interest, I would love for that to happen. So that is me. Thank you so much. Find me online. Find me on the LinkedIns, the emails, the webs, the Twitters, the whole 9 yards. And thank you, Katelyn and company, for having me. I will be glad to answer any questions.
I can press the mute button.
Yeah, we're good. Technology, y'all.
We have one question. What are your thoughts on pair programming junior developers?
Yeah, I think if you are in a pair programming shop, pair programming with junior developers is a great way for them to learn because they can see how a more experienced developer thinks about problems, how they break down stuff, how they code, what are the styles, what are the conventions. And as long as you're not expecting them to be a true peer day one, I think pair programming in that context is a really good way to introduce them to the concept of how professional programming works. And just like the support engineer, let them fix the things they can, let you fix the things you can, and over time that will start to equal out. I personally, not a giant pair programming fan, but in places that do it, I think it's a great way to level up engineers.
Awesome. I just asked again in the live chat, but I didn't see any questions pop up there.
Clearly, I answered everything.
I mean, you kind of did. But yes, I definitely enjoyed this talk just as much as I did as a junior developer myself. And someone also said with such a wonderful voice as well. So yes, definitely the announcer voice. I can always hear it.
Yeah, it is a weird life I lead.
An amazing one though, and there goes the dog again, living in infamy forever. But thank you so much, Wade, for taking the time to talk about why this is so important. Like I was saying, I definitely enjoyed hearing it this time just as much as the last time I heard it, now with more perspective and more time in the industry. So hearing it this time around, actually as thinking about hiring, is definitely a new perspective. So thank you for taking the time out of your day and coming to our symposium today.
Thank you for having me. Good luck to everybody in the hackathon. Hope you have a great time, build something really cool. And if I can ever be of any help, certainly reach out to me online.
Amazing. Thank you. Bye, Wade.
Thanks, y'all.
Awesome. All right. Our next presenter is Dr. Raymond Capra. Dr. Capra is a old professor of mine. For those of you that don't know, I did major in classics at one point. And Dr. Capra is the coordinator of classics over at Queens College, part of CUNY, or CUNY. I don't know how people say it anymore. He's going to talk to us today a little bit about gazing at the stars, digging in the earth, and astronomy in the ancient world. We're going to learn a little bit about the relationship between ancient human beings and their observations and interpretations of the stars, and how that led to advances in human culture. And with that, I will let Dr. Capra take over.
Thank you so much, Katelyn, and welcome to everybody. It is with great pleasure that I speak to you, and obviously I'm changing up the subject matter ever so slightly, or rather quite a bit. And I must admit, I have to add one disclaimer that I had thought of while preparing this was gazing at the stars has somehow has led to some perhaps sidetracking in human culture as well. And so I'll make some reference to those. But basically, well, let me start this way. I grew up in the San Francisco Bay Area, and although it's a heavily populated area, the geography with its valleys and its hills have been rather good in kind of obscuring the night lights of the cities, and have afforded some rather remarkable starry skies, which I was sort of pleasantly blessed of. Still, while visiting Lafayette, California, I enjoy the night sky there, and the constellation Orion is, always presents itself rather boldly in the night sky. There we go. And I have to make a note that this picture was certainly not taken there, nor by me, and is obviously enhanced, but nonetheless, Orion's belt and limbs have always been rather, obvious, and it's always a joy to see those. I did the end of my graduate work in New York City, and then there was one point when I realized that I had not seen the sky for some, or that I had not seen the moon up in the sky for nearly a month, which I have to admit in some ways was rather disconcerting when one thinks of these things and realizes that, in fact, something one's so accustomed to seeing all the time. But nonetheless, for human beings in the pre-modern period, one can only imagine, the intensity of the night sky. And the rhythms of ancient pastoral life necessitated a change of grazing locations dictated by a change of seasons. And we're, beginning in, very old forms of human culture and human ways of being. In these change of seasons, it's a change that was reflected above in the movements of the celestial bodies. And so I say when people began to look at the stars as guides, certainly they were always looking at them, but when a realization that the movements of these bodies could be used as guides, we can't say for sure. But the first appearance of astronomical observations in the archaeological record demonstrates a well-advanced system. And this puts us into Mesopotamia, and this is the Venus tablet of Amisaduqa. It's also known as the Enuma Anu Enlil tablet 63. The Enuma Anu Enlil is a larger text from which it comes. This is a cuneiform tablet which describes and records the times of Venus's rise, its first and last visibility on the horizon before or after the sunset. And as I said, sunrise and sunset. And these observations were made, excuse me, and recorded over a period of 21 years. These dates were recorded in a similar fashion to lunar cycles, which of course is the basis for many a calendar system in the world. And so what do we have? We have the beginnings of scientific observation of the movements of bodies, and an understanding of the world and the cosmos is something that moves in a cyclical way. And this is different than a pastoral life that has, of course, is cyclical, but it's in a yearly cycle with some variations. Here we begin to embark on a greater understanding of these cycles over the long term. Theoretical and understanding of these can be applied to the contemporary experiences that human beings have on the earth. And so it's worth noting, right, that the greater text from which the contents of the Venus tablet come, and this is the Enuma Anu Enlil, it's a collection of nearly 7,000 omens which interpret atmospheric and celestial phenomena and their relevancy to the affairs of the king and the state. And so, of course, it's the application of these that is rather, interesting. At the same time, we have scientific information being recorded. We also have, something that many of us would regard as a kind of fantastic interpretation and application of this information. Right, is both the Venus tablet and its greater context illustrate the interpretation of the interconnectedness of the movement of the planets and stars and human affairs has led us along to some rather dubious paths of inquiry, but as well, it's led to a greater understanding of the composition of those celestial bodies themselves, right? And so there really is this tenuous hand-in-hand, astrology and astronomy in the ancient world that, has led us to various places. As I mentioned, the Venus tablet of Amisaduqa recorded the rising and setting of Venus for a 21-year cycle. So it's important to remember that the data of the ancient text was itself the product of a long study compiled presumably by a team of scientists of the day and then handed down for thousands of years. And as I had said, the text as we have it comes from many centuries after we know the data had been written down. Various authorities, both scholars of Mesopotamia and scholars of the night sky have dated some of the events that are referred to in the rising and falling of Venus, and and it has given some pretty good dating in the mid-second century, in the mid-second millennium, so about 1500 BCE. And of course, observations such as these began the process of liberating mankind from his intellectual dependency on the environment immediately around him, as a means to anticipate and understand the changes of the seasons, to something more akin to a calculated understanding and reading of the night sky as the harbinger of change. And of course, in modern ways, again, being a Californian, it's like talking about El Nino cycles, right? We don't think in terms of a single 4 seasons throughout the year, those changes throughout a one calendar year, but again, right, these longer atmospheric and celestial phenomenon that are affecting how things work. And of course, what we get out of this are great advances to agriculture, right? If we can have an understanding of what, how the movements of bodies are going to bring rains, rather heavy or small, it allows societies to store allowed societies to store resources and prepare for harder years, and again, to take advantage of those good years that were going to come, or even to understand how, again, interpreting celestial phenomenon could lead us to an understanding of what was going to happen on Earth. And so, this is a knowledge that was not, of course, akin only to Mesopotamia, but was shared throughout the world. And of course, to the east in India, an equally sophisticated system of observations developed. And there's an important text, which is the Vedanga Jyotisha. There you have a little excerpt from it on your screen. And this describes the winter solstice, amongst other things, for the period of about 1400 BCE. And again, this was a celestial observation that had been carried down and handed down and became part of a scientific knowledge, right, that this culture was in possession of and was able to evaluate, and using these same kinds of calculations, not only to look backward, but also to look forward to see how these cycles would come out. The book, as we now have it, is written in a much later period, but it stands as another example of the compilation of all of this information based on the study of planetary movements. And of course, what do we do with this information? Well, the application of this knowledge was to find within the predictable movements of the stars a means for interpreting the events that would transpire on Earth. And of course, they're just the people who were gazing at the stars and doing their mathematical calculations. And this is one angle of it that I won't speak so much about, but of course is the development of the arts of mathematics underneath all of this that had to exist and able to be able to perform these sorts of calculations. But when we talk about reading the movements of the stars for a way of interpreting the Earth, for knowing when to dig the Earth, when to plant our crops, when to get our harvest, how to prepare for the wane years, and what to do when we're going to have years of abundance, and how to deal with all of this cyclical nature. Herein lies a metaphor for humanity's self-understanding of its role in the universe. Right? We're no longer see ourselves as scratching out a living under the heavens. Instead, we are part and parcel of the universe. Well, let me restate that. For mankind's perspective, and that is from the inside looking out, looking from our Earth and gazing upon the stars as we stand with our feet on the Earth. This, of course, assisted in the perpetuation of the most obvious of our error in the entire history of stargazing, right? That we are the center of the universe, not only intellectually, but also physically. And this, thus, the geocentric conception of the universe, was something that was going to persist. But getting back to India, in some of the greatest texts of India, and the one that I'm going to, give you a small taste of comes from the Ramayana. And again, this is a text that exists in many versions in many languages throughout the world. The sort of central text is assigned, and most prominent version assigned to a poet by the name of Valmiki, and that's where this little bit comes from. But what we have in this story are the dark Rama, they're the bluish greenish one, and his brother Lakshmana. They've been sent into exile for 14 years, 12 years in. Rama's bride has been abducted by a demon, and they go off to battle to retrieve her. And as they are approaching the shore of southern India, they have to cross the ocean to get to what is now modern day Sri Lanka. Lakshmana says to his brother, reading the celestial phenomenon as he looks at the sky, and he tells him, the sun, maker of day, is bright. The Bhargava Shanas is shining with bright rays behind you. The constellation Brahmarashi is clear, as are the great seers, which shining brightly, all encircle and illuminate Dhruva, the North Star. And this learned text has been read, as I said, for centuries in numerous countries. And for example, in Indonesia, which is, of course, a country with a quite different, cultural perspective these days, it's an extremely popular text. And not only presented as a piece of literature, but it's presented in plays and in dance. And just to point out, right now in India, that they're producing a movie version of it with one of the great stars of India by the name of Prabhas, who just, starred in a two-part movie that had been the biggest budget film in the history of Indian film. And of course, the next film on Rama is going to be, of even larger budget. But nonetheless, just to show, right, and again, what's being perpetuated in the continuation of this story, right, is an understanding of the entire universe being read. Human affairs and celestial affairs, are one and akin to one another. And indeed, this astrological way of thinking is still a well-practiced art, in the Indian subcontinent, I suppose, in North America for that matter as well. And just to refer to a few other countries before I discuss something a little smaller and less well-known, is, for example, the Chinese began detailed records of astronomical observations during the Warring States period, that is to say the 4th century BCE, and started to produce these star charts. Here you have, one that comes from a much later period, but nonetheless, which is a perpetuation of that information and that knowledge. Shi Shen and Gan De, were the two prime astronomers of this era and responsible for the earliest data that formed star catalogs. And again, what I have behind me is another version of one of these. And of course, divination was an integral part of the application of this information. However, you know, the way that these two things coincided is quite interesting. So for example, the supernova, which created the Crab Nebula, now referred to as SN 1054, was one astronomical event observed by ancient Chinese astronomers. Of course, this happened in the year 1054 of the Common Era. And this was referred to as a guest star. And so the appearance of guest stars were something that was able to produce, you know, was used as a way of predicting fortunes, whether like often for the state and for emperors, right, whether affairs were going for them or against them, in the same way that Lakshmana was interpreting that information. Another thing that came out of this tradition of Chinese astronomy and astrology was that they were able to predict lunar and solar eclipses with great accuracy, you know, before the advent of Western forms of astronomy that were actually, you know, brought there by Jesuit missionaries. And so, of course, well attested in the astronomical observations made by the Egyptians, the orientation of their temple architecture, and again, we have, you know, some records of this within Egyptian hieroglyphics in their literary record. But I'm going to pivot to a smaller, though contemporary, that is contemporary with the Egyptians, location in the Mediterranean, and that's Malta. Right, I've made mentions of the great civilizations of the past and their engagement with and use of the observations of planetary and stellar movements, you know, both for the obvious reasons, in particular in dealing with agriculture and when we should be digging up the earth by following the movements of the stars. But these are ones that have been, you know, assisted to a great deal by the ability of a large successful empire, whether we're talking about Egypt or China, right, or India or or Mesopotamian culture. And I mean successful in that they were able to feed a large population with the resources that they had, were able to acquire the resources to be able to do that. Malta is in the middle of everywhere, and still it's in the middle of nowhere, as you see there. It's, you know, the map shows you two islands. These are the populated ones. There's a third, even smaller little island that is only inhabited part of the time by a priest who's on the one little church, and in the rest of it is a nature reserve. But nonetheless, a thriving culture sprang up there in the 4th millennia BC, and we know this by means of the archaeological record. There was no evidence of writing whatsoever by this culture, but we know a great deal, right, of the trade that they had with Egypt and the other cultures of the day because of the objects that were gathered there. And certainly to be engaging in trade, they had to be able to produce something that was worthwhile to other cultures. And being in the middle of the Mediterranean, you know, still as it is today, you know, Malta is a thriving port of trade. So just to point out that the larger island of Malta, it's about the size of Manhattan. It's rather small, it's rather sparse. Previous to humans getting there, it's famous for having pygmy hippopotamuses, which were the size of, you know, sort of medium to large size dogs, right, that ended up on the island. And this, you know, becoming small size is a phenomenon that often happens in places like this. But one thing that we do have happening in Malta, right, are the construction of these megalithic temples throughout the island of Gozo, the northern island, the island of Malta. These were built between, you know, 3600 BC and 3600 BCE to 2500, and they're unique in the fact that they're the earliest freestanding stone buildings in the world. You know, compared to the pyramids, of course, they're not huge, but for a small land with scarce resources, right, they're a real achievement in terms of the architecture and the way that this culture produced them, and did so without, right, the resources of larger lands and peoples. And so these huge stones, right, that were dug out from the rocky island were put together. And of course, this becomes the question, what was the purpose of these? And so here I show you one of the older temples of the island of Malta, which is Agar Kim. You can see these sort of apsidal structures, right? These large walls were built around them. Here you get a glimpse of the inside. What is most notable, right, about these becomes the orientation of them. And so, for example, the orientation of the southern temple of right, of Agar Kim, just flipping between things, is it and another temple complex that are about 500 meters away, right, is that the orientations and the entrances of these were linked up with celestial phenomenon. And so, for example, here we go to the island of Gozo and Gigantia, right, and you can see all of these lines represent they again tell you this when we started off in some earlier phase, even, right, in a much smaller way, right, but that all of these markers of the summer and the winter solstice. And even though those change slightly over time when we're dealing with the elliptical nature of the sun and the moon, and there was some start adjusting, as they say, that a transition that goes on, right, from a sort of one apse to another to collect these, and the ways that they hit various stones along the wall. And I'll show you a sort of interesting example of that. And so here's the Menajra complex. There, just here's a larger slide of it. My slides in the wrong order. I'm very sorry for that. But it's this, later addition right here referred to the solar temple. And so, of course, this is the rather, exceptional characteristic of this particular temple, right, is the orientation of the south temple. The buildings aligned astronomically to mark the rising of the sun during the equinox and the solstices. And you can see right straight through during the equinox, and during the solstices, coming in at this angle. During the equinox, the rays of the rising sun pass directly through the main doorway and reach the innermost central niche. During the summer solstice, the first rays of sunlight illuminate the edge of a decorated megalith found within the first apse. And of course, the same effect is happening on a corresponding megalith in the opposite apse during the winter solstice. Right, and so of course, what does this suggest? Right, what does this phenomenon tell us? That we have a prehistoric society, right, a non-literary society that built these monuments, that they observed the motions of the stars, the moon, and the sun, and they related them to the changing seasons and the times of planting and harvesting crops. And again, what has to be stressed when we're talking about Malta here is that we're dealing with, scant resources. And so being able to acquire this knowledge, of course, it has its ritualistic, religious nature, but it has, right, also the practical application of how to deal with the proper seasons, and not only on a yearly basis, but also on a cyclical basis. And so, and of course, the extension of these over a period of, over 1,000 years, right, emphasizes the ways in which they're dealing with the shifting skies and stars, but also the success of this society, again, that was able to produce these. And so Agar Kim, which again is 500 meters away from that, we have this very interesting thing called the calendar stone. And what the calendar stone of Agar Kim is it's this stone, right? And here on the right, you have a sketch of all of the carving on it. On the left, you have a close detail photograph, right, of some of the stones. is that or we have the stone with all of these drilled in holes and right aligned rows that can be linked to several periods of the moon's phase. And I will quickly give you some understanding of how these particular one. As you see, we have 7 rows, right? And so the first row talks about the 19 years of the Metonic cycle, which is a cycle that goes for 6,940 days. And after this period, the moon is the same lunar phase and the same ecliptical latitude and the same ecliptical longitude. There are 19 holes in that row. And of course, they didn't make this right over a period, they did make this over this period, as they say, we have this, but a 19-year cycle. So again, akin to our 21-year cycle of observing the rising and setting of Venus, is that we have this similar kind of understanding, right? The second row is composed of two rows, one of 16 on the right, 13 on the left. Talks about it's from the days that the old moon is still visible until the next full moon. And together we get 29 holes and 29 days. And thus we have a full month being brought out. And so at any rate, just I won't go through each one of these rows and, bore you with those other details, but the final row there has 53 days, or 53 holes. And so what does that represent, right? The 53 weeks of a tropical year, 365.2 days, right, from the ascent or the descent of the Pleiades unto its next cycle. And so again, we have something, getting akin to our modern calendar, all through this understanding of the movement of the stars. And so this knowledge that these people were able to take from here, right, led to, of course, great advancements that we're achieving today. And certainly, we're talking about all the time as part of NASA, but I just am here to remind you, I suppose, that it's a very long process of the accumulation of human knowledge and human observation, as important back then and central to civilization as it is now, and applied in the same way. Of course, that and I'll make my last comment that I have to bless the satellites up in the sky that my internet did not have any problems, as far as I know, while I was giving you this talk. So thank you very much for your time, and it's been my pleasure to speak with you.
Thank you, Dr. Capra. I always say that I learned the most in your webinars and your live talks. So thank you so much for taking the time today to speak with us. I think it's so interesting, like today it's so easy. We look at our calendars, we know how many days are in a month, and back then they didn't have technology. It's just so crazy to think of how they were able to do the things that we do with such ease, but and with such precision, down to the sun falling into the direct hallway it needed to fall into on the equinox. So very interesting. Thank you very much for your time today. I didn't see any questions, but does anyone have any questions for Dr. Capra before we head off into our next talk? Awesome. Well, I don't.
Hello. Hello. Thank you.
Hi, actually, I'm co-host. I loved your talk. Thank you so much. And I did have a question that I wanted to ask if no one else had any. It's fascinating to discover that for ancient civilizations, astrological observations inform, star charts and catalogs, divination, orientation and purpose of architect, and planting season, just to name a few from your own talk. So my question is, how do you believe our relationship with stargazing has changed or remained the same since these earlier periods of civilization? And what do you think our relationship will look like in the future as we continue to pursue space exploration?
It's, I suppose the way to say it in some ways, what Katelyn's comment kind of summed it up. We've gone from a world, I believe, where everybody was stargazing, almost out of necessity, right? Just having some understanding of the moon, for one, because it was there and it was one of the, once the sun had gone down, it was actually a source of light. But, and again, by virtue of not having, modern light, for those of us living along the coast, which is a great part of the population, it's become something, sadly, right, that's, fringe now. And thankfully, people we're still talking about in some ways, even at least abstractly, is, to get people out there. And I can just say, like, if you think back a few years, the excitement that was generated by virtue of the solar eclipse in the United States, right? And people traveling, extreme distances to go see these eclipses, as, they can do any part of the year. I suppose most of them happen over at the ocean. So it's rather difficult to get there, but nonetheless, it's still, I suppose, something that's part of us, but nonetheless, it needs a little more promotion. And of course, the fact that we are dealing in a world of satellites is something that we all should have a good understanding of how all of these planets work and how everything works up in space.
Awesome. Well, thank you, Dr. Capra. Before we head into our next speaker, I just wanted to, you just saw Dominique, I just wanted to introduce her. She's going to take over emceeing for me for a little bit. So Dominique is a co-director of Space Apps NYC with me. So Dominique, I will hand it over to you, and thank you once again, Dr. Capra.
Thank you so much.
Thank you, Dr. Capra, for your presentation, and thank you for the introduction, Katelyn. Hello, everyone. Like Katelyn said, I'll be helping to MC some of the presentations today. Up next, we have Sean Keegan from Postman. His discussion will be on exploring intergalactic APIs with Postman. It's a bit of a workshop, so it's to teach you all how to use APIs, and we'll get the opportunity to use some open data and NASA data. So in this presentation, we'll learn a little bit about the fundamentals of API by getting hands-on with Postman. You'll learn why web APIs are the glue that holds everything together on the web. We will walk through Sean will walk through different HTTP methods and see how each method allows you to retrieve and update information in your web application. Together, we'll all explore some of NASA's vast data sets using their public APIs. So this session will definitely provide you with the tools to delve deeper on your own and leverage the APIs to build your own web applications. We're hoping that some individuals who may not have felt comfortable joining our hackathon this weekend will learn a lot from this presentation and bring these tools with them to participate this weekend. So with that, I'll turn it over to Sean Keegan. Thank you for presenting today.
Cool. Thanks so much, Dominique. Can you hear me okay?
Yes.
Fantastic. Yeah. Hey, everyone. Fantastic intro. I really appreciate it. So I'm excited to be speaking and to have this opportunity to talk to y'all about APIs. And if you don't know what that is or what the heck I'm talking about, no worries. We will cover all of that. So I'm going to go ahead and share my screen. So give me just a sec. Let's go full screen. Okay. And Dominique, can I just get a quick confirmation that you can see my screen here?
Yes, all clear.
Okay, awesome, cool, thanks so much. Yeah, all right, so the name of this talk is Exploring Intergalactic APIs with Postman. So hopefully, if none of this makes sense, if you're not sure what APIs are, if you're not sure what Postman is, no worries, stay with me. I promise we'll cover all that. And hopefully when you leave today, you'll have an idea of how to explore APIs on your own. So that said, my name is Sean Keegan. I am a developer advocate at Postman. And what that means is I think I have a very cool job. I get to speak at events like this, teach people about Postman, teach people about APIs, and really just make that process, hopefully more accessible for people. Give people the tools to explore APIs on their own. I get to do cool things in the community, talk with various partners and see how they're using Postman and what they're up to with APIs. and bring that information back to my team so we can kind of make the API space better for everybody. So quite a fun job. If you're interested in Postman or you're interested in developer advocacy, certainly reach out on Twitter. I always love chatting about this stuff. So here's the agenda for today. We'll start, like I said, with an introduction to APIs. So if you're not familiar with what they are, stay with me, we'll cover that. Then we'll go through API basics walkthrough. So we'll get you started so that you know what an API is and how you can go ahead and start playing around with them. Then we'll explore the NASA and other space-related APIs. So that's where I think it's going to be really fun. NASA has so much data, and it really is accessible to us through APIs. And so I think it'll be cool to see how we can use Postman to go ahead and explore some of those data sets. Then I'll talk briefly about some other resources to get you started on your own. And then we'll leave some time at the end, certainly for some Q&A. And I am keeping an eye on the chat. So, and if Dominique wants to let me know if any questions come up throughout, feel free, and I'm happy to answer on the fly as well. Here are our learning objectives. So if you stick with me to the end, at the end of the session, you'll be able to explain what an API is. You'll be able to use Postman as an API client to make requests. And this, I think, will make a little bit more sense as we go through, but really, we're going to use Postman to help us, ask NASA for data and get it back. That's really what that means. Find relevant APIs in the Postman public network. What that means is there's all sorts of APIs available that you can find, within Postman, and we'll figure out how you can go ahead and find those. Then we're going to inspect API responses for useful info, right? So we're going to ask NASA or another API for information, and we're going to be able to make sense of what it sends back to us. And lastly, familiarizing ourselves with API documentation so that we can make more specific requests to get the information that we're looking for. All right, so let's start with what is Postman. So Postman is an API collaboration platform used by more than 17 million users. And if I had to summarize it in a sentence, I would say that Postman helps people work with APIs more efficiently. And you can kind of see a flywheel here that talks about different parts of the API process. Right, so whether you want to test an API, document it, monitor, and we're not going to go into some of these other features, but it really allows you to do just about everything with APIs and the full life cycle of APIs. Now let's talk about an intro to APIs. So yeah, I've said this phrase a ton, right? If you're not sure what I'm talking about, this is the slide for you. An API, it stands for Application Programming Interface. And what that is it's a tool or a piece of software that provides access to data and services. And so what I can think about it, right, is if I were building I live in New York City. So if I was building like a super fan page for New York City, I would want various bits of information on that page. I would want, maybe the weather, events that were taking place in New York, a map of New York City. And rather than myself going out and like every minute taking the temperature and going back and updating my site manually, that's like not a scalable or fun process to do. But websites like weather.com or Weather Underground, they have this data accessible, and they do that better than I'll ever be able to do it by going out with my own thermometer. And so through the power of APIs, I would be able to essentially ask weather.com for their information on the weather, get that information and use it on my New York City website. And so that's like a very crude example of how you can use an API and what it's for. But it's that idea of requesting information and getting data. So the next thing to talk about is a client. And so this is the website or mobile app that makes requests to API endpoints. And so we'll be using Postman as the client for this example, for this workshop. And really all that means is we're going to use Postman to help us say like, hey, weather.com or hey, NASA, I want this information. And once it sends it back, Postman will help us inspect that response and see what it gave to us. So the goal for today, we're going to do just some very basic API walkthroughs with a demo customer API. And then we'll look at some more fun ones, including some NASA related ones. Okay, so now we're going to go ahead into the demo section. So if you're following along now, you can either go ahead and just kind of watch what I do and take it in that way. But I'll try to make sure it goes at a pace with instructions that if you did want to follow along and kind of go side by side with what I'm doing, that you'll be able to do that. And so the first thing you'll need to do is you'll need to have a Postman account to do all the stuff. And so here are kind of like the prerequisites for following along. You have to create a Postman account and sign in. And then the next step is downloading and installing the Postman desktop agent. And all that is it just allows us to use Postman in the web to do the request and make the request that we want. And then lastly is going to the public workspace. And I'm going to go ahead and share links to these right now. So give me just a sec here. I have lost my display thing. So I'm going to go here. And this is ultimately the web page we're going to go to. And I'll send you the link to get here. It is just one sec. I'm going to send it over in the Zoom chat. So if somebody could go ahead and pass that along to the rest of the groups. Dominique, if you could send that to everybody, that would be awesome. And so that will take you to this page here, this Exploring Intergalactic APIs workspace. And this is where we're going to do the majority of our work today, or where we're going to see the majority of what we're looking to get into. And if you're not familiar with Postman, this is a workspace is kind of the container or area where all things related for a specific purpose are going to live. In this case, I created this workspace specifically for this workshop. And right now, just familiarizing ourselves, this main page right here is going to be our overview of the workspace. And it talks about this specific workshop, has information on getting started, has information on additional resources, and encourages people to get involved and contribute if you like. So it looks like Dominique has passed along the information. So again, if you want to go here, go to this public workspace site and go ahead and create an account or log in, and you'll be able to follow along with everything I'm doing. So the next thing to point out is we have collections, and what collections are is just a group of requests for an API. And if that sounds kind of wordy, let me unfurl one of these, right? So API 101, that's the name of a collection. And these are all of the requests specific to this API. I'm gonna take a quick sip of my delicious seltzer and get back into it. So for API 101, this is gonna be how we kind of first introduce or first look at APIs and what they are. And this is just a very basic sample one. So for me, this public workspace exists and I'm not part of it. So what I can do is I actually want to take this collection, this API 101, and if I click it and look at this documentation tag here, this gives us information on what this collection is. So this is an API 101 template for learning API request basics. And to go ahead and actually use this, and if you're following along at home, this is something that you would want to do. You're going to click this fork button here, and I'm zoomed in, otherwise it would say fork. And if I collapse this, I think it'll say fork. And what this means is I'm going to just kind of create a local copy and a local version that I'm able to mess around with. So let's go ahead and call this stream fork. And I'm going to back up a tiny bit, because if you're not familiar with this, or you wanted to have it in a clean workspace, I have to fork this into a workspace. And I have quite a few here that I've already done before. But say I wanted to have something specific, I can come up here to workspaces on the top, click new workspace. And I'm actually doing this step so that if you're following along at home and you want to have a workspace specific for your workshop, you can call it workshop practice. And I'm going to keep it as a team workspace, and I'm going to create the workspace. So what happens now is that actually takes us to this new workspace that I created. And you might be wondering, well, what happened to the other workspace that I was looking at with all the space themed stuff? And that's where the search bar up here comes into play. It's very helpful. You can just go back to the link that Dominique shared, but let's make use of the search. So I remember that it was called Exploring Intergalactic APIs. And if I just type exploring, we can see that it pops up in the search. So I'm going to go back to that workspace here. And this will allow me now, so now I can fork that collection that I was looking at, this API 101, into the new workspace that I just created. So let's click fork. I'll say stream fork. And I just called this one workshop practice. So that's where I'm going to fork it into. All right. So that workflow allows me to copy that collection from the public workspace into my own workspace that I can work with. So now we're going to kind of see sending a request and getting information back. And that's kind of how APIs work. So let's look at the first request. That's what the documentation says. Just open the first request and hit send. So I'll click get all customers. And now let's familiarize ourselves with the UI here. So this top pane is going to be all things associated with the request that we're about to send. So I'm going to send a GET request. That's the HTTP verb. We're going to send it to this address here by clicking this blue send button. And Postman handles all of the formatting of this, and it tells the server, we're going to send information, send the request to this endpoint. And I click this blue send button. And this might take a little bit because Glitch has been having some problems, the website where the API is hosted. But if you're following along at home, hopefully you can just click that send button and you see down here in this bottom pane, we have what we call our response. And so this is the information that comes back from the server. So Postman helped us say, hey, API 101 glitch.me, I want to get the information that you have available at this endpoint. It went, pinged the server, and then it came back down here and we got this information on, just as just a sample API, but this is customer info here. So this is the response that it sent us. If I wanted to go ahead and, just get one customer, now we introduce this idea of a variable. And a variable is just going to be something that we reuse in Postman. It uses this double curly brace notation. And you can see it's still that API 101, same URL as if I were to go back here, right? But now I've just replaced it with this reusable chunk of information. And so if I click send again, this is going to go ahead. So now it's a more specific request and saying, hey, I actually want, instead of all the customers, I want the customer that has the ID of 1. And what Postman does pretty easily for us is that it handles, formatting of these requests and sending specific information to the server. And if I were to check this or uncheck it, you can see that it populates in that query up there. So that's kind of basics of API 101, but we're here to learn about kind of cooler space themed ones. So, if you want to go through and do the rest of this API on your own, feel free, you can certainly fork the collection. Highly encourage people to fork it, especially if you're not familiar with APIs. It's a great API for just learning the basics and getting to explore. But what I'm going to do is let's now go back to the intergalactic APIs that we were working on. And like I said, let's look at a little bit more exciting APIs. So if I scroll this over, so I put all these APIs in here for us to explore. Let's go ahead and get started with this NASA astronomy picture of the day. This is actually one of NASA's more popular APIs. And again, if we think about what an API is, it's just going to be a tool that allows us to get all this information, from NASA or from wherever we're trying to get it from. So let's click this, and it unfurls the documentation here on the right, and we see get your NASA API key here. If you're not sure what an API key is, it's just a kind of a thing that associates your account with you, right? So if I make a request, an API key says all right, this is Sean that's making that request. So what's really cool is this endpoint allows us to get either a random picture from NASA or ones for a specific day. So let's go ahead and look at this. So, here is the actual request, but you'll notice I can't click send, it's grayed out because again, I have to go through that workflow of forking this collection. So highly recommend. Now we're getting to the cool stuff. So I would fork this collection. So same idea here. It looks like some people already did fork it, which is awesome. So you're getting ahead of us, which is sweet. Let's go ahead and fork it. I'm going to click this fork button. I'm going to, again, just call it stream fork and pull it into that same workspace that I was working on before. And this is going to take me to that workspace, and now I can kind of work on it from here. I actually forked it into, but let's say, so this is where we are. which I've already done this workflow before, but let's just say this was the first time. Now I have this request. I'm saying, all right, NASA, I want this information for the picture of the day for September 13th, 2019. I'm going to click send, and we run into an error, but it's not too bad. Like this is okay. Right, we have the status code of 403 forbidden. I'll zoom in a bit so we can see this a bit clearer. All this means is that we need an API key, which is that thing I talked about before. You can see if I were to hover over this, we see that's an unresolved variable. And that just means that we don't have an API key entered here. So this is going to be kind of our first taste of API authorization and using API keys. So let's go back and look at the collection documentation. Right, so I just click the collection and it says, get your NASA API key here. So I'm going to go ahead and open this tab. So when I open this, right, the very first thing it tells us is here's how you generate an API key. So I'm going to go ahead and just go through this flow here, and it's going to show my API key, which is, not great practice, but for this stream, I'll just, void the key after. So let's sign up, and NASA's super easy. It gives you the API key right off the bat. So I'm just going to copy this because this is the information that I need. And now let's go back to our actual request. I want to request the information for September 13th. So now what I'm going to do is I want to make sure I use this value API key. I'm going to get a little bit advanced here. I'm going to make this a variable, and I'm going to do it in an environment. So that way I can reuse it. So I'm going to go to this environments tab here, create environment. And I remember that it was called API key, and I'm going to save it in my current value. Make sure you click the save button if you're following along. Okay, so now when I come back here, it still says that it's unresolved, which, and because right now I don't have the environment active, so I'm going to come up here and click this new environment, and let's just call this the NASA environment. It's already automatically saves when I change the name, and I'll click this little check so that it's active. Come back here. And so before, this was the issue that we had, right? No API key valid. If I hover over this, we can see that it does indeed evaluate to a value. So let's go ahead and click send. It's going to take a second. What it's doing right now is it's taking all this information that we just sent in our request, sending it over to the NASA API, and they're validating whether or not this API key is okay, and if these requests all are formatted in a way that makes sense to them, and they can send us back this information on the picture of the day for that date. And so we have a question that I'll look at in just a second, but here's our response, and here's all the information that comes back for this day. And if I were to click this URL, what's kind of cool is it opens up a new tab here in Postman, and I can click send, and I'll get the actual picture, which is really cool. So one of the questions we have is someone wants to know, can you share API keys, or do you need your own? Highly encourage you to keep your own API key. It's not good practice to share it. A lot of APIs will be pretty specific and say that it has to be specific to just a single user. So that way it also limits the amount of nefarious potential activity that could take place. So very much recommend keeping your API key to yourself. And so I know I want to make sure I leave some time for questions, but I want to show you another cool thing and just make sure that we understand kind of how we can look at some, documentation to make, more specific requests. So let's go to this browse API steps. Now I'm on the NASA documentation page. I'm working with the astronomy picture of the day. So I'm going to unfurl this. Here's the information on it. And if I scroll down a little bit, we can see, right, this is that GET request, the base URL. Let's say I didn't want it for a specific date. I wanted, a randomly chosen images, and I can control how many I get. So it says here, it cannot be used with date, start date, or end date. So let's go back now and say, all right, we know we can't have date, but what I can do is I can say, I want the count to be 5. And by unchecking this, watch up here as I check it, right? Date was added. And then by unchecking it, the date is removed from the query parameters. So Postman handles that and makes sure that the request goes through as expected. So click send again. And you'll see now, right, this is the response. It's formatted in JSON for us, which is just, it actually comes back like this. It's just a huge old blob. But if Postman recognizes that it's JSON from the response, it can format it and give us, 5 different objects. So here's one from April 23rd, 2018. Here's one from 2008. And we get all this information. And so if I were building my own website about, NASA or space, I could go ahead and make a request for, 5. If I wanted to make it 10 images and click send, I could do this and get, new pictures every time with these URLs. And so it's pretty cool, pretty neat. These are very basic examples, but, hopefully you can kind of get the idea of, how powerful or how useful APIs can be. And Postman just happens to be an API client that allows you to, test APIs and check out some of the functionality. But APIs themselves are quite interesting, quite powerful. And there's a lot you can do with them. So we've kind of only just scratched the surface. I want to make sure I leave time for chats. But again, if you're for questions rather, but if you're interested in exploring more, there are quite a few space-related APIs in this workspace. This collection here has a bunch of NASA APIs that you can check out. So definitely fork this collection. That same API key will be super valuable and helpful in just exploring all the various things. And Postman will make it quite easy for you. So happy to take some questions. I know I ran through that pretty quick. So, if there were questions, definitely, let me know here or, get in touch with me on Twitter, and I'm happy to answer as much as I possibly can for everybody.
Thank you for that presentation, Sean. I was learning a lot. I was trying to follow along as well, because I do know that trying to work with APIs without a medium like this is actually kind of challenging. I would always miss like a sans mark or a question or not formatted properly and just spend hours trying to debug figuring it out. Other than that, can you tell us some of the other ways that, Postman enhances the experience when people are trying to integrate APIs into their projects?
Sure. Yeah, that's a great question. And like you said, I think, if people are trying to explore APIs on their own, there are quite a few ways you can do it. There's curl commands, which are basically doing a lot of the same stuff that we did in Postman, but just from a command line. And Dominique, like you were saying, that can get really challenging. You could miss, a quotation somewhere. You could, not understand the parameters. Like authorization gets quite tricky. And so, what Postman is really helpful with is kind of taking care of some of the finer points and places where you can make errors in a kind of neatly, presented tool. So for example, right, I added the count, I changed the count from 5 to 10, and all I had to do was, change that number from 5 to 10. I didn't have to totally redo the request. I didn't have to copy and paste a ton of stuff and hope that all worked out. A tool like Postman just makes it, much more convenient to kind of work with, sending API requests and inspecting the responses.
That sounds amazing. We do have another question that was Hannah, who said that she thinks the picture from NASA was cool that popped up. And she wanted to know, is there anything further we can do with it other than seeing it within the Postman API? So what's the next step after you gather this API?
Yeah. So great question. it's tough to kind of showcase the full power of APIs, in a 20, 25-minute window. But yeah, I mean, some next steps could be, right, we were exploring the NASA API just to kind of see what was out there, what the picture of the day API looked like and how it behaved, what it said back to us. And so say I was building, instead of Sean's New York City fan club website, I wanted to build a space themed website. A tool like Postman is really helpful to, explore these APIs and then, test the functionality and see what I would need to do to get information from my own website. And, there's the ability to generate code. So if I make a pretty advanced request to a NASA API and says, I want, X number of pictures from these dates, and I only want the HD URLs, Postman can help us figure out how to get, those exact parameters and the code to make that query to an API. And it can convert that code into, Node.js, if that was what I was doing, to write my website, server-side code. Another really nice thing is you can take information from one request in Postman and use it to make an ensuing request. And so if I, captured information on, we didn't get a chance to dig into some of the others, but if I was looking at International Space Station locations, I could capture that location and see if there's anything nearby using other requests as well. And I think that's time. So I'm gonna give up my time here and say thank you so much for having me, Dominique. This has been a blast. And for everyone that has other questions, feel free to get in touch with me.
Yes, thank you so much. This was so informative and really, really great. And I think the people who are watching learned a lot. So thank you so much.
Yeah, you're very welcome. Thanks for having me.
Thank you. Have a good day.
You too.
Awesome. And so now we have our next presenter. His name is Fernando Salvador. He is going to discuss STEM and crime. And basically, he's going to discuss STEM to Violence, which is a platform that aims to use STEM as a tool to empower youth to veer away from crime. So STEM to Violence does this in two ways. One, by creating workshops, either in person or virtually, for at-risk kids, and also by showcasing a diverse selection of positive role models in the fields of STEM. And so we'd love to welcome Fernando so that he could tell us a little bit more about STEM to Violence, its impact, and the objective of it.
Hi, Dominique. Thank you so much. First of all, thank you all and Katelyn for the invitation. Feel so honored to be here, all the way from London. Just a bit about myself. So I was born in London from Latin American parents, both from Ecuador. So that kind of, through the platform, I try to kind of use both kind of languages, Spanish and English, to kind of reach out to further afield through the programs I'm trying to put on. So I'm the founder of STEM to Violence, and it was kind of created in 2019. An idea that I had in my mind from working with youth in around London, different areas of London, South London, West London, and my own love for STEM. I don't come from a STEM background, although I did do architecture way back at university, but I did not complete the course. So something about this kind of creating this platform to kind of empower kids, to empower youth to see that there's so many different ways that you can get into STEM, and STEM now, STEM always there's different kind of career paths as well. You don't have to be a scientist to be or a coder. If you want to get into tech, there's so many different career paths that you can take, and still kind of learn coding as well, which is actually a really good thing to do anyway. So it's a platform which is actually growing in terms of like a kind of hub with resources and just trying to channel that information that is coming through quite like instantly now, with big changes that are coming, especially in the UK with the space industry, for example. The space industry is actually one of the fastest growing industries at this moment in time. And there's a lot of like startups coming up, and I just want that kind of information to be channeled to all youth. Space is for all. So that's my main motto behind the platform. So I'm going to just show you, I'm going to see if I can show you, let's see. I'm just going to share a PowerPoint. So just wondering, can anyone see that? I don't know, I just want a quick message.
Yes, we can see it.
Yeah. So so this is, so it's welcome to STEM to Violence. You can find us at www.stemtoviolence.org. And it was just nice to put NASA Space Apps Challenge at the end, 2021. Again, thank you so much for this. So this is me and my colleague, Chris, who I kind of met in one of those these tech events that I was going to back in 2019. And one of our first workshops was hosting like an interview type kind of workshop with an ex-NASA astronaut, Jose Hernandez. Amazing, like, he was so happy to do it, and we had 2 schools from South London that came along, and it was just an amazing event. He came on, it's probably like 6 hours back as well, just like in New York, but we all had a great time. He was able to kind of talk about his experience as an astronaut, about his humble beginnings, and I mean, all of that kind of, it was powerful in terms of how, especially with the kind of audience that we had, they felt very connected with, with the experience that he had, and hopefully in time inspires them to kind of follow careers in STEM. So that was one of our first space talks. And then we went on to talk more about tech and bringing in the kind of cybercrime element to it, which is something that I'm actually trying to get more involved in. We had a specialist kind of team come on in partnership with Microsoft, and a school came along and they took part in this kind of cybercrime challenge, matrix challenge. Most of the kids, it was their first time of doing some type of coding, and this kind of like introduction to coding, this kind of Microsoft opening the gates, so people could just walk in and experience this was again an experience for everyone, especially for the children that took part. Again, that's something that this was well before COVID, and when we were able to kind of meet up and see each other quite easily. But then COVID came along and it just kind of changed things, and so we started to do things virtually. So this is another image of what happened at the Microsoft flagship store. They had this games room where all the kids were able to kind of play with the Xboxes. Amazing. I mean, I had to go, and yeah, definitely we'll go back there when it opens again. So one of the first virtual talks we had was with Dr. Samuel Garcia, who's an education specialist at the Kennedy Space Center. And he came on, and we did it with a school virtually. This was with a class of 20 or so kids. And yes, he came on and he started talking about ways of how you can get into NASA. What kind of subjects you should do at uni or college, and other ways of getting into kind of the STEM professions. That went amazingly well. And we actually have him on our STEM profiles, which I'll talk about a bit more later. And then magically, I mean, I don't know how I managed to sort this out, but yeah, we've got an interview with Elio Murillo. So he's an engineer who worked on the Perseverance rover that landed on Mars this year, and he spoke about his work on the rover, on how he got to where he is, you know, especially coming from you know, a different background to what you normally see, you know, in the STEM industry, and he managed to get to where he is, you know. He's talked about the struggles that he had and how he overcome those struggles. And again, we've got him on the STEM profiles on our page as well, which is amazing. And then now we're kind of like starting to go kind of back into kind of tech, and we're now collaborating with a Barclays Digital Wings, which organizes this online platform for parents as well as young people to kind of enhance the digital skills. And you know, it goes through kind of ways on how you can stay safe online, how parents could learn a bit more about what kids could probably be doing. And it talks about all these new kind of social media platforms, which a lot of adults like myself, you know, we kind of like should not take it for granted. We should really kind of learn a bit more about what you know, what kids are doing on them, and then we can kind of like show that support with our kids. I'm a father of two as well, and at the moment they love Roblox. They love, you know, it's the kind of platforms where back in the day I've never heard of, and you know, there wasn't any Roblox. So you know, I take my time to kind of get involved and try and find out and learn a bit more about what it is, and just make sure that it's safe for our kids to take part in. So, and there's a on our website there's a link there for these courses. You just register, and now that things are virtually and that connection that we have, instant connection that we have across the world, anyone can take part, not just from the UK. About a week ago, we also kind of like formed a collaboration with Microsoft with their Latinx Heritage celebrations. So we took an opportunity with them to kind of showcase, you know, what they kind of show in terms of their celebrations of the Hispanic and Latinx communities. We have a growing Latinx community in London, so it's an opportunity to show them as well what companies in America are doing. Again, highlighting the Latinx community in the tech world. And then I mean, that's it. I mean, I thought I'd show you just a quick kind of like overview of us and how we've progressed. It started with me, you know, just one person, then it became a team of 5. And the idea behind that was to just try and kind of invite professionals, people that are at university doing their PhDs, who are specialists in the kind of field, so they can bring their ideas and how we can kind of create workshops and introduce like youth, you know, especially youth that for many factors don't get the chance to get to see like what's going on with tech and STEM. We've kind of also created a collaboration with a aerospace company based in Scotland called Sky Aurora, again to kind of create these kind of workshops, virtual workshops, to highlight what, you know, how, you know, the UK's presence in space. So this is what behind the kind of platform is, to kind of create this partnership, collaboration with organizations, and kind of break down those barriers between you know, that the youth might feel they have between them and say CEOs of all these companies. You know, they'll never get a chance to speak to a CEO just like that. And through our kind of channel, we could probably create a virtual, and you can actually ask questions directly to them, so that they can feel that, you know, anything's possible, and they were able to kind of reach those positions in the STEM world. The other thing that we've kind of found is that there's a lot of youth that have this kind of fear of tech, fear of STEM. Many don't believe about, you know, space and about, you know, how far we've gone. And again, so this is another way of kind of reaching out and introducing them to space and kind of like missions that are happening, and slowly kind of get them involved and get them to learn that they can also be part of that. You know, it's out there in terms of, like, there's a lot out there in terms of resources and platforms where you can learn on how to be part of it. So yeah, that's another thing that we kind of aim with our platform. So if you look here, I've just put up the Instagram, Twitter. It's all about social media now. So we're quite active on social media. I put up, you know, things that are going on around the world, the new kind of technologies that are taking place. There's kind of videos on our YouTube channel about just talking about apps that you know, new apps that we find, and kind of do a review on them and stuff. So again, another way of kind of introducing tech to kids, to youth, to anyone, and hopefully it kind of inspires them, you know, to kind of problem solving, and you know, and that's something that in relation to what I do on a full-time day-to-day basis, it's always a problem solving, and if you're good at problem solving, then you'll do really well in STEM subjects. So that's about it. Is there any questions out there?
Thank you for this talk.
Oh, go ahead. I was just going to ask a question.
No, it's fine. Ask your question.
Okay, I was just going to ask, so Fernando, I know that you mentioned that you work with a couple of schools at some of the talks that you have brought or have given them the opportunity to hear. But for the kids that are in your program, is there a certain way that you locate kids that are, you know, more in need than others that maybe don't have access to things as easily?
Yes. So at the moment, we're trying to kind of create a partnership with youth hubs, not really schools, youth hubs where kids, you know, you get kids from all backgrounds. Some kids, you know, may not be going to school. They might be doing homeschooling, especially now after COVID. So many, well, the lockdown. Sorry. There's a lot of like uncertainty out there. So we kind of go to these youth hubs, you know, talk about what we do and look to kind of create workshops with them. Many of them don't have access to facilities, so that's another thing that we're looking to do, to try and create like collaboration with companies that can come along, give us, you know, just rent out, or, you know, like laptops and stuff, so that we can teach kids what we want to teach them.
Awesome. And I had one other question. What was it? Oh yeah, so what I know you mentioned that growing up, STEM was always something you were interested in, but why children? Why work with children? What's your inspiration there? I'm curious what has gotten you started working with kids and at-risk youth.
Well, my kind of full-time work is law enforcement. over 10 years now in London, and I've had that kind of like experience dealing with kids in the streets, you know, talking to them, and I kind of wished I'd had this idea a long time ago, because you know, I would have had something to talk about with, you know, show it to, you know, like it's been a journey for myself especially. So what the journey that I've had so far is what kind of that feeling of being empowered to empower them, to empower kids, to empower people. So yeah, that's where you know, that's where it comes from, that ability to be able to kind of say, look, you know, there's this platform where you can learn a bit more, learn about coding, learn about you know, don't be scared, just get involved. So that's where my kind of passion for it comes from.
Amazing. All right, Dominique, I'll turn it back over to you.
So Fernando, thank you so much for coming today and discussing what your organization does. I find it really inspiring. I think we need more of them. I know you spoke a moment ago about how, you know, there were kids who have never met a CEO. They didn't know certain jobs existed. And it's true. Many people live in very different worlds. We all may live in the same city, but are experiencing it completely different. And a lot of people don't have access to some of the things we think are so simple and we take for granted. Everyone goes, oh, you could just Google that. And it's like, no, we need role models, we need representation, we need someone to guide us through the process so that we can understand it and have that support with us. And so I thank you so much for, you know, creating your organization and all the amazing things you're doing with it. I think beyond just your organization, I think anyone can also play a role in this. And so I would love if you could share some of the stories you've had with just the responses the kids have had when they went to, for example, Microsoft, because it looked pretty cool from here. I really wanted to jump in one of those Xbox chairs and, you know, do cyber crime challenges, or, you know, when they were listening to Emilio talk about his work with the rover, because I think that will connect to a lot of people who may have things to share and the things that they want to teach, and they should know like what they're bringing, like the importance of what the knowledge that they have that they can share.
Yeah, so I mean, especially the fact that it's all about kind of a reflection on, you know, when you see someone that looks like you, or kind of similar backgrounds in the field where you don't tend to really see that. They have that connection, and I saw it especially with with Jose Hernandez, where in the beginning it was a bit kind of, you know, it was a bit difficult because the kids were like, oh, you know, this is this is something different. But then as it progressed, I started to see the change in just that moment. Probably it was an hour, and that change where the kids became more comfortable and started asking questions, to start interacting. And probably kids that you probably wouldn't hear or see that they interact with kind of normal schooling or you know, other things. But this fact that, you know, that you could speak to someone and from you know, another country and kind of feel, oh wow, you know, I can relate to him, you know, and if he can do it, I could do it. And that's what I was hearing. You know, is actually, you know, just to go back a bit, the other thing, you know, you mentioned early on what inspired me as well. Like I mentioned, I have two kids, and my oldest one is 9 years, so she's 9 years old. But there was something about her that she said something one day when she was watching, I don't know, I think there was like a superhero, like a and she was you know, she looked Latin, or she may have looked Asian, Indian. So and my little girl is half Indian, half Ecuadorian. And there was something that she said that really kind of got me thinking. And she was like, oh my word, that's a superhero, and she looks like me. And I was like, wow. And it just got me thinking, like, you know, who knows, maybe, you know, I don't know, looking back when I was a kid, I'm not sure if I'd ever thought like that, but for me to have heard that, say that, kind of made me think, that there is something that we need to kind of try and make change about, change. And there is a lot of changes happening, but it just needs I think it needs more people to get involved and to see that there is a need for more diversity, more inclusion in the STEM professions.
That is so amazing and so true. Nowadays, I hear, when you see more and more people of color being represented in movies or as in professional roles, you see little kids going, oh, she looks just like me, or he looks just like me. I can be a doctor. I can be a scientist. I don't recall when I was that age either, but maybe a bit older in high school and college when we were meeting professionals, and I would see this one Black lady who was a cybersecurity expert, and I go, oh my goodness, we exist in those roles too. And I went up to her and started talking to her, and I felt like I could see myself in that role as well. I mean, I don't do that, but I am in technology. And so I recognize that and appreciate that. And I think another part of it that people should be aware of is that following STEM, not only is it great for the mind because you're exploring our world, and you're coming up with innovations, and that's amazing. But also there's like a real impact on families. I've read research about how getting into STEM careers, going into technology, literally pulls entire families out of poverty or out of low income homes, or, things like that. And so, where do you see, or what type of impact are you hoping that STEM to violence will have on not just the kids you're talking to, but their entire family?
Well, that's it. This is another a good point actually behind it, in terms of like the whole family. Families. Some families are probably. I mean, my family. They probably wouldn't know much about STEM. Wouldn't know much about tech. But having someone, their children, talking to them, would also inspire them to learn as well. Like my mom probably doesn't even know how to kind of send an email, for example, but kids can now teach their parents so that they can also be part of that kind of tech world. And who knows, from one thing it can lead to another. Even as much as the kid, the young person could get a really good job, parents can get a really good job as well. Family members could get a good job in terms of something that they probably wouldn't have thought of, that they'll probably obtain. It's kind of changed that mindset, that things are now kind of much more easier than when I was growing up. And there's so much on, like, for example, YouTube. There's a lot of learning channels. I was learning myself how to code through YouTube channels. So it's something that it's open to everyone, and it's just all about kind of being headstrong and saying, yes, I can do it. You can do it, and you do it. So that's another message definitely that we want to get across.
I love that message. It reminds me of, when we transitioned into this pandemic state and a lot of places went to quarantine, one of the biggest groups of people that were impacted were senior citizens. And when you look at it, traditionally, a lot of them aren't really plugged into technology and into, so the pandemic made them more isolated than most people, right? So a lot of things they did, like they write checks and they walk over and they deliver them, or, they go to bingo halls or whatever it is they, do. They couldn't do it anymore. And I remember reading an article about how, people were saying, oh, they can just use Skype or they can just use whatever. And it's like their entire lives, they never used it. And so the only way they had access to it now is if their children or their grandchildren show them how to do it. And so it's really important that we think about how, the things that we do for kids, how that impacts their families, not just financially, but like you were saying, how it just helps bring the entire family into this century, this generation, and like connected with technology and how important that is. So I think that is definitely a crucial point brought up. So before we wrap up, I just wanted to know, what are next steps for STEM to violence? What are some of your milestones?
Well, the idea now is to kind of enhance the kind of we want to enhance a program so that we can invite youth to come on board, you know, for them to kind of take part in these kind of courses that we may that we're looking to have, and they can kind of receive like a certificate, for example, like an incentive, you know, to participate with the courses, and kind of open it up with I don't know, educational institutions, so they can kind of, we can signpost them to, oh look, you know, you can go to this college, you can learn, you know, you can learn this, you can learn AI, you know, you can so that's our kind of next step, to kind of create this program. And we're kind of half there with terms of the digital platform that we've just created with Barclays, but there's so much more we want to do, especially like once things kind of get back to normal, because at the moment things are quite challenging in terms of because of restrictions and all sorts. So once we can actually do face to face, it'll be so much better, because then it's, I mean, I prefer being face to face. Kind of, you know, I think it builds better relations than and then once you've done that, you can do virtual. But yeah, so hopefully we go back to that again, and just keep on doing these virtual workshops and in-person workshops as well.
That's amazing. And so we're at time now. So one, I want to thank you, Fernando, for coming on today and talking about STEM to violence. I think our participants, our attendees learned a lot, and hopefully you've inspired them to go out and also contribute their time or their knowledge, skill sets to helping the youth learn more about technology, STEM in general, and apply it going forward. We see that it has a big impact on the world. And also, I want to send positive energy out there that, you know, STEM to violence continues to be successful, and that it continues to grow, and that you hit all your milestones, because you're doing amazing work. So thank you so much.
Thank you, Dominique, and thank you, Katelyn, for everything. Katelyn, for everything. Truly kind of honored to be here.
Awesome, thank you. And so now, everyone, we're going to take a little break. We're just going to play some music for a while into our next presentation we have. So thank you, everyone, for attending, and don't go too far away. Enjoy the music, and we'll be back shortly.
Yeah, we'll be back at 3 o'clock, everybody.
Eastern Standard Time.
Yes, Eastern Standard Time.
Thank you, bye.
All right. Hello, everybody. Can everyone hear me okay? All right, we are back. Welcome back, everybody, after our short break. I hope everyone is able to get something to eat and drink and able to use the restroom, because that's important. And I would love to introduce our next speaker, who is the CEO and founder of Mediamatics, Dr. Martin Fengler. This is a company that's near and dear to my heart. I've worked very closely with them and their weather data for a personal project of mine for the NASA Space Apps Challenge in the past. Dr. Fengler will be speaking about the future of weather forecasting. And in this talk, he'll cover a brief description about how the weather forecasting happens today and how Mediamatics tackles the challenge and how they want forecasting to move forward to the next level based on their unique technologies. He's also going to explain how users can access their weather data and what kind of possibilities this offers for users and companies. And finally, he'll connect the dots to NASA and explain why they're part of the challenge and how participants can benefit from their API data. And with that, I will turn it over to Martin.
Thank you very much for this kind intro. And actually happy to see you again, Katelyn.
Well.
Let me quickly share my screen. I hope this all works perfectly well.
Yep, it looks good.
Good. Yeah, thank you very much for giving me the opportunity to join this Space Apps Challenge again, and talking a bit about Mediamatics and what we are actually doing in this field and how this relates to the activities of NASA and, of course, all other scientific institutes around NASA. So if it comes to numerical weather prediction, it's worth shedding a light on this, how this works nowadays. So of course, it's involving tons of partial differential equations covering fluid dynamics and coupling the Navier-Stokes equations into the thermodynamic equations. But let's skip this part for the time being, and let's have a closer look to the data situation. And the data situation is much different than normal or people that are not meteorologists would expect. And this is that we have actually no idea how the weather conditions are right now. So it's not just a forecast that typically meteorologists screw up, it's also that they actually do not know how the weather is right now. And of course, we have lots of instruments, maybe such as satellites that give us really good insights from above, aircrafts. Currently, there's not that much air traffic, of course, but this is now recovering. And this is a really valuable input source for the weather forecast, but also radar data, balloon data, and especially also station data. But one of the key challenges is that we have only little knowledge about the mid and low atmosphere, and especially also no idea about the planet boundary layer. And the planet boundary layer extends roughly to the first mile of the atmosphere. And if I say mid atmosphere, then I mean in the following something like 6 kilometers, so about 20,000 feet. And if you do not know how the weather conditions are right now in this atmospheric layers, you fail to predict fog, low stratus, and storms. They have their trigger basically in this very low atmosphere, and especially the temperature and moisture content plays an important role for the formation of these sort of phenomena. Now, we decided about nearly 10 years ago now to tackle this challenge and to develop drone systems that are equipped with meteorological instruments to capture precise temperature, moisture, and wind direction data from this mid and low atmosphere. Of course, this is not an easy task. It might be at a first glance by just attaching a thermometer to a drone. But once you decide to fly to altitudes of, let's say, 6 kilometers high, you are taking part actively in air traffic. So it requires lots of paperwork and coordination to get the certification, the flight permit to take part in air traffic and fly to these altitudes. And at the same time, we talk about small UASs, so small drones of a size of 5 kilograms, run a Pixhawk autopilot system that fly just a vertical profile. We have, of course, these sort of mobile systems, but you could think also of systems that are integrated into an automated solution, into what we call a Meteor base. And this doesn't require any operator nearby and can completely operate it from abroad. Now, this gives us precise information on the basic ingredients of a numerical weather forecast. As I mentioned before, temperature, humidity, wind speed, wind direction, and of course the air pressure. And these are the so-called prognostic variables, and they can be easily integrated into a numerical weather model such as WRF, for instance. And we do so operationally. And this helps to get an improved initial state and come up with much better forecasts. Now, if you fly to these altitudes, you typically cross also clouds, and this requires operations, what is called beyond visual line of sight. And of course, you fly across clouds, and these clouds are in mid-latitudes, typically below freezing. So you encounter icing conditions. And this is a serious threat to rotary systems, such as small UASs. And this is why our drones are now equipped also with a propeller heating system. So we detect icing conditions in these clouds and activate the propeller heating and continue the mission flying across the clouds and taking really precise measurements about the moisture content, the temperature gradients, for instance. And something that makes a meteorologist really happy is that once you conducted such a mission, you get an entire SQT diagram, which helps also to support nowcasting decisions. So we had the opportunity to conduct also some pilot studies with the National Severe Storms Laboratory in Oklahoma a couple of years back. And this was then taken into their nowcasting systems in this pilot campaign, using array-op data formats, but also other data formats are supported to help the National Weather Service with some of their nowcasting decisions. Here are some examples of flights that took place in Avon Park in Florida. Here showing now multiple profiles in a row. And this, of course, looks at the first glance rather boring here with temperatures around 28 degrees Celsius and then decaying out to, what is it, let's say -6 degrees Celsius and 6,000 meters height. But if you have a closer look to the relative humidity, you can nicely see how the variation is in this mid and low atmosphere. So you have pretty high moisture content in the first mile, and then a dry layer, and then the first cloud deck starting, and then in about 5,000 meters height, another dry air intrusion. And this gives you already some idea about the cloud structure, the ceiling height, and cloud top heights, etc. So this is something that supports the nowcasting process. And especially if you consider also the wind data, you can nicely see how different the wind conditions are in the mid and low atmosphere. So here there's a sea breeze, the first mile, then winds come down and change from southeasterly winds to northwesterly winds in high altitudes. And this is, of course, extremely important once you take those data and assimilate those into high-resolution models. So we run actually a 1 kilometer model for Central Europe operationally. And we had the chance to do a pilot study with sponsored by Zurich Airport and Swiss International Airlines. During this pilot study, we operated these drones in 6 locations in the vicinity of Zurich Airport. One drone was actually operated inside Zurich Airport during nighttime, and this helped us to improve the fog forecasts. And the setup looked like this. So Zurich is located here, and here the red dots indicate the location, and the distance was around 30 to 40 kilometers. And then you can do intercomparisons. You run these models with drones and without drones. So you can nicely see in this intercomparison how the weather model with the additional information from the drones that were operated in this area helped the model to improve the initial state and to evolve the fog that you can see in the Swiss plateau. What you also see in this pictures is that there's also fog in the Lake Geneva area, and this is where we currently do not run any drones, but this is about to come. So we are right now setting up a network of these meteor bays, an operational network in Switzerland, and this is government funded by the Swiss Federal Office of Civil Aviation, and we are already looking forward to improve these high-res models with the additional drone data. Of course, drones alone won't save the entire planet. It's just a puzzle, a piece in a much larger jigsaw. And we like to add, or we continuously add also other data sources, such as lake temperatures, sea surface temperatures, and even some satellite data. Now, once you run this model, and this is also true for the weather models from NOAA, from NASA, but also from other National Met Services, they all have in common that they create a huge output volume. Typically also provided in a let's say, in a more technical data format like GRIP data or NetCDF data to the users, something that data scientists are typically not used to deal with. So what we developed is what we call the Meteor Cache, an in-memory database technology, in which we ingest all of these different models, local area models, but also global models, maritime data, satellite data, station data, elevation data, and so forth. And in front of that, we have this weather API, and this is what we are providing and to this NASA Space App Challenge. So you get free access to, during this weekend to utilize all historical, current, and also forecast data and even climate projection data to do your own analysis. For instance, Katelyn looked in her project into the classification of sea ice, and there she used some of our sea surface temperature data from the API. Now, to make the access as convenient as possible, it's RESTful API. So you have this API endpoint. You specify the start point in time, the end point in time, and the temporal resolution and the parameters you're interested in. There's a huge online documentation available on our website, and you have access to thousands of different variables. Not just the surface data, but also upper air level data and even soil data like soil moisture, soil temperature, for instance, and of course also maritime data. Then you specify the latitude, longitude in which you're interested in, data format in XML or JSON. Just to give an idea how this looks like, we have the API query, and for instance, could be a CSV. And this is now a location, I think it's pretty close to New York City, giving you the temperature at 2 meters height in Fahrenheit, and gives you here a 2 days forecast. Of course, you can change this date also to some historical dates. Now here, just taking some data from 1980 to 2021. And then again, you could also retrieve the entire time series seamlessly from the same API point just by changing the start date to something in the past. Same, by the way, also true for any date in the future. Of course, very short time scales. We have nowcasting and maybe local area models doing a 3 days forecast maybe, or let's say a global model for a 10 days or 15 days forecast. And then we do a blend into climate projections. So there are different climate scenarios available in our API that could be accessed. And then you have data even that go out to 2100. It's not a proprietary mathematics model. Here we stand on the shoulder of giants. So we ingested into our platform public available climate projection data that form also the basis of the IPCC report. To make the access as convenient as possible, we have lots of different open source connectors available. So most of you will most likely use Python or MATLAB and R. There are connectors available to make this access as convenient as possible. It's typically just something like adding 2 or 3 lines to insert the module, and then you can already query data. You have the data in a data frame, and then you can continue correlate those data with some of your other observations, or do a machine learning, deep learning algorithm, train the data with historical data and apply this even to future data. Now it's also important to know that we do not only take in some, let's say, raw data from other national met services, but that we also refine those by combining meteorological models, for instance, with high-resolution digital elevation models. So we have ingested into our platform the NASA SRTM model in 90 meters resolution. And this helps to resolve, even in mountainous areas, small valleys, and to come up with something that is more, let's say, reflecting the local phenomena, like higher temperatures in valleys and cooler temperatures in mountaintops. And same is also true for a lot of other variables like relative humidity, visibility, wind speeds, and so forth. So all of this input gets downscaled. Now, as we have already discussed the time series, and you with these images, you get also an idea that there's also a WMS and WFS interface. So this allows you to take from our API also graphical output and combine this in a geoinformation system, for instance, or with some other mapping technologies such as MapTyler, for instance, and Cesium.js to do some sort of overlay. Here, this is an example of hail data and lightning data and weather stations readings. It's just here in this example, of course, of relevance for some claim management with insurances. But you can also integrate this, let's say, more professional geoinformation systems such as Esri, ArcGIS, or even Hexagon Intergraph. These are all supported, and the integration is pretty much straightforward. Last but not least, I'd like to give you also a live demo of this. So this is now the tricky part in such a live session, to do a live demo. Here we see a representation of the temperature, 2 meters temperature. And we use here as a rendering engine, Cesium.js, and we have map-tiler data underneath. And as I mentioned before, you can zoom in, and thanks to our powerful backend, we do in real time the downscaling of these data. So none of these data have been pre-processed. This is all done in real time when you query data in any of these locations. And this is not only true for the temperature. You can query from thousands of different parameters. So if you go to our website, you will see huge online documentation, which covers the basic meteorological variables, but also what we call derived parameters. For instance, a windscreen icing index, slippery road warnings, severe weather warnings, and stuff like that. And of course, we have also the aforementioned satellite data available. So you have, for instance, NOAA satellites data in the same API available. We render composites with the European satellites and with the Japanese geostationary satellites. And this allows you then to zoom in any of these locations, and we have typically a resolution from our API that is somewhere around 1 kilometer, depending, of course, on the location. It's worth mentioning that some of the parameters get also a real-time refinement. So if you go, for instance, to some of the storms that are currently taking place in Louisiana, then you see here, this is time is always here in UTC, some storms, and then by stepping, let's say, 10 minutes into the future, you can nicely see how these storms are moving to the northeast. So with every new radar image that we ingest, we immediately do also a nowcasting of the information. It's not just about having nice, colorful pictures. In any of these locations, you can also query the adjusted amount of precipitation, for instance, that is nowcasted, and all variables that depend on precipitation input are immediately also updated. Yeah, so last but not least, I'd like, of course, also to show you a little bit how far we go in terms of the downscaling. So if we go maybe into the early evening tonight here, oh, this is maybe already a little bit too late. You can nicely see, let's go to this area, how the shadowing of the terrain is taken into account. So all of this is computed in real time. And this is now showing the global radiation, and the global radiation is reduced by the direct radiation, of course, in this case, as the shadowing doesn't allow for the direct sunlight, and only the diffuse radiation remains. And this is, of course, of interest for solar power installations, and of course also if it comes to snow melt and related topics around the surface relevant temperature data. Yeah, so this is for the time being what I wanted to demo, and you are more than welcome to to go to our website. And if you let me share this in the chat. If you go to this website, you can request a free API account And we are, of course, happy to support you during this hackathon. So if you have questions around that, feel free to send them to support@geomatics.com. This is something, all of this information will be sent to you once you have applied to this API account. And there's a huge online documentation available under this link on our website. And if you encounter any hurdles, let's say that you violate some limitations on the number of queries, or you encounter any other issues, just shoot us an email and we will try to get this fixed as quickly as possible. Yeah, thank you very much for giving me here the time to share all of this with you, and I'm of course happy to take any questions now.
Yeah. Oh, sorry about the dog. But I was going to ask, are there any questions for Martin? I'll also check the live stream really quick. Okay, I don't see anything in the live stream. But I did want to mention, Martin did talk a little bit about the very vast library they have of things that you can look up, terms you can put in, variables you can put into the API calls to get various information. And I just want to highlight, it is very well documented. My first project with Mediomatics, I didn't have any experience with APIs at all. And I was still able to make API calls and make a full working project within a weekend. So it's very easy to follow. It's very easy to ingest. It's something that I would recommend everyone take a look at. There's so much we can do with weather data that hasn't been done yet. Our project just happened to be around sea ice, but they do so much more. You know, we took wind into consideration, we took ocean temperature, humidity, radiation, all types of things that even I didn't know about at the time existed, let alone that there was a company out there recording it and putting it in a place that I could have access to it. So yeah, this is part of what we what we were doing. Very cool.
Shows sea thickness, yeah, sea ice thickness, yeah.
Yeah, very cool. So not only can do they have the visualization tool, but you know, we were able to visualize it ourselves in our way that you know, we needed to for our project. So it's really easy to take this data and use it and make it fit within your project. So I can't recommend it enough, and their support team is also stellar. They answered us whenever we needed them, and because we were not experts, we ran into quite a few silly problems in the beginning, but they were happy to help. So yeah, definitely, if you're doing one of the weather challenges this hackathon, I would recommend taking a look at Mediomatics.
Thank you, Katelyn.
Yeah. All right.
Good.
I don't see any other questions, but we did post the links in the chat, and we posted them in the live stream chat as well. So anyone who is watching the feed afterwards as well will also be able to see them. So we'll make sure they get out. But thank you, Martin, so much for taking the time out of your day to present. And thank you for your support of Space Apps NYC and Space Apps in general. You guys have been great over the years. It's been a pleasure to work with you.
Thank you very much, Katelyn, and yeah, enjoy this weekend. And I think we see us Sunday night, right?
Yes.
Okay.
Sounds
Have fun.
good. Thank you.
Thank you. Take care. Bye-bye.
Bye. All right, guys. So our next speaker, or shall I say speakers, are myself and Dominique. So our next talk is about Space Apps in general, and then Space Apps NYC. There's kind of some stuff that we definitely want to highlight, not only about our organization, but some of our plans for the future. We'd love for you guys to weigh in on some of the plans for the future as well. That's something that, you know, we want to get some feedback, see if what we have on deck is something that you're actually interested in. But Dominique, I don't know if you wanted to start it out with maybe, I don't know, should we start with Space Apps NYC or Space Apps Challenge?
Well, hello everyone. Thank you for coming back. And also thank you, Dr. Engler, for your presentation. I actually was doing some data science work this year. We were trying to do weather forecasting, and it was so complicated. And I think if we had access to your company's APIs and like just data access, it would have made a project so much easier. So definitely stressing to anybody this weekend who's using, who's tackling a challenge that involves weather or can use weather in a unique, innovative way, definitely check out that link, get the free account for the weekend, and test out all that out. In terms of this our session right now, we really want to talk about just why, like, bring you guys along on our journey of why we are co-directors of Space Apps NYC. And so I don't think there's really a clear like separation of Space Apps from Space Apps NYC. And so I know my journey started in 2014 when I just volunteered for Space Apps NYC. I was just transitioning into technology and didn't really know much about it. And to a point that was made earlier, you know, I didn't really see a lot of people who look like me doing tech stuff or working in space. So I really just wanted to see what this hackathon was about, and I didn't have any coding background or anything like that. And when I showed up, I just saw a bunch of people who were you know, happy and excited to work together to hack away at different challenges. They came from all walks of life. They have very different backgrounds, and here they were coming up with really very interesting products and things that I just thought, you know, came out of a sci-fi movie. So it's pretty cool. Not everything worked the way they had intended it to during the demos, but the idea was there and the passion was there. And I felt like this was a group of people that I would love to be part of, like a community I would love to be part of. And so that's really like the first step of my journey with working with Space Apps NYC, and then also really loving the mission that we were supporting. How about you, Katelyn?
I was just about to go grab the dog. Just give me one second. I'm so sorry.
No problem. So while Katelyn's doing that, I'll just continue to discuss a little bit more. When I was in 2014, when I volunteered, I was really just greeting people and helping them stay on track with our schedule. So I didn't really do much with the organization. And at that point, it was just a grassroots organization. And since, which had actually started in 2012, the first year that NASA decided to host the Space Apps Challenge. And at that point, prior to our arrival, we were main stage. We had individuals like Mike Caprio, who were like at the spearhead, and they were really pushing us forward because they had this vision of us being like the nexus of a space-related community here in New York City. And so that was the start of it. And I was really kind of like a bystander, just a fly on the wall, observing what everyone was doing and trying to understand where I could fit in, what role I could play. And in 2016, we had a conference in addition to the hackathon that we were supporting. And that was my first time actually being more active in it, and it was very empowering, right? Because I helped to coordinate the boot camp we had, which was focused on introducing underrepresented communities to STEM. And it was first of all, it was a lot of work, and it was very intimidating for me to go out and like cold call people or follow up with people I didn't know and encourage them to come participate in our vision and in our conference and our hackathon. But I think through that process, I learned a lot about project management, about networking, about building communities. And it was very empowering for me to do that. And it was so rewarding to see the results of not just our participants and our guest speakers and our people who came in to do workshops, but just in general, like the sense of community we had and the vision that I felt that we all were sharing at that moment. And then in 2016, there were actually like parallel activities happening. And so I didn't know Katelyn at this time, but Katelyn was was actually participating in the hackathon that year. And let's hear about your story, because that's super fascinating.
Yeah, so that's perfect because it led right up to my beginning of my journey here at Space Apps. So I was at the point where I had graduated school the year before, and I was trying to figure out what in the world I was going to do with my life. And I was taking a tech boot camp at the time. My mentor suggested looking for a hackathon, and my whole life I've been obsessed with space. I always wanted to be an astronaut, knew it was never going to happen because I can't get in that kind of shape. And so I knew that the closest thing would be trying to, hack for NASA in a hackathon. And so I saw the ad for it and I signed up, and I showed up all by my lonesome. And it was quite intimidating, as Dominique said, in the beginning, just coming as someone alone, because sometimes people come as teams. But I can't stress enough how welcoming everyone was. And the organizers kind of like, took me under their wing and helped me figure out how to find a team and all of that good stuff. And I wound up doing a challenge that had to do with space origami, which hey guys, there's a category this year, so maybe take some notes. No, I'm kidding. But we wound up being global finalists, and so we won the local New York City challenge, and we also then moved on throughout. There were 4 or 5 different rounds that we moved up to, and we were global finalists, which means that we were in the top 10. And of course didn't win, but it was exciting enough. I have some tips on what I believe got us as far as we got, which we can get into maybe a little bit later when we talk more specifically about the hackathon. Yeah, that's how I got started. And then I knew that this was special. I knew that this event wasn't just another thing that happens every year. I saw that it was getting bigger every year, year over year, and the growth told me that this was worth sticking around for. So the next year, I actually 2017, I did not participate. I was in touch with Joe, who is the local lead at the time, and I helped with some stuff before, but I wasn't free the Space Apps weekend, so I wasn't really into it. But in 2018, I decided to participate again, and we didn't win that year, but we learned so much. And by that time in my career, I was a little bit more into tech. I was a customer support engineer. I was working with code, so I felt like I was a little bit more prepared that year. But I decided to kind of pivot what I was doing and start organizing for Space Apps NYC, just because I knew that this was something that I wasn't going to do just to, I wanted to do it all year long. It's such a great weekend. It's so much fun. It's exhilarating. If you're an adrenaline junkie, I mean, this 48 hours will get you going. But I wanted to do it all year long, and Space Apps NYC was that place for me, where I could continue to, have these fun activities, these educational activities, go to these talks, these workshops, and really learn. And not only that, but then, now I'm at a point where I can also teach, and, give my skills as something to give back to the community that's given me so much. So, in 2008 or 19, I started helping out with organizing. I hosted the Brooklyn Hackathon. We had 2 that year. We had one in Manhattan and one in Brooklyn. And I did the Brooklyn one. And I think, Dominique, you were in Manhattan, right? Yeah.
Right.
And yeah, so, and then last year, of course, we did the hackathon virtually, but we kind of didn't know what we were doing because of the pandemic had just kind of kicked in. And so it was a little bit of a mess last year, but we were still here, we were still planning. And one of the cool things that's happened to me personally is Space Apps NYC and the Space Apps Challenge has given me the opportunity to become a NASA Global Ambassador. And what that means is I've worked on enough projects now with NASA data that they've recognized that I understand the open data sets that NASA has. And so during things like the Space Apps Challenge, I'll be available not only for our participants here in New York City, but globally for the Universal event as well, to help out with any data related questions or anything specific to certain data sets or just problems that people are having. So when I'm not present in the New York City challenge, I am over there answering a bunch of data questions. But it's such an honor to have the title. And I'm not sure exactly how many there are throughout the world, but I know that on the meetings there's not too many people. But it's a recognition from NASA, which was always my dream. If it wasn't to be an astronaut, it was just get something from NASA. I don't know, maybe a t-shirt, but to have that actual recognition and like acceptance letter of being a global ambassador was really special for me. And it's honestly just motivated me to want to help out more, which is why we put together the symposium this year for the 10th anniversary of the Space Apps Challenge. It's why Dominique and myself are really taking planning this upcoming year seriously. And we have some really cool things in mind. We're making new connections. We're very excited about where Space Apps NYC is going. And we're continuing to be excited not only for this weekend, but for the Space Apps challenges that will come in the future as well. So yeah, that's my story, and that leads us up to now.
Awesome. And so I guess some of the things that we should discuss now are going more into depth about some of the most impactful moments we had. One of the things that we're going to launch later on in this month is an option for our previous participants to send us a video or write a little blog about what was the most impactful moment they had while participating in a hackathon or an activity with Space Apps NYC. So we're going to solicit all of your feedback about that, whether you found your career trajectory through coming here, or you met people who you've maintained a really amazing relationship with, or you learned something about yourself, such as a new skill set that you didn't think you'd be able to develop, or that you didn't know that you needed until you got it. So we're looking for that, and please visit our websites later on to find out more information about that. We'll be announcing that a little later in the month. So that's one thing. And so, Katelyn, did you want to talk about any impactful moments you've had since working here, in addition to being super badass in 2016 with global finalists?
Yeah, I mean, one thing that I'm really passionate about is making sure that your team submissions are complete. I know that Karen Lopez spoke about this before in her talk about managing time, especially during the hackathon. But it's the first thing that judges look for is making sure your submissions are complete. So no matter what, if you're participating this weekend or in any other hackathon, the first thing that they're looking for, they have people who are not really judges, but are just there to make sure that certain boxes are checked. And that's the first round of judging. And if you don't pass that round of judging, you're not even really getting eyes on your project. So That's one bit of advice I wanted to pass on. But in terms of impactful moments, I mean, there were a couple. Definitely my first year, we built a prototype. Actually, I might as well share my screen now. I have it all pulled up. We built a mesh network of self-propelling origami robots for the surface of Mars. And this was our documented journey. So, you know, we had this little tiny conference room, and then we moved into a nice big conference room because they realized that, you know, we were serious and we needed some space. You know, we wrote down our questions and our design principles. You know, we had lots of different things going on the whiteboard. We changed the magic ball to tumbleweed, which was our final name, our project name. This was the actual folding of our prototype. So it took a very long time to fold. And I believe, yeah, we actually have a video. This is him actually folding our prototype, which you'll see what it looks like in a moment. But the impactful moment that I'm thinking of is really the moment we saw it working, and the moment that we had something tangible in our hands that we created in under 48 hours that was actually working. That was a moment that I never ever thought would be something, and here it is, something I never thought would be so important to me, but just seeing this little ball roll around like in the wind was amazing. I mean, it's got 2 Dunkin' Donuts cups on the ends of it. But it was a concept that we had just come up with out of the blue, and it worked. And just to see that and be part of it was amazing. This was one of our local leads at the time, Stuart. He was the head of the Carto DB, where we had our hackathon that year. Oh, and then we had a wireless orientation module that basically lived inside of the tumbleweed and told us if it was moving or not. So the idea was, if one of the tumbleweeds got stuck in a crater or between 2 rocks, or, you know, for some other reason wasn't moving, we'd be able to tell, because of the orientation modules, that it was a loss of life for the project, because that robot was then not moving anymore. This was our whole team. You can see we have several prototypes. We've got a launching device. It was pretty intricate. This was actually the video. If you look here on the computer, it'll go back and forth between the computer, but when the tumbleweed is not moving, these lines aren't moving. But as soon as the wind picks it up, you'll start to see the lines moving. And this was our proof of concept. So now it's moving, and you can see that the levels are moving as well, whereas before they were just still. So we were able to prove that it worked, which was great. This was just some extra pictures. We decided that it would be powered by solar panels that would look like this. This was the orientation module inside. And this was our launching device. Basically, they would fold because they're origami, they would fold up, they would get real small, and they could be transported in tubes, which are a lot easier than footballs. So if you push them out, they pop into shape, into their little football shape. So as you can see, we have a slow motion little launch going here. But this was our journey, and you know, we have global finalists, tumbleweed. The challenge was origami space recycled, so that's what our challenge was. So that was a very impactful moment. Another very impactful moment was, this is my other team, the Unicode Unicorns. This was the year that we also moved on to global judging. But there was a moment where I was working on some code, and I had never worked on this type of code before, and I was very, very disappointed with myself. And at one point the code worked, and my friend snapped a picture right at that moment when I got the code working. And this actually wound up on the NASA website. And it was just such a moment of triumph, of exhilaration. I was so tired. This was like right before presentations on Sunday. We were waiting for just this little bit of code, and it finally worked. So that look of like pure surprise / joy on my face, I would say, is definitely another one of my most impactful moments that I will remember probably for the rest of my life. But yeah, our tweet, guess what, guys, the code works. We're just as shocked as you guys are. So yeah, I would say that those are really my two big moments. This was actually what we ended up creating. This is our using this data as independent variables in our linear regression model. We were able to predict our dependent variable, open water. So we were looking for how much open water was in a coordinate that, beyond just ice. So we were looking for open water. And our R2 score was 0.89. And just a 1 is perfect, and no one ever wants to get to a 1 because that's kind of scary if it's perfect on the first try. But our R2 score, our R squared score was 0.89, and for 48 hours of work, that's not so bad. And this is how we used Mediomatics. These are all of the different things that we pulled in from their API, all the metrics we pulled in, and we were able to come up with this. This is from 1999 to 2001. It's raw data for temperature, speed, wind speed, humidity, radiation, with 7-day, 30, and 30-day aggregates of each. And this happens to be the Beaufort Sea. So I know this doesn't make sense to a lot of people, but it didn't make any sense. It wouldn't have made any sense to me either, but Space Apps gave me the opportunity to now be able to look at this and be like, hey, I know what that is. I know that that's a linear regression model, and I actually know what the words linear regression mean. And I don't think I would have ever entered the tech field, as enthusiastically as I have. I don't think I'd be as successful, and I definitely wouldn't be as happy without Space Apps. I mean, I've met so many people, I've worked on so many amazing projects, I've got so many great memories. It's something that I hope to continue to do in the future, definitely.
Thank you for sharing that, Katelyn. It's so amazing. And I think that people who haven't participated in one of our hackathons really just don't know the joy. They imagine how hard it is because it's less than 48 hours over the weekend. They don't really imagine, they don't know the connections you make, the joy you have, the things you learn, because it's not as though we come in here knowing about weather forecasting or knowing, your team may have one person who has some familiarity with that issue or that topic, but everyone else is learning so much at that moment just so that they can produce the solution to that challenge. And so, that kudos to you, working on amazing projects and getting so far in the judging. And even for all of the people who don't get past like the first round, I think, the experience is the experience itself is very rewarding. And that's why we have people who come back year after year to participate. I know I come back year after year just to help host, because that's really where I get a lot of my satisfaction from. When I first participated in organizing the boot camp, I remember walking around nervous, wondering if people were found any value in the classes I had coordinated. I'm like, oh, do they like this intro to the program, and do they like this, 3D course, or, and I was asking people, and one lady, she was an older woman, and she said, she had heard about this hackathon and one from her kids, but she thought, this wasn't a place for her because it's just for people who are young, early 20s, and people who know how to code. And she said she was neither. But then after she thought it was so exciting, her kids kept amping it up, and she said, well, once they go off to college, I'm going to take a boot camp class course, and then I'm going to participate in hackathon. And so this happened to be the year where she came in and she said that she felt so much more confident participating because we had this boot camp that encouraged people from all walks of life to come in, and she saw that it wasn't just people who had 10 years of programming experience and a background in astrophysics or something like that. And she said it was an amazing experience, and that was really heartwarming and rewarding to me, because it let me know that the role I was playing was significant. I wasn't just calling up people and coordinating events. I was thinking about what are things that are impactful to people who may be interested in space related activities, but they don't know how to get started, or maybe they feel as though their rocket has gone up to sky already or orbit, and so I think that's one of the reasons why I'm always interested in how can we leverage Space Apps NYC to bring more people into this community and have more people tackle space related challenges or issues throughout the year with the skill sets that they already have, right? Not everyone has to be a programmer. They can learn along the way if they want, but we're looking for people who do UX design or UX research. We're looking for people who come from an art background. We need graphic designs. We're looking for people who project manage. You have to do a lot for a hackathon in a short amount of time. Somebody, at least one person on your team should help you manage your time and make sure you're hitting your milestones and good on your deliverables. So really, I think what I'd like to say in our last 5 minutes is just talk about where we're trying to go next. Now that we have established ourselves as one of, we have the hackathon every year. We've had it. This is going to be the 10th year. This is the 10th year that Space Apps NYC has hosted it. And we want to tell everybody what our ideas are going forward. And some of them include, in addition to this hackathon that we're having every year, we want to have workshops and more presentations. We want everyone to feel more connected and learn more about space-related activities. We want to shine light on the growing space ecosystem in New York City. We have startups that are developing spacesuits, or we have people who are working on growing food in space, and we have people who are creating VR software to help train people. So there are all these different things that are happening in New York City, and we want people to know about it, and we want to encourage more people to get involved. Do you want to share some of your ideas that we've been discussing as well?
Yeah, I also want to say, and just another quick thing that Dominique mentioned is that participation is for everyone. I mean, like I said before, we had a 9-year-old come a few years ago, made the coolest invention ever, was very impressive, had no coding background, still participated, still had a tangible project at the end. It's really for everybody, and that's what Space Apps NYC strives to achieve, is spaces for everyone. We want to educate, but at the same time we also want to have fun, and there are ways to do both. And like Dominique said, having workshops, boot camps, maybe coding nights where we just have maybe some mentors and someone can help with your project. But another one of the more fun ideas and less educational ideas I had was to simulate a space mission. So where you have one team that is ground control in like JPL, and Houston, we have a problem. And there's also a team that's in space and has to tackle challenges, and they need to be able to work with one another through these challenges to simulate a real space mission. So that's something that I'm working on. It's not going to be until 2022 for sure, but that's definitely something that I'm looking forward to doing. There used to be a place that did that around here, but they actually closed permanently. So that's unfortunate, but I'm going to make it happen. But yeah, beyond that, I'm passionate about educating children. I'm passionate about educating women of color, women in general, and people of color, just underrepresented communities, as Dominique also mentioned before. I'm really passionate about getting those communities educated in the ways that they want to be educated, and reaching out across the board and being like, hey, you can do this too, because it's like I said, again, space is it for everyone, and I want to make sure that everyone knows that. And I think right now the problem is not everybody knows that. So that's kind of my personal mission.
And your dog seconds that.
Yeah, Lily agrees.
And so also, if you, in addition to that, we also want to strengthen our partnerships and grow more partnerships. A lot of the people who presented today, we want to work more closely with them. And a lot of people who will be presenting, who haven't presented today, we're either we're working with them closely now, or we are establishing strong relationships so that we can create some type of programming and activities to share. A lot of the stuff we're going to do is going to be free to low cost, so that we can reach the widest, most diverse group of people that we can. So we're definitely very focused on that. And if you all have ideas that you think would be great, we'd love to hear from you. You can drop some suggestions in our comment sections here. You can email us at organizers@spaceapps.nyc. We're going to, on our website, we'll post more ways for you to get in contact with us and give us your ideas. You can also join our mailing list. As we have events throughout the year, we're definitely going to continue to solicit feedback, not only on what you think we should be doing, but what we are currently doing, if we're doing it well, if there are ways we can enhance it. We definitely want to make sure that we're not just thinking of what we think people want, but actually listening to them and responding and iterating on our projects so that we can get to a state that makes sense and that is bearing fruit from all our hard labor. And on that note, we've wrapped up our chit chat with you guys.
Yeah. On that note, yeah, we have our next speaker ready. We are going to be speaking with Ariel Ekblau. I don't know if I'm saying that right. Am I saying your last name correctly, Ariel?
Yes, Ariel Ekblau, you got it.
Ekblau, okay. I just wanted to make sure. Ariel is from the MIT Space Exploration Initiative. She's going to be talking a little bit about what they've been up to. Some of the things that she's going to be talking about are very exciting. There are things that I didn't know about that they were working on that I'm very excited about now. So with that, I will let Ariel take over.
Fantastic. Well, Katelyn and Dominique, thank you so much for having me. It's an absolute pleasure to be returning to the NYC Space Apps Challenge. I don't know if you guys had mentioned this before, but I actually had a chance to participate as a member of the hackathon back in 2014. So it's really delightful to have the chance to come back and speak with you all. I am the director and founder of the MIT Media Lab Space Exploration Initiative. And what I'm going to talk to you guys about today is a little bit about the research, the flight opportunities, the ways in which this organization at MIT is democratizing access to space, and also some of the ways that you all could get involved. So as many of you know, we are at this cusp of interplanetary civilization in this decade. It is really momentous that NASA is planning to go back to the surface of the moon within the next few years and send the first woman to the surface of the moon as part of the Artemis program. We are already really excited and gearing up at MIT to be part of the research that will return to the surface of the moon. And this really is part of NASA's long-term moon to Mars strategy as we think about preparing for human missions to Mars. What can we learn from a nearby celestial object like the moon, and being able to actually get sustainable settlement going? When we think about Mars and reaching further out, of course, there are groups like SpaceX. So this is an image credit to SpaceX. Many of you, I'm sure, are familiar with Starship and Elon Musk's plans for developing sustainable systems there. But even in the nearer term,
we are seeing an incredible inflection point in the space industry right now, with the rise of commercial space habitats much closer to home in low Earth orbit. I'm sure many of you are familiar with the International Space Station. We are already looking ahead now to a near future coming soon, where we are excited to work with Axiom and other players that may have free-floating, standalone commercial space stations in orbit. We expect that this will really revolutionize our ability to do research, to send payloads up, and then soon even sending our own researchers and staff and graduate students and undergraduate students as we begin to see the proliferation of these civilian missions like Inspiration 4 that happened a few weeks ago, the Axiom 1 mission that's coming up early next year. I'm sure many of you have also followed the news about these suborbital platforms that are really coming online now for space tourism. Blue Origin, we have had the pleasure of flying on the Blue Origin rocket for our research payloads, not the humans yet. So it's great to see that this is now coming online as a space tourism opportunity. And of course, Virgin with their Spaceship 2 as well. This all really brings us to an appreciation for the fact that at this particular moment in time, we're seeing a real burst of growth in the space industry, a lot of burgeoning activity. And we can think about, what are the precursors, the historical examples where we've seen this before. And one is, the birth of commercial aviation after World War II and the rise in the ability to travel to extreme environments. This is a glacier in Alaska that Alaska Airlines is able to bring, people to for the first time in the 50s and 60s and then into the 70s. And we are trying now to do the same, to prepare humanity to become an interplanetary civilization and really go forward as a spacefaring species. And it's an incredibly exciting time to be at a hackathon where you're thinking about the next generation of space technology that can contribute to this era of burgeoning human spaceflight. As we think about the future of space, there are a couple different dimensions, right? We really want to be able to scale humanity's presence in space. And so part of my research and my area of interest is space architecture. How do we design systems, space habitats, space stations, eventually large scale space structures like what we see in science fiction? How can we design these systems with an eye towards indeterminate growth? So this is an example from biology. It's a term from biology where systems don't just grow and stop at a certain scale. You're able to actually expand and grow much larger over the entire life cycle of an organism. Similarly, in space, I think we could benefit from taking this metaphor from biology and say, how do we transition beyond the International Space Station model of space habitats, which can only accommodate a certain amount of people at a time? It would be very hard to scale that particular example of architecture module by module to have enough to have hundreds or thousands of people living in orbit. What are different geometries for space habitats that might allow us to scale and grow indeterminately? And then on the same, other side of the coin, we want to think about the impact of the technologies that we will design, whether it's in my space architecture portfolio or thinking about the future impact of space debris, thinking about how we negotiate shared use of the space commons as a shared domain of activity, and of course shared resources like electromagnetic spectrum for frequency bands that are required for in-space communication. These are examples of resources that we really need a new space ethics and policy framework around. And so I hope some of you, as you're going through your hackathon challenges over the next couple of days, will take some time to think about both next generation interesting new ideas for space technologies, and how do we make sure that we're doing space technology development in a responsible and an ethical way. Here you see a slide that is actually an artist's render of 14 different projects from our research portfolio at MIT. So again, I lead the MIT Space Exploration Initiative. This is an organization that supports all kinds of different people across MIT to be able to get your research actually built and deployed in a space environment. So we support scientists, aerospace engineers, physicists, but we also support artists and biologists and creative designers and architects, because our vision is saying, if Elon Musk and Jeff Bezos and NASA and ESA and others are going to be working on the rockets to get us there, wherever there may be, Mars, Moon, or beyond. We at MIT, in my group, we are working on the human lived experience of space. So what are all the different artifacts and tools and products that we would all want to be able to have in a future space habitat to be able to really support a richly envisioned life in space? And so here you see examples of the agricultural units that we're working on for growing future space food, mechanisms for mobility. When you're actually floating in a large scale open microgravity chamber, you'll need ways to propel yourself and control your momentum in the space. Even to the architecture itself. So here you see you're in essentially a very large geodesic dome. We think this is one of the examples of geometries that could scale well to support larger numbers of human life in space. And of course, also thinking about things like mental health and well-being. So in the bottom right-hand corner, you see kind of our conception of a entertainment or relaxation area where we've designed a musical instrument that only plays when it's floating in microgravity. We've designed the kind of the sensorial aspect of a projection environment that can make you feel like you're in a greenhouse or a really rich, lush, open area space on Earth. These are all interesting components to a holistic and well-designed life in space. And so this vision is really what drives our work at the MIT Space Exploration Initiative, which is how do we build out all of these different artifacts and prototypes? And I like to say we're not just a design house. We do really actively build examples of these products, and we fly them on parabolic flights, suborbital launches with Blue Origin, International Space Station missions, and we're preparing for our first missions to the lunar surface in the coming years. We like to say that we are training the space generation, and all of you members of the Hackathon Symposium today are very much a part of this. This was a parabolic flight that I charter every year for our group at MIT. And here we have former NASA astronaut Katie Coleman, who I actually met for the very first time at this event in 2014. That's where I met Katie, and it was the beginning of a wonderful collaboration. And so I hope you all have an opportunity to meet people like Katie at the hackathon this weekend, even virtually, and make connections that can continue to last throughout your whole career, as I have continued to work with Katie on many different spaceflight opportunities. Here she is floating in zero gravity on a parabolic flight with one of the students that the Space Exploration Initiative at MIT has supported, working on a wax casting propulsion payload. This is an example of our team. So it takes a large group to be able to pull off all of this space research. We're very fortunate to work with over 50 graduate students, staff, and faculty at MIT across many different departments. And we work really closely now with Dava Newman, who was formerly our mentor when she was a professor in the Aero Astro department. Many of you may know she was the former deputy administrator of NASA under Charlie Bolden during the Obama administration. And Dava is now our new director of the MIT Media Lab. That is the organization that our space lab sits within. We are under the MIT Media Lab, and so we're really absolutely delighted to have Dava at the helm and helping us lead our space work this year and in the future. What I'd love to call out about this team is, if you notice, it's the diversity of backgrounds. And this is also something to really, store away for your future careers, in that we no longer need only STEM people in the future of space exploration. STEM education is still critically important. I myself am trained as a scientist and then had my PhD in aerospace engineering, but we also need space designers, space lawyers, space doctors, all kinds of different professions now we will want to be bringing into the mainstream of designing for life in space. And so no matter where you may come from in terms of your background or your academic training or what you think you want to do in terms of your career, there is likely a place for you in the space industry these days. Here's a mosaic of just a few of the concepts, the different prototypes that we've built and flown over the years. You see we do everything from zero gravity 3D printing and advanced manufacturing to self-assembly. This is my particular passion, and I'll show you a little bit more about this later, how we could imagine designing structures that are like Legos that build themselves in orbit through the use of very powerful magnets. We also work on soft robotics, exercise equipment for the future of human life, space suits, even space fashion, thinking about the future of AR and VR in a space environment. And like I said before, you're not a real space program if you're not actively launching into space. And so every year I charter a full parabolic flight This is the 0G plane that you see in the bottom left corner. And for anyone who's not familiar with this, it is affectionately known as the vomit comet, because the plane does what you'd want a plane never to do, pitches very steeply upwards at 45 degrees, noses over, pitches very steeply downwards at 45 degrees. So it flies this very dramatic arc in the sky, and then repeats that arc 20, 30, 40 times. So it's very much like a roller coaster in the sky. And at the top of that arc, you're able to have about 15 or 20 seconds of pretty good quality microgravity when you really have this floating sensation. And so that's when we turn on the research experiments. That's when we test the different projects that are on board the plane. From there, from the zero gravity flight, we will progress research to a flight on a Blue Origin suborbital rocket, the New Shepard rocket platform. This is an opportunity to send your payload to space for around 3 minutes. The rocket goes up, separates the capsule where the experiment lives, separates from the rocket booster. The capsule floats for 3 minutes, very good, high quality, clean microgravity. So you have a longer duration of microgravity than you would on, say, a parabolic flight. And then if all goes well, the capsule returns and it lands and you're able to retrieve your experiments. From there, we support students to also fly their payloads to the International Space Station. So here on the ISS, we can work with astronaut interaction missions. So if you design something like a musical instrument that you want an astronaut to play with or to test with, we can do interesting experiments inside of the experiment racks on stations. So biology, robotics, science missions. And then we're also looking forward to the future to doing external tests on the surface of the International Space Station for things like new habitat materials or robots that might actually crawl and swarm on the outside of the space station to detect different dangers or detect, micrometeorite punctures, things like that. And then longer term, we are very excited about the momentum that is growing in the space industry now to return to the moon, not just through NASA, but through a host of commercial partners as part of the NASA CLPS program, the Commercial Lunar Payload Services program. And that has succeeded in really launching and kind of jettisoning a whole early industry of landers and rovers and different spacecraft that are going to be driven by commercial companies, but available to academics and researchers like ourselves to be able to send our work back to the surface of the moon. Our ecosystem, we work, as I mentioned before, 50 plus graduate students, staff, and faculty. We are quite fortunate to be funded by about 60 different member companies. This is what's very unique about the Media Lab. This really lends a very concrete, mission-driven, very kind of effective time scale for working on projects, because we have all these companies that are interested in the future of products for life in space, or where they might be able to eventually grow their companies to also be a space company. So we work very closely with corporate bodies there. And we also have collaborations across the space industry now with different new space age startups, with folks at NASA, ESA, and JAXA. So if you're listening to this and you think you have a project that might be a good candidate for a collaboration, or you would like access to one of our flight opportunities, we're really open to collaboration. And I'll give the website, a link to our website at the end of the talk. And we have an email on the website where you can reach out if you're interested in learning more about the initiative, or maybe getting involved with us even. We care really deeply about democratizing access to space. And that's one of, I think, the most special things about this symposium day in particular, and about this hackathon, is that it's bringing people from all walks of life to a set of challenges, thinking about the future of space exploration, and can unite people from different backgrounds, different disciplines, different ethnicities, from all around the world, right? We're talking here in the New York session, but this is going on simultaneously in many different sites around the world. And it really is time that we thought about democratizing and opening access to space exploration. And so throughout many of the projects that we do at MIT, whenever we can, we open source them. We teach several classes each year, one about zero gravity flights and how to prepare research for a zero gravity flight, how to prepare for a mission to the moon. And we open source this curriculum in an effort to really share our knowledge and try to get more people feeling prepared to participate in the future of space exploration. So this is one of our core mission elements, is to really democratize access to space and help all of you see yourselves in a future where you would really get to go to space, or at least participate as a designer or an engineer on a real spacecraft mission. Every year, we run a large event at MIT. It's a very special gathering. We don't charge any money for it. It's completely free, and via live stream, it's open to the public. And it's called Beyond the Cradle. We're celebrating here this notion of Earth as the cradle of humanity, and how do we prepare to move beyond it as a spacefaring species, but also protect it. And I think in the last few years, we've understood and really come to appreciate, as a country and internationally as well, the importance of preserving Earth in the face of climate change. And so now a lot of the space technologies that we're thinking about can also be explicitly considered for the ways in which they can come back down to benefit life on Earth. And that's part of the spirit of this event, is bringing together lots of different perspectives about the future of space technology, space art, space design, science fiction. So we bring astronauts, CEOs of space companies, science fiction authors, Hollywood producers. We bring about 60 leading space visionaries all together to MIT each year in March, and this is going to happen again this coming year. And we would encourage all of you who are tuning in for this hackathon to stay in touch with us. Reach out on our website, follow along on our Twitter, where we post information about the event, and we would love to have all of you be able to engage with this really amazing group of people that we bring to MIT every year. In terms of my personal goals and the research that I lead for the future of space habitats, my real passion is in self-assembly. So how can we design habitat architecture, large-scale space structures that would be able to build themselves in orbit without requiring a robotic arm and without requiring a human EVA, or an extravehicular activity, when the astronauts don their suits and go outside of the habitat? And one of the ways that we have conceived of doing this is to take tiles, much like the pentagons and hexagons that you see on a soccer ball, or also known as a buckyball, and prepare these tiles for space, make sure that they're space grade, pack them flat in a rocket, in a stack inside of a rocket payload fairing. When these tiles are released outside of the rocket payload fairing, once we reach orbit insertion, the tiles have very powerful magnets on their edges, and the tiles are able to come in together and be brought in together for autonomous bonding. So this does not require any human intervention. It does not require a robotic arm or a robot to, reach around and manually connect the tiles. It's really like thinking about Legos with magnets that would build themselves. And so the tiles just swirl around nearby each other and click into place. We've had an amazing opportunity to test this technology in miniature form on the International Space Station, and we were able to validate the control code, the electromechanical systems, the magnet actuation for self-assembly, completely, unguided self-assembly. And this project now is continuing forward as we plan for how do we build ever larger and larger versions of this system, and eventually be able to do a tech demonstration in orbit. One of the benefits to a modular space habitat is, unlike the International Space Station now, which is a unibody shell spacecraft, right? So there's multiple modules, but they tend to be a unibody aluminum shell. If there is a bad puncture or a fault in that structure, you really do have to repair it in situ. In the future, with modular architecture, we are excited about the potential for, if there was a single panel that was damaged in some way, you can temporarily depressurize that module and pop that tile on and off. So we have complete reconfigurability control. What this also means that we can do is respond to more agile mission needs for the future. So if you've initially configured your buckyball space habitat to have a few windows, maybe a few cupolas, a berthing port, a docking port, and then in a week, that you're actually going to need to dock with 5 additional modules, you can pop that cupola window off, add on a new CBM tile, so a common berthing mechanism tile modeled on the International Space Station mechanism, and then be able to retrofit a habitat to change the types of missions that it is able to support. And this is part of that initial goal that I raised at the beginning of the presentation about how do we scale life in space. I think one of the ways that we do that is by making systems that are modular and more reconfigurable and more flexible for the different types of missions that we might confront once we are out there. In contrast, this is an example of essentially all of the realized space architecture to date. You can see that most of it is based on these aluminum pressure cylinders. In the bottom right, of course, you're looking at the Apollo lunar lander, which is a little bit different. It's one of the few examples of architecture that sustained human life for a few days on a surface of a celestial body, of course, on the moon. And the question that I like to pose is, what would it take to get us from this model to something like this? Right? So for decades now, we've been exploring space architecture in this mode, but we have not been able to achieve the ring worlds or the large scale space structures that we see in science fiction. And I think one of the challenges, of course, is just the cost and the budgeting and the realities of the American political process to be able to achieve the level of funding that would be required for something like this. But it's also the engineering approach. It's the paradigm that we take that would allow us to build large-scale space structures that we might need to change from how we've been building in the past. And so what I'd like to propose is, if we all want to see a future like this is from 2001 Space Odyssey, decades ago. This is envisioned speculative space architecture. If we want to see megastructures like this succeed, instead of trying to build the entire structure all at once, which would require a huge engineering challenge, a really large and significant budget, so probably an immense and perhaps unsurmountable political challenge, we could start small, grow organically, design, and organically I'm using here as a metaphor, design more in the way that nature grows, by additions of one cell and one cell and one cell into a tissue, to make something that is a modular space station that can really grow and expand. And so here you see an example of a blown out view of the International Space Station and how it was assembled. Very manual, right? With robotic arms, astronauts going out to do EVAs. Here's an example of an astronaut doing some of this work, an ESA astronaut off the end of the Canadarm. But instead of this paradigm, where it's quite a lot of kind of massive, kind of individual, custom, bespoke construction, could we be inspired by nature and pick a pattern for the ways in which a space station scales and grows, where each individual part of the larger scale megastructure, in this case, each node or each leaf that you're seeing of this philodendron, this establishes a pattern for growth where each individual module that we might build of this large megascale station is actually small and is modest and is cost effective. So this is just a slide for inspiration of the types of geometries that we might be able to achieve in the future for space stations if we free ourselves a little bit into a different design principle for space architecture. Now I'm going to play a video, and I'll end after this video. This is a concept video for the Tesserae self-assembling space station. This is the project that I have been showing you a little bit about buckyball and the self-assembling spherical approximation space station, and we call it Tesserae. Here you see the tentacles in that flat path stack. That's how the titles would be able to be put into their area of orbit where they would have magnets, pointing edges, or shell. Here you see a little bit more of the shell coming together in modular parts. There are ways to do this with older tiles, exactly where to go, and give them to assembly. And there's also ways that they can do it completely autonomously, just energy ability of you see a multiple dot shell discussed how we would go from a single module to a space station. Here now we've flown inside the futuristic space interior. It's a concept that was developed in partnership with a university in Germany around the future of space logistics that handle the shipment movement of space and between things. This concept that mediating the atmospheric qualities of an environment, that artist Ventre that I showed you at the beginning, about the quality of interior life, mental health. Now here we'll close the video with how these habitats could be reused, but also support how the Walle won't self-assemble quite elegantly in a gravity-based system. They need microgravity to float and self-assemble. You could still pack them flat again, able to be disassembled, and reassemble them on the surface of Mars or the Moon or wherever we may be voyaging. And so with that, I will stop my screen share and I'm happy to take a few questions. I'll also put in the chat our website. I'm not sure if this is going to go to the full, here we go, everyone, hosts and panelists. So that if anyone is interested to follow along with our work, you can find an email address and a way to reach out on the website.
Amazing. Thank you so much, Ariel. That was so interesting and motivating. Personally, I have a project I'd like to talk to you about,
Please do.
Yeah, it's very inspirational to hear that this work is going on and that someone who maybe isn't an engineer could be sending something of their own work up into space. I think that's amazing. It's an opportunity for everyone, and it kind of goes with today's theme, which is space is for everyone. So I really appreciate your talk today and taking the time out of your very busy schedule. I'm just going to check the live stream very quickly to see if there's any questions. What's the easiest way to connect with this initiative for collaboration? We answered with the site that you just sent. Is there another way that is better for collaboration?
That's the best way. So if you go to the website, you'll find our email. I can also type the email into the chat if you folks are interested. It's explorespace@media.mit.edu. And that's a way to reach out if you're interested in collaborating or if you'd like to get on our mailing list and follow along with the activities that we do throughout the year.
Amazing. Yeah, we'll pass that on to the live stream as well. But beyond that, I don't see any other questions. But thank you again, Ariel, for taking the time and doing the work that you're doing. I think it's really important work, and very excited to see where you guys are headed in the next few months and years to come.
Well, thank you so much for having me, and I hope you all have a wonderful time at the hackathon. Good luck, and I'll see some of you again this weekend.
Sounds good. Thank you.
Thanks. Bye-bye.
Alrighty, guys, our next talk is someone that if you've been on the stream all day, you are a little bit familiar with. This is Karen Lopez, who is back to talk to us about what's that smell working with open data. Her talk is going to be a little bit about how open data sets have sometimes left us with more questions than answers. In this presentation, she's going to discuss the types of data anomalies that organizations can run into when they use external data, the wrong data sets for the right reasons and the right data sets for the wrong reasons. She uses real life examples of her own data to show the impact of bad data decisions. And I think this is going to be a very important talk, not only for our hackathon, but for our daily lives as well. When we are using data, it's not always perfect. And well, what the heck do we do when the data is not perfect? And I think Karen's here to tell us what we should do in those situations. So Karen, I will hand it over to you.
Thank you so much. So I'm laughing because even I find this topic funny. And this is based on a topic that I've called various things over the years, but it uses examples of my own data having been messed up by other people's systems. And so this is kind of a funnier, snarkier take on just the very basics of data. So let me get my screen shared. There we go. So there we are. So I've titled it this time, What's That Smell? Because yeah, sometimes data isn't always as healthy and fresh and timely or even as useful as it might claim itself to be. I'm Karen Lopez, and I'm Data Chick on Twitter. I do tweet a lot, and I tweet a good combination of data-related things, privacy and security, as well as space enthusiasm. So it might be a good fit for all of you as well. I just want to give you a warning that this, like I said, this presentation is a little bit snarky. It's a little bit irreverent. Like, I love data. I consider myself part of team data. But again, I'm going to show you the way sometimes you go to work with data and it's not loving you back. And this is also sort of a rant that I have that I've been giving for years, which is why I've got a picture of some NASA control panel that has a flame bucket. So this is kind of my flaming rant on this take. So you might have heard that, you know, big data has 3 or 5 or 6 V's, like volume, velocity, and variety. Well, I'm here to tell you there's a new V, because data is veered. Okay, so maybe only if you're German, if you speak German, does that make sense? So I'll just say data is weird. And that is because primarily people are weird, just a little weird. I don't know if you've noticed that. And that's because innovation's weird. Like, I started my career a few decades ago, and the things we worried about in data design, some of them are still the same. I have some data quality presentations where they've been updated with new terminologies, but the theories have been the same for 35 years that I've been giving them. So that's not the problem. Innovation's great. Like, definitely it would be a hard time for us to have this virtual hackathon if the internet and the World Wide Web hadn't been invented or deployed yet. But sometimes innovation in data or innovation in development techniques causes your data to go astray. Now, I have a little story here that won't make a lot of sense why I'm telling it right now, but we'll come back to this story. But here's the story. Back in 2011, a gentleman urinated into a water reservoir in Oregon. And, you know, there's a picture of a type of reservoir. These are used to retain water that eventually go into the water system for the locality. And a guy got caught having a leak in this reservoir. So what happened is that 8 million gallons of water in this reservoir was drained. And I'll just let that sink in for a minute. So these reservoirs, they're open to the sky and they're open to the land. And let's just say that probably no one should think that a few ounces of human urine would actually have any impact at all in the quality of that water, given the fact that ducks and geese and maybe fish and frogs and mosquitoes all live in that reservoir as well. But just in the interest of keeping public confidence in the water system, the water board decided to drain these 8 million gallons. And that cost the Oregon municipality $34,000 to drain that reservoir. Now, in an overall county or city budget, that's not a lot of money. And again, they were kind of buying confidence into the water system, the purity of it. Hold on. And they said, the basic commandment of the Water Bureau is to provide clean, cold, and constant water to its customers. So they're just trying to keep their marketing and their brand up. Well, remember, I told you data is weird. And data is weird because people are weird. The other weird thing about people is they lie sometimes. I know that this is shocking for you, but they lie. Here's one of my favorite data-related lie stories about data. So back in 1989, do you remember that 7 million children in the US disappeared off the face of the earth? Do you remember this? Do you remember reading stories that on a single day in April of 1989, 7 million dependents disappeared? And I'll let you think for a second on why that might have happened. It was in April. The reason these people disappeared was because the IRS started adding a requirement that dependents who were used to get a deduction on US taxes, these children before 1989, you could just say, how many dependents do you have? So you could put 4 or 7 or 12, whatever it felt like in your house that morning on April 14th when you decided to start working on your taxes. But in 1989, the IRS put in a requirement that children or anyone listed as a deduction on your taxes also had to have a Social Security number. And they phased this in with older children first being required, and then finally it came down to even babies. So prior to this change, most kids, so people my age, you didn't get a Social Security number until you either got a job or went off to college or got a full-time job after college. Like, it was just not required that children have Social Security numbers. Well, when this rule came out, what happened was people who were willing to accidentally over-report the number of children in their home, now all of a sudden, to keep reporting all those children, would actually have to take this extra step of falsifying birth certificates, of going down to the Social Security office, filling out a form, getting a Social Security number for these kids. The 12 that they thought they had, when really they only had 2. It just felt like 12 kids. So all of these children disappeared just with the filing of tax returns. Now, this particular data anomaly resulted in a loss potentially of up to $2.8 billion worth of income tax because people misrepresented how many children they had. So this is an example of how a policy changed data. So why is this important? If you were working with open data, let's say, and there are open data sets with the IRS that is anonymized or aggregated or both, where you can go look up, say, the average number of dependents. And if you didn't understand why this data anomaly happened in 1989, you might make this decision that something horrible happened in the US, that all of a sudden there were 7 million fewer children and dependents. And you might even write a paper about how this didn't happen in any other countries that year. And it must have been alien abduction or people just vanishing or something like that. You need to know the provenance of the data, and that often isn't logged or given to you anywhere. And we're going to talk about some other stories about that. So this is a 5-digit number that starts with 4. And there are some guesses that you could make about what these numbers mean. Depending on where you live, this might be instantly sort of look familiar to you, or it might not. So I'll tell you what this number is. This is a number that I regularly give to systems, on surveys, when I buy things, and it's a lie. It's an absolute lie. And the reason I intentionally lie is because this is the zip code, the postal code in the US for Hell, Michigan. Now, why in the world would a nice data evangelist lie about data? Well, I'll tell you why I have to lie about data. Some systems require you to enter a postal code, and they've renamed their label postal code, and they're very happy for this globalization that they've introduced into their UI or their UX of their applications. The problem is they've put in a database constraint or a application constraint that forces the postal code to look like a US zip code. So my postal code has letters and numbers in it because I'm in Canada. I can't enter it into a lot of systems, and I'm forced to enter a 5-digit numeric only value. Well, in the olden days, I used to put in 90210 or something, some zip code that I could remember. And then I found that Hell, Michigan has this zip code. And I'm always telling systems that if they want to find me, they can go to 48169 because their systems forced me to lie about my postal code. But it's not all the fun for US systems. So this is a really common postal code in Canada, H0H0H0. And that is because this is Santa Claus's postal code. And if you write a letter to Santa, this is where you write to, ho, ho, ho. And just to let you know, yes, indeed, Santa lives in Canada, the North Pole. So anytime you want to write to Santa, write to him via the North Pole, H0H0H0. Having said this, this is a common way for Canadians to fib about their postal code if they're wanting something but not really wanting to give real data, much like my Hell, Michigan zip code or 90210 or something like that. So that means that many retail stores will not allow a customer, if they ask you for your postal code for demographic reasons, will not accept this one. So what happens then? You've got a customer, they've bought a t-shirt, they're trying to go on their way, and the point of sale system is forcing them to record a valid non-Santa Claus postal code. Well, I'll tell you what actually happens is the customer who says, no, I won't do it, they don't give their real postal code. They give a formal postal code, or what happens is the person working at the point of sale enters in their own postal code or the postal code of the store. And all of a sudden, if 20% of the people are fibbing about their postal codes, the whole reason a retailer asks for this information is to do analytics on how far people have come to this store so that they can make plans for either advertising or building new stores. The crazy thing is, by making the data mandatory, instead of allowing people to just opt out and say, no, I don't want to give it to you, is the data has now been severely skewed. And if the people running the analytics on the data don't know that this is a common practice to give either Santa's postal code or the Prime Minister's postal code or the store's postal code, they're going to make invalid, suboptimal decisions about where customers are coming from. So I have this saying to my developers and to my teams, if you want the data to be simple, you first have to go out, make the world simple, and then come back to me and I will make the data simple. A lot of data architects like me and data modelers were being told all the time, but that's an exception. Don't handle that. No, we have to handle exceptions because in our database designs, we're going to code in what are the allowed values. And if you force me to only accept these types of values, your data is going to be skewed. Or if you say there's no constraints, we'll take any data, then your data is going to be skewed to data that doesn't even make sense. So it's a fine balance. So if you were with me in my early presentation, you saw this slide just as a taste, but I'm going to tell you that this is a story reported in the media back in 2017. It made it so many news stories because it was such a great, interesting story. A teenager from the UK had noticed, he was monitoring NASA open data, just like you're going to do in your hackathon, and he was looking at sensor data that was reporting energy levels on a sensor based on the space station. But he noticed one unique thing about the data was that sometimes the data had a negative number for the energy level for that sensor. And as many of the media reported, you can't have negative energy on a sensor. And so he contacted NASA, and no one at NASA knew why these sensor data was all wrong, including NASA experts. And I had to kind of laugh at this because I'm really sure that what this was a case of is if a sensor didn't record data, didn't report data, it's highly likely that the database, the data set intentionally recorded a negative number, which is what I call using a faux null. A null is an indicator that there is no data. Either there's no data because none was measured, like in the case of this sensor, or because that particular data item doesn't apply to this particular instance or record. It could be because the person reported a value that was outside norms, and rather than record the outside, the expected values, the developer decided to record a negative number to say, we don't know what the actual value was. There's all kinds of reasons that nulls actually exist in the real world. And I have another story coming up next about that that's really familiar to me. So what was happening was there was something you had to know about the data itself to understand it. In this case, for this data set, there should have been documentation, and maybe there was, that a negative value in the energy level was an indicator to you that there was no valid reading at that point in time. And that's important to you as someone using data, because that negative number has a special meaning among all numbers. So sometimes I get the question, why wouldn't you just record a 0? And that's because at an energy level, a 0 has a completely different meaning than the amount was missing, because 0's an actual measurement. -1 is not an actual measurement. It's supposed to be an indicator, a flag that something was missing from the data. The other reason it's important is if you're doing analytics or aggregating the data, you have to leave out these special faux nulls because it will mess up the sums and the averages and the peaks and the trends and the skew and any machine learning you're doing. It's all going to impact it. So you have to know when you're looking at somebody else's data set, are there any special values such as 9999 or -9999 or 0 or any of these things to understand the true meaning of that value. So I said these things were nulls. Let me tell you a story about my dad. My last name's Lopez, and so is my dad's. And it's really common in Hispanic families that you are not given a middle name when you're first born. You're given a given name and a family name, maybe a couple of family names, but you collect your what we call middle names throughout major milestones in your life. And in a lot of Hispanic and Latinx families, you collect it like at confirmation, at baptism, you know, different milestones in your cultural milestones in your life. Well, my dad was not given a middle name when he was born, but he also didn't go through all of those traditional milestones. So he never collected middle names throughout his life. So he just doesn't have one. But just like the faux null thing in the past that I just talked about, a lot of systems, a lot of records, a lot of applications insist that you must have a middle name or a middle initial. So my dad used to just fill out none, except that systems just took it and look there, that's his middle name, none. And so I sometimes say none, because that's how you'd say none, those letters in Spanish. And again, this is someone who designed a system and decided, because they have a limited view of names, that everyone in the world has a first name, a middle name, and a last name. And I'm here to tell you that is not true for everyone. So what do people do when systems force them to give data that doesn't exist? They make something up. You might call that lying. I call it none. So this says love your data lake. This just means all your data. This data lake is a pun on the reservoir that we first talked about. So I say data deodorant is a good data strategy. So what's that smell with open data? None of the data items that I've talked about so far are because people had a bad intent. They are because people thought they were doing the right thing with data by using faux nulls, by forcing people to give data. We're going to talk about some other ones because I'm here to remind you that data is weird. So here's another example. So I'm a US citizen living in Canada. I've been here for more than 20 years. And the US government State Department sent me correspondence about my US passport and my US passport card. So you can see there, US government official mail coming from New Hampshire. And what's kind of hard to tell there, but if you look closely, there's a Care of Canada taped to the top of the little wax window on this letter. So the letter's on the inside, my name and address are on the inside, but there's basically a sticker that adds a country to my address, Care of Canada. Now, you have to remember, the US State Department is an organization that not only manages passports and all this other stuff, but also includes things like embassies and foreign addresses and foreign everything. And yet the third-party system that they use to contact me doesn't have room on the letters or in the window to put the country that they're mailing to. So some person or process has to put that sticker with the correct country on it. I can't imagine how crazy that is, that the US State Department can't easily correspond with people outside the US without a sticker being involved. And I don't mean the stamp. And I also found it quite endearing that the US State Department thinks that Canada is caring for me. They are indeed, but that made me really happy. The other example here is from a professional association that I used to be a member of, the Association of Information Technology Professionals. And they had to put a sticker over the whole window that someone had to write out with my full Canadian address. This is an organization proposing that they are a global professional association for information technology professionals. And they also didn't have a third-party mailing service that would support international addresses. This is a clear example of people developing solutions within their internal systems. Like both of these databases would have had my full address, but hadn't tested and therefore implemented international requirements all the way from the start of their business processes all the way to the end. Now, I've seen examples of this in databases and applications where something was designed, it was designed only for a subset of customers, like only for US addresses, only to find out that they actually have to support foreign addresses. And so someone has stuck the country information, let's say in address line 4 of the address. And that doesn't even make sense. They might be overwriting what it legitimately needs to be in address line 4, or it might mean the address gets printed out of order and the correspondence is delayed or not even delivered. So this is one of those data smells that happened because people didn't understand the bigger picture of data. So here's another example. I said my name was Lopez. Technically, my name has an accent over the first syllable, which is placed over the O. Most people who have umlauts and tildes and accents and other special characters over or included, I mean, this really isn't an O with an accent. This is a different character in the ASCII data set. But people who have those that aren't kind of normal, I've heard described letters, we learn, I never type this into a computer system because I don't know if your systems are going to be able to handle that. Now, this particular character, the O with an accent over it, is in a regular ASCII data set. You don't have to use the more expanded, twice as wide data sets or double byte sets in order to support these, but there are characters where you need that. So I just include this fun picture where a friend wrote me a card, forgot where the accent went, so he just put it over all the letters. But typically, we Lopez's that spell our name with an accent have learned not to do that because you end up with a shipping label that looks like that. So look at that name, L, and then ampersand, amp, a tilde, amp, sup, 3, Pez, L with a bunch of escape characters and Pez. That is because, and I didn't do this, someone wrote this beautiful poem, Ode to a Shipping Label, and explained how it went from Lopez with an O with an accent over it, and how all the integration points between the systems caused just this little O with an accent to get escaped all the way through the system until it hit the UPS shipping label and it looked like that. I love this example of how not truly understanding your underlying data causes all kinds of garbage to come out other systems. What does this have to do with the hackathon? You might run across data that has been escaped to heck and doesn't make any sense. This is especially true if you are importing open data from a non-English based system into a tool or database or Excel that doesn't support those characters. And you typically see them on the webs with substituted as empty boxes or boxes with question marks. All of those things happen because somebody put data through a strainer that didn't understand how to use those things. So know when you find those, doesn't necessarily the data was wrong, it just got translated incorrectly. So I also want to tell you again that data is weird. So look at all these boarding passes of mine, old boarding passes. Look at the many different ways my name is rendered here. We have Lopez/Karen. We've got Lopez Karen MMS. We got Karen MS. We got Lopez K. And then we've got this Lopez Karina. So for about 3 years, the name on my boarding pass, when I booked travel through my corporate travel booking site, until the name made it through all the integrations from that travel agency to the consolidators, all the way through to United or Air Canada or the former US Airways, my name would just get mangled. Now, I can tell you that the MS that you see here is likely my salutation, Ms., appended to my first name. So that explains the MS. One of the M's is probably from one of my middle names, which is technically Maria de Guadalupe, but it's probably the M from an initial that got picked up along the way. But Karina is because one of my middle names is Anne, and somehow it was getting appended to my first name. Now, I have no ID that says Karina. I used to refer to this name as my spy name. So that meant that my data was screwed up on a boarding pass and it kept me from getting at my data. So just remember, systems can be good, they lie. If you have a Starbucks name, you've seen how it's been screwed up. So just remember, data hygiene is something you want. Profile your data, because people lie and systems lie. We'll go through these examples. And what happened later is another guy got caught taking a leak in another reservoir. So they had to do the same treatment, only this time it was 38 million gallons, and it cost them even more money because they wanted to keep repeating that good data's. Just remember that someone will always be stinking up your data. And if you want data to be simple, go out and make the world simple and come back to me. So thank you so much for sharing these snarky takes on data quality.
Thank you so much, Karen. I was giggling at the ho, ho, ho example in Hell, Michigan, because I work for a market research company, and I bet you if I were to look.
Yeah, for sure.
That's very funny. I thoroughly enjoyed this talk. I think it's very important to know that data is imperfect sometimes, even though when we are looking at it, we expect it to be perfect. It's very good to remember that. I didn't see any questions in the chat, and I know that we're a little over time. But thank you so much again for both talks today. Both great. We're going to show one of the earlier one at our opening remarks tomorrow, because we think it's really great for the participants. So thank you again, and have a wonderful day.
Yeah, thank you so much.
All right, guys, our next talk is going to be from Prosper. He is an engineer from SourceGraph, and Prosper is going to be talking to us about an introduction to SourceGraph. SourceGraph is a tool that allows you to search all of the code that's important to you. So whether that's code on your machine, your dependency libraries, or open source repositories. This workshop is going to walk us through how you guys can leverage SourceGraph in your hackathon toolkit as you build your apps collaboratively. And also, I believe that, regardless of whether or not it's for a hackathon, I think SourceGraph is an amazing tool that should be used by all. And also, I want to shout out SourceGraph for being an official sponsor of the NYC Hackathon. So thank you guys so much for being a sponsor, and Prosper for being with us today. And I will hand it over to you.
Hi, can you hear me?
Yep, we can hear you.
All right, so hi everybody. So I'm just gonna try to share my screen now. And here we go. I think, yeah, so can everybody see my screen? Can you see my screen?
Yep, looks good.
All right, okay, I'm really glad to be here virtually. I've been listening to all the talks, and they've really been very interesting so far. And I'm also excited to tell you all about SourceGraph and how you can use it in your daily, use as an engineer, in your code base, and how you can also leverage SourceGraph for your hackathons. All right, so SourceGraph is a search tool basically that allows you to search all of your code, public, your private code, and all your open source code. You can also connect SourceGraph to several code hosts, GitHub, GitLab, AWS code commits, and SourceGraph can help you index all of that code, and then you can just search through all the code to get you more, get more out of the code base, basically. So just a little introduction about me. I'm Nigerian. currently right now in San Francisco. Today is also October 1, which is Nigeria's Independence Day. So that's also fun. And then I co-founded a company called Eden. There's a startup in Lagos. And also right now a developer advocate at SourceGraph. I run several communities in Nigeria. I run the 4Loop Africa, which is like the largest developer community right now in Africa. So that's just a little about me. So let's delve into SourceGraph. So the agenda for today, I'm just going to go to run through code search, SourceGraph, explore SourceGraph via the demo that I have for you guys, and then also tell you more resources that you can use to know more about SourceGraph and code search. So very interesting intro. I mean, code search is something that we all do. There's nothing crazy about code search, right? If you have written code before, or you've opened an IDE before, whether on Sublime or VS Code, or even if you use Emacs, you have done some sort of code search before, right? You use your local search to search for code, right? And that's great, that's awesome. However, if you notice, you can do this mostly for your just one repo, or maybe you have a bunch of repos that you have cloned from GitHub, and then you have to now search through it. You have to clone it first, right? You can do all of this, on your local machine. Now, we have other tools that people use for code search, right? People use SourceGraph, OpenGrok, LiveGrep, grep, even GitHub code search to search for code on GitHub. Other alternatives are Hound and Kite, right? But today, I'll just delve into SourceGraph, basically. So I like to call SourceGraph the Google for code, right? The Google for code search. So when you look at Google, when you look at the way people use Google, most of the things you want to know about, you just Google it. You put something in Google and then it brings out the search results for you. What if you had something like that for code search, for code? I know we have Stack Overflow, right? You Google something as a developer, you open Stack Overflow, you go through different, words and, code samples of what people have written, right? With SourceGraph, you can delve straight into your code base, or you can take a piece of code, whether a function or just the name of a function or the name of a class, or even a line of code, and dump into the SourceGraph, or even your error messages. You can take your error messages, dump it into the search box, and then it goes ahead to search multiple repos for occurrences of that code, right? Now, the exciting thing about SourceGraph, which I'm going to talk about, is with SourceGraph right now, you can search over 2.1 million open source repositories across GitHub and GitLab, right? If you've tried to use GitHub Search before, GitHub Search is limiting in the way you can get data out of it, right? With SourceGraph indexes some of those repos on GitHub and GitLab. Right now, it indexes repos over 5 stars, right? But the goal is by the end of the year, it's going to start indexing repos with over 1 star on GitHub and GitLab, right? By then, we'll have over 5 million repositories indexed by SourceGraph. With that, you can search tons of open source repositories across GitHub, right? The mission of SourceGraph is to be able to index the entire open source ecosystem, right? So that every bit of code that is open source, you can get access to that code easily via the SourceGraph search engine. With SourceGraph also, you can search your private code. It's not just for public code, right? You can connect your private code to SourceGraph and then be able to search for it. Now, this is very useful for open source maintainers, that go ahead to do paid versions of their product. This is also good for companies, organizations. You have tons of repositories within your code host or within your GitHub repo, or you have large mono repos. You can connect that to SourceGraph, and then SourceGraph provides a very lovely intelligent search interface for you to be able to search all of your code. It also provides precise code intelligence, the same way you have in your local IDE. And then SourceGraph has the ability to automate large-scale code changes. There's a feature called batch changes. With that feature, with a configuration file, instead of opening pull requests, for example, if you have some repos that have maybe you have a design system, for example, or you have a shared system that occurs across different repos. You have a file where you need to change something across different repos. Instead of having to open a pull request for each of those different repos, SourceGraph allows you with batch changes to be able to do all of that at once, and it automatically takes care of that, right? SourceGraph also provides code monitoring, right? You can tell SourceGraph to monitor a particular part of your code and send you notifications when something happens to that part of the code. So for example, when you have several people contributing to a code base, and there is maybe a core part of the code base you really want to know when things are happening or how, it's going to change over time, Sourcegraph can help you monitor that part of the code base and give you regular updates and notification on how, people are contributing to that part of the code base. And then we have a new feature that is still in beta, Code Insights. With Code Insights, you can have graphical interface that shows you how, different parts of your code base, with the authors and also languages, the language, the functions, the classes, how it has changed over time. And you can really, extract insights from how people spend time on different parts of the code base and what people are using in that code base. And this is awesome and great for large code bases to understand what's going on, right? So these are just Sourcegraph features. I'm going to tell you why you actually need Sourcegraph, right? So let's start with developer velocity. Most times, like somebody said in one of the talks, you don't get to start code from scratch. You get to join a team with an existing code base. Most times when you join a company with a lot of code, a company that serves a lot of customers, you discover that they have tons of repositories of code, right? Now, most times when you join a company, you probably have a documentation where you have to go through to understand how the code works. Or most times you have to jump on calls severally with different engineers. Like if you come across a part of the code that you don't understand, you have to call a developer or a senior developer and say, hey, can you jump on a call with me? Can you explain what happened here? I don't understand what this function does. With Sourcegraph, Sourcegraph can allow your developers to move fast and search for code. You can with Sourcegraph, it can onboard new developers to your code base easily, because all you need to do is show them your Sourcegraph instance. Your Sourcegraph is already connected to all your code bases. So as they are going through the code, they can just search. They can literally just search for anything, find references to the code, and also find precise code intelligence on that code base. Don't worry, I'm going to walk you through all these things I'm saying, and you're going to get a clearer picture of how these things work. But I just wanted to give you a rough overview of why you need Sourcegraph. I've also talked about code-based refactoring, right? Now, when you have large, repositories of code base with Sourcegraph, it allows your, developers to move fast because they can easily search for anything, and then those results will come out. And it also helps them when they are refactoring, right? When you are refactoring, most times you are, you're dependent on the test. You're trying to see, do we have other occurrences where, this particular function is used, or where this particular module is used, or where this particular class is used. I want to make changes to all of these files. So when you search for them, you can easily see. Sometimes you don't even know, because the code base is so large, you don't know the full name of the functions, right? You don't know the name of the classes. You have a faint idea of the name of the class, or you have a faint idea of the name of the function, or some of the arguments of the function. With Sourcegraph can allow you, even with the faintest idea of what you have, it can allow you extract that information and just bring out accurate query results of where each of these things exists in your code base, right? So this is these are the reasons why you need Sourcegraph. So let's start with literal search. I'm just going to give you a rough overview of some of the search we have in Sourcegraph. So there are three major types of search, right? You have the literal search, you have the regular expression search, and you also have the structural search, right? With literal search, you can literally just dump what you need to search for, as you have in the example here, full bar, you can just dump it there, and then it's going to go ahead and search for occurrences of what you dumped there, right? With regular expression, I mean, many of us use regular expression in code, maybe not every day, but you must have come across, a part of the function, a part of your code base where regular expression is used, right? A lot, right? And for some of you that might not know, you might just, you can just Google regular expression. There are different websites that shows you how, to come up, use regular expressions or ramp up with regular expression, right? So if you have that knowledge of regular expression on Sourcegraph, you can literally just toggle a button, type in the regular expression, and regular expression can help you to search for information faster, especially when you want to combine searching for one or more files or one or more code structure or code syntax in your code. You can always use regular expression for that. And then, sorry, just okay. So this is how Sourcegraph works. Like when you put within the search engine, within the search engine box, there are different keywords that you can use for your search, right? You can use when you type on repo, it brings out a drop down where you can actually have, it suggests some of the repos that you already connected or some of the open source repos that you're trying to search through. So just autocomplete to help you, search faster and better. So you can look at some of the things we have here. We have type symbol, we have the file path, you have the type commit or diff, and you have the lang. I'll just explain this in, briefly before we go to the demo. So when you look at lang here, this is a search right now. I'm starting from what we have at the last image here, right? This is searching through the source graph repository, but searching through a particular release, right? This is version 3.24.1. It's going to search for an occurrence of foo within that release, right? And then because source graph has tons of repos, it's going to limit it. This lang go means I'm trying to search for the occurrence of foo, but I want you to only limit it to Go repositories, to Go code, right? So if you are searching, for example, all of source graph organization, and source graph uses Go a lot, but source graph also uses JavaScript. Now, if source graph was to use PHP or Scala or any of that within that organization, you can type for what you're trying to search for, and then limit it and say lang colon PHP or lang colon Python, and it's going to limit your search result, narrow the search results to Python occurrences or PHP occurrences, right? You can also search within a commit. Okay, so we have when Lisa was giving the talk about Git, when you commit, you put why you're working on a particular feature. So you can search via people's commits, right? Okay, I want to search for all occurrences of foo within people's commits for the past week, right? You can also specify a timestamp, and you can specify type commit. When you specify a type commit, to go ahead and search for changes of code within commits, right? It's going to narrow it to commits, like what changed within this commit, what's changed within that commit. This occurrence of foo exists in this commit. Also, you can just specify a file path to search. For example, what we have here is going to search within the client directory in the source graph organization. So you are narrowing the search to say, hey, search for the occurrence of foo within the client directory within the source graph organization for this particular release. So you can see how you can narrow down your search, not just a wildcard search. You can do a wildcard search, right? But sometimes you just want accurate information very fast. Like I know where this thing is. I just can't remember where it exists. We have tons of files within this directory, but I want to be able to see where this is at the moment. So for type symbol is straightforward, right? When you search for a method or a function, it returns the results with a lot of definitions and where those functions are called. With type symbol, it limits the search results to show you just the function definition or the class definition or the module definition, right? You want to save yourself so many clicks of going to find the definition, right? With type symbol, just say, hey, search for the symbols of foo. So this is going to return results of maybe the class definition or the function definition, foo, or the module definition, and you can literally see it just return in the result. Don't worry, we're going to go through some of this in the demo if you're not really clear about how it works right now. So one of the things I also wanted to talk about, in your IDEs, sometimes you hover on your function or you click on it, and you can see documentation of how that particular function works, right? So with source graph also provides you with code intelligence. When you hover, you can see precise code intelligence, and you can find references and also, go to the definition. All right, so demo time. So if you are listening to this talk with me, I would like you to go to sourcegraph.com. Sourcegraph.com is the cloud version of Sourcegraph, but we also have a self-hosted version of Sourcegraph, right? If you go to about.sourcegraph.com, you will see instructions for how you can, download the Docker version and just install it yourself and set it up yourself. But for those that cannot set it up themselves or don't want to go through the hassle, you can go to sourcegraph.com and do everything I've just talked about, right? So let's go to the fun stuff. Here we are on sourcegraph.com. Now, I'm just going to show you how to search. One of my favorite searches is, I'm a developer. I'm in this hackathon, right? I need to search for how certain functions are used, right? Because Sourcegraph already indexed over 2 million repositories, I can come here and say, hey, I'm trying to use the clipboard, function, the clipboard browser web API, but I really don't know how to use it. Or I've gone to the documentation and I can't see, so many examples of how to use it. So I can come here and just do navigator.clipboard.say read text. Now, like I said, I'm going to narrow this to JavaScript, and I'm going to search enter. Now you can see the search results that it's returning right now, right? You can see all the different examples of, clipboard read text. Now, this is searching for examples of this particular API in the wild. So you can see different repos. You can see how Facebook used it here. And like one of my colleagues will say, Samson will say, when you're looking for vetted code in production, use SourceGraph, right? So this is not, giving you tons of doc to go through. It's just going straight to the code base. Like, how is this implemented, right? So if I click on one of these, for example, I can click on this rocket chart and I can see, oh, so this is the way we use clipboard or read text, right? And I can copy this block of code and I just go ahead and, use it in the hackathon project I'm working on, right? So if I go back right now, even without a read text, I want to see what are the functions that navigate the clipboard, gives me. If I click on that, you can see how people are, oh, now I know that there's a write text. Oh, okay, so I can use write text. And this is the way somebody uses it in React, like, in the React package. In 3JS, I can see how this is being written. If I click on this here, it's going to open the code base and I can see that, like, oh, okay, so this is the way it is used. And I can go up and I can see how people are actually using this, right? So I'm going to, that's literal search I just did. Now, let's go to how you can use this for regular expression. So I know that we can use read file sync in JavaScript or in Node, but I want to see how other people are using read file sync in the wild, okay? But then I also know that there is write file sync, right? If you've read from files before, you know that we have this. Okay, so now this is just going to return read file sync. If I come here and do write, I do lang JavaScript. Okay. But with regular expression, I can say, instead of doing this one after the other, why can't we do something like this? I want you to return to me the occurrences of both. All right, no results. That's because I did not click on this. So there's a toggle here. I'm going to enable that and it's going to search. Wow, that was very fast. So you can see read file sync. If I scroll down, I'm going to see write file sync. So it's returning both results to me because I decided to use a regular expression, right? So you can take advantage of regular expression to limit your search results and then I can look at these. Just looking at this, I can go ahead, enter each of these and then, see how it's being used and all of that. So I can decide to search for anything. For example, in Python, I know there's a lambda function. I rarely use Python, but I need to use Python in this hackathon that is, is going to happen very soon. So I can say, how is lambda function used in Python? Okay, so that's returned a lot of results for me. And then I can see how many people are using, this, right? So that is for regular expression. Now, what if I want to do a structural search, which is the third type of search I'm going to show you? So let's come here. So with structural search allows you to search like, blocks of code, right? For example, you want to see how try and catch is used somewhere, or you want to see, you know the name of a function, but you're not so sure how, the arguments. So you want to return, the usage of a particular function. So I'm going to go ahead and search within an organization. Like Linux is a very large code base. So I'm going to say, let's search for this in Linux. There's a function called fprintf, for example. And fprintf has several arguments, right? I can only remember the first argument to be stdrr, but I can't remember the rest. So I'm just going to do a 3 dot here, come here and toggle on this, and it's going to search for all occurrences of fprintf, right? That starts with an stdr argument. Now, can you see that? So it's highlighting the results. Every result here has fprintf that starts with stdrr, right? And ... is a placeholder. It says just as long as it starts with stdrr, return all functions to me that has every other function after stdrr. So you can see that. Now we can go further and say, okay, I know I want you to return all functions that have this. I don't care about the first, the argument that comes before or the argument that comes after. I just want you to return the functions that has this in the middle. So I'm just going to go click on enter, and then voila, you can see the results, right? I can now see all occurrences of fprintf that has this as the middle argument. This is what structural search is good for, right? I can take an if else and paste it in here, and it's going to search within the Linux repository for all occurrences of that if else. And I'm going to get all these samples, right? I know my time is running out, but I just want to quickly show you something. So let's search for the NASA API, for example. In the NASA API, if you open the NASA API, I can click on Browse APIs, and I can see that we have these APOD. This returns, what does this return? What does this return? This returns the date of an APOD image. But I can do something. I can copy this URL and say, oh, this documentation might not be very great enough for me to use. So let me copy this and see how people are using the NASA API in the world. Okay, this is wrong. So let me do this. I hope it's going to copy and then come here and paste. All right. So if I paste that, okay, I'm just going to remove the structural search. Good. If I paste that, now you can see how people are using the planetary NASA API, right? This is very, very interesting. So if you come here, you can see how different people are using it. So I can come here, open this, and see how people are using it here. I can also restrict it and say, you know what? I'm using Java for this hackathon. So restrict the results to Java. Voila, you have a lot of results here. Okay, so we can go through here and see how people are actually using this API. Now, let's look for something else. Insights. So we have the weather service insights. So I'm just going to copy these. Even without the HTTPS, I'm going to come here, I'm going to dump it here and say, restrict the results to say PHP. Let's see how people are using this in PHP. Okay, no results. Let's see how people are using this in Java. No results. All right, I'm just going to do something here. Let's see. Okay, so let's see how to search within, say, an organization like Cloudinary, for example. So Cloudinary is a service that is used for images, right? I know that there's upload, right? But I don't know what upload does. I don't know the particular method. Or I can even open the Cloudinary documentation and say, this is the upload API reference. This is the method. Okay, so we have this method in Ruby, in PHP, because I'm developing an app that we need to, upload images and, for this hackathon that we're trying to do. So I can copy this and say, you know what? Let me copy this, paste it here. Now, this is going to search within the Cloudinary organization, right? And then it's going to show me how this is used, but I don't want it to search within it. I just want to see results in the wild, right, of how people are using this method. Okay, so see how people are using it here. In the bounty source, you can see how people are using the Cloudinary upload method with the different arguments. And then I can now go ahead and look at this, copy this, and then just paste in my code base, right? Because this gives me all the ways people are using it, right? I can even go to the symbols. The symbols are all the methods that we have here, all the constants. I can come here, I can go to the definition, I can search, I can find references of how it is being used. And there's so many other things you can do, right? So there's like, the search is crazy. There's so many things you can do with SourceGraph, right? From literal search to structural search to regular expression. All right, I've just shown you how to do some, as you're using the NASA API or probably using Cloudinary API, or there's just a particular method you've been trying to use, right? For example, I'm trying to use the Twitter API. Maybe I want to use the version 2. I just want to see how people are using this because I'm not getting enough results. So I'm just going to do, let's just do this. So I can come here, I see how people are using it. And then I can see this, there are so many results this can bring out for me, right? And yeah, so that's just a walkthrough of how you can use SourceGraph, right? Just in the next 2 minutes, I know my time is almost over. I just want to show you how you can also add your private repositories. So I'm going to log into SourceGraph via my GitHub repository. I can, I create an account. I have a GitHub account here that I've created, I linked my SourceGraph, my GitHub account to SourceGraph. So I come here, I can go to repositories. Here, when I click on manage repositories, right? Let me check my code host, right? So I'm already connected to GitHub. I can also connect to GitLab if I want to. So now that I'm connected to GitHub, I can go to my repositories. I can come here and say, okay, now this is returning all the repos I have here, right? I want to add the Hackathon NASA repo that I created, all right? So take these two repositories. I want SourceGraph to have access to these repositories so I can search through it. So now it's syncing it, and then now it's showing that it has connected these repos, right? So I can come back here. Now you have this context global. Now, because I've connected my repositories, instead of using context global, I can click on these and click on Unicode developer, because these are all the repos I've added, right? And I click on these. So when I click on these, what SourceGraph is going to do is anything I put into this search box is going to limit the search results to the private repositories that I've added to SourceGraph, right? So I remember I can search for something like get all attendees. And you can see it's already suggesting the function for me, right? And I click on that. I click enter, it's going to return this. So in the Hackathon controller, we have a get all attendees function, and I can see that here with SourceGraph. SourceGraph enables me to easily search for that, right? And I know I can search for odd zero. Okay. I know let's see if we added that. Just go to settings, go to repositories. Oh, okay, I didn't add that. So let me just try to add one more repository. I call it, there is a store zero demo I have that uses odd zero for authentication. So I'm just going to search for that. I'm going to add that here. Click on save. All right, so we have that here. So I'm going to come back here and just search for something. Okay, good. So if we come here, now we can navigate this repository easily. Good thing about SourceGraph too is you can easily see, the contributors here. You can come here, click on the commit. There's so many things you could just do here from SourceGraph, right? And yeah, I know my time is fast spent, so I'm just going to come back here and say, we have so many other resources that you can use to learn about code search and SourceGraph. So if you go to the learn.sourcegraph.com, there are so many articles here. On the docs.sourcegraph.com too, we have tons of articles here that you can use to learn code search and learn SourceGraph also. Also, we write on DevTool. If you go to DevTool, we have some resources there, and we write and publish an article every week. Also, if you go to our blog, we write tons of interesting articles that will teach you how to learn how to code or how to code better or manage engineers. Also, we have DevTool time. With DevTool time happens every 2 weeks. I think now it's going to happen once a month, where we invite people to talk about how they set up their desktop, how they set up their workspaces, and it's very interesting. You can just go to our YouTube channel and you can see so many episodes that we've recorded. We also do podcasts, with different, senior engineering leaders and authors of frameworks. And you can find all resources about how to code better, how to manage people with code, how to manage people that code, also how to, just come up with fantastic frameworks, thought process around like how engineering leaders, do stuff. And yeah, so that's it for now. You can contact me on Twitter. I'm very active on Twitter, Unicode Developer. You can also, search for me on GitHub at Unicode Developer. I'm also very active on GitHub. And you can ask me any questions that you want to ask me there on Twitter, or just find a way to, contribute to some of the repos I have on GitHub. And I think that's all for now. I hope you guys enjoyed this workshop, and I hope you use SourceGraph. And thank you very much.
Thank you so much, Prosper. That was a really interesting workshop. I definitely can see myself using this in the future, especially with some work-related things. Looking in code is not my favorite thing to do. So I can definitely see this being a very valuable tool for both myself and our participants. So we'll make sure that we have this video available for them tomorrow and throughout the weekend. So thank you so much for taking the time out of your day, and happy Independence Day.
Thank you. Thank you very much. Thank you very much, Katelyn.
Amazing. Well, all right, everyone. So we now have a scheduled break just for a half hour. We will be returning at 6 p.m. Eastern Standard Time. So that is a little over 20 minutes from now. So I will put on some music. Everyone get a glass of water. Everyone have something to eat, and we will be back with our evening sessions. There's a lot to look forward to, so please join us back here in about 20 minutes.
I guess I have to leave our Zoom. No. That's okay. That's what I went to, I think. So.
Stop screen sharing for a sec. Need a little bit more power to get there.
Yeah, I'm gonna. Okay, but I don't want to stop my screen share, or should I?
Carter.
You want to leave mine and go there.
Great. Okay. Thanks. Okay, will do.
You're fine.
Okay. All right. Hello. Hi, Katelyn.
Hi, how are you?
Good. How are you?
Good. It's great to have you here. We're very excited for your talk today.
Well, likewise. I've been looking forward to it.
Yeah, so Carter is joining us from, oh, sorry. I'm just trying to open things here all at once. Carter is joining us here from Open Space. Open Space is one of our official sponsors. So thank you, Carter and team. We're very appreciative. That is actually the reason why all of you guys who are actually on the webinar and are using our Zoom links over the weekend, the Open Space was kind enough to let us use their Zoom accounts for this weekend. So amongst other things, and we're very fortunate to have Carter here today to talk to us about using the powers of 10 to understand the scale of the universe. And with that, Carter, I will turn it over to you.
Well, thanks, Katelyn. I'll start sharing in just a second, but I did want to mention as a sort of preamble what Open Space is. If you're interested in checking it out, you can go to our website, openspaceproject.com. And what Open Space is a data visualization engine. It's open source, NASA supported. It's an international collaboration, really, with Sweden's Linköping University, the University of Utah's Scientific Computing and Imaging Institute, perhaps the world's largest data visualization research facility there, and also New York University, so NYU's Tandon School of Engineering. And so we have about a dozen developers, and the NASA funding has enabled us to develop this. This stems from work done at the American Museum of Natural History, from the rebuilding of the Hayden Planetarium, a place where I grew up and started taking classes when I was about 10 years old. It was quite life fulfilling to sort of come back and work with the team, very talented team, to put together the notion of actually what a planetarium could be in the 21st century, to go from stars on the ceiling to a data visualization across the universe. So without further ado, I'm going to share screen and we're going to jump into this. And so I'm just going to ask if you can all see this.
Looks good to me.
Okay, great. What we see here is the Museum of Natural History, and I'm zooming in on top of the Rose Center. Underneath the ceiling, of course, is the big white ball. And you see some half arcs here. Well, this is I'll just show you that on top of the Rose Center, there are 4 air ducts. But we have basically this notion we're going to be exploring is the universe in steps of each step 10 times bigger than the last. What we see here is a radius of 1 meter. So across here is 2 meters. And then, so if this is 1 meter, this is 10 meters. So this is 20 meters. And this is not quite the size of the Rose Center sphere underneath. The Rose Center sphere is 90 feet, or about 30 meters across. And so we're going to pull back now, and we see the Greater Museum of Natural History. It's a complex of buildings.
It was started in 1869, the same year that the Transcontinental Railway was completed, Promontory, Utah, and they drove in the Golden Spike. And 100 years later, we were bringing rocks back from the moon with Apollo 11. So we're now seeing a radius out to 100 meters. So this is about a football field across here. We see the greater property of the American Museum of Natural History. This is 81st Street, and down here is 77th Street. So let's pull back now, and we see the greater Central Park. And if we take our distance scale 10 times farther from 100 meters out here to 1 kilometer or 1,000 meters. And so this takes us over to Riverside Drive and or the other direction, just out past our sister museum out there, the Metropolitan. So let's go further. And as we do, I'm going to just give you this sort of aerial perspective that we see the Hudson River and the East River, the island of Manhattan, Central Park once again, the Great Pond. And so now if this is, this is 1,000 meters out here, or 1 kilometer, we're now talking 10 kilometers out to here. We're reaching on out toward, into New Jersey. This is Teterboro Airport down here, if you can see my cursor. And then reaching on out into into Queens and past LaGuardia Airport. So 10 kilometers. At this point, I'm going to tip over, and we're going to see the atmosphere of Earth. We also see some stars. We're just going to leave the stars up. Visibility, of course, you wouldn't see that during the daytime. But these arcs are tipped over, and you're going to kind of see why in just a bit. But if this is 10 kilometers, I'm going to draw your attention for a second to how the atmosphere is already starting to thin out. Typically, when we fly in airliners, we go up about 30,000 feet, maybe it's about 10 kilometers. So this is 10 kilometers here. It's angled over, of course, but about here is where airliners fly. And interestingly enough, however, about 30 kilometers, 40 kilometers is where the atmosphere basically fades to black. And this is equivalent to 20 miles, if you want to think in terms of miles. The island of Manhattan itself is about 17 miles long. So if you took Manhattan and stood it on Battery Park down here, the tip of Manhattan Spite and Dival would stick out just about to the edge of the atmosphere. That's how thin this atmosphere is on Earth. The late astronomer Carl Sagan used to like to mention that the entire biosphere, as we know, if you also include the depths of the ocean and so forth, and into the lower troposphere part of the atmosphere, is about as thin as a skin on an apple. So now we can see Long Island, and we're going out farther to 100 kilometers. This takes us out to, it's maybe a little hard to see, but the Delaware River. So we're already hitting into Pennsylvania here. And so I'll just continue our journey on out. And as we go, we see an orbit here, several lines. I'm going to tip this over. And so we're doing this to where basically these hoops centered on New York are parallel to our equator or equatorial plane. And so it sort of makes sense for where we are and move out and bring the United States up here. As we can see before the clouds kind of fade up, they're going to fade up in a second. We can see the Great Lakes. This is Chicago out here. You got Cleveland, and about 1,000 kilometers from New York, not quite to Chicago, is South Bend, Indiana. If anybody's from South Bend, we can clearly see in this nice high resolution map that's shared with us from Esri, the world's largest geographical information systems company. We can see the continental shelf, and then it gets darker blue as it gets deeper. So as we come out, we see an orbit, and this is the orbit of the International Space Station. Orbit's 400 kilometers up. So if we look at our scale here, if this is 1,000 kilometers, half that distance is about the distance off the Earth that the astronauts on the and cosmonauts on board the International Space Station. 11 countries make up that space station. and they're orbiting really just above, where the atmosphere continues off in, it goes black in about 30 kilometers, but it continues exponentially decaying. That's why we put the satellites higher than that. And what would the astronauts see? Well, they see the Earth, of course, with the clouds. We're looking at the clouds of yesterday. In fact, I think this is Hurricane Sam, if I got the name right, out there in the ocean. We're now looking at data from NASA's Global Imagery Browse Service. This comes from NASA Goddard outside of, in Greenbelt, Maryland, outside of Washington, D.C. And they process images from various satellites. This one is from a satellite that's cooperated by NASA as well as the National Oceanic and Atmospheric Administration. And they have a series of satellites, really, and that this service actually has hundreds of layers that are gathered every day in various wave bands. And we've chosen something here called true color, and we've added that atmosphere in as an effect. It's a true Rayleigh and Mies scattering atmosphere, so that we can show the Earth with the imagery, but with the beauty of the atmosphere as the astronauts see it. Well, I've gone out to we were looking at 1,000 kilometers out to South Bend. Now we're out to 10,000 kilometers in radius. The Earth is 12,700 and change in diameter, so we can see here, just in this radius, it's on the order of not quite as large as the Earth itself. And so when we get out to this perspective, we like to turn on other satellites than just the ISS. And so I'm going to turn that on. And here we are showing just statically right now. I'm going to show this in motion in a second, but we see a ring of satellites out at about 22,000 miles and is about 40,000 kilometers. So once again, if this is 10,000 kilometers out, 20,000 kilometers, and you take two of those from the center of the Earth, about 40,000, it's about 42,000 miles out to the geosynchronous orbit. What's special about that orbit is that the rotation period of the satellite is 24 hours. And so parked over the equator, these are great for communications and so forth. In fact, the great science and science fiction writer Arthur C. Clarke envisioned this in a paper he wrote in a radio journal in England in 1945 at the end of World War II. So what I'm going to do now is I'm going to set this up, and I'm just going to get rid of the powers of 10 rings, just steps of 10 once again. So I'm going to turn those off because I wanted to show, we've seen, okay, we're out here with the satellites right now, and we think of space as empty. Well, here we are filled with lots of satellites, but I wanted to show you, just give you a window on some additional stuff here. And so let me just, let me set this up for us. And I'm just going to change time a little bit. And let's do this and set this up. And now we're going to, I'm going to go into that time lapse I talked about. If you're closer into Earth, the satellites go around a lot faster. They go around in an hour and a half. So now we're going to start time. And we can see the satellites in close buzzing around. And just what turned on now is the Earth's magnetosphere. This is a data visualization, a dynamic simulation based on actual satellite observations of a particular event when we were being hit by coronal mass ejections in July of 2012. I'm going to turn the powers of 10 rings back on now. And so we went from 10,000 to 100,000 kilometers now, and it's about 40,000 kilometers out to the geosynchronous ring. And we can see that the magnetic field of Earth, you know, it's kind of like a bar magnet. We see it sort of just sort of spin around this for a second. And so it pinches in at the magnetic poles, but it doesn't exist alone. It's actually it reacts to the greater magnetic field of the solar system caused by the sun. And so the heliomagnetic field. And but here we see Earth, and then these purple streamers are basically the solar wind, and they come in and they're diverted around the magnetic field. And the geosynchronous ring goes out about 1/10 the distance to lunar orbit. So if I come out far enough, we're going to see lunar orbit as well. Let me just come in, and we're not seeing it just yet. So let me turn on some orbits, more lines, and it gets confusing. So what I'm going to do is once again just turn off the powers of 10 rings, so that these are trails essentially through space that the Earth is tracing. This is where it was, and this is where it's going. And down here we see a trail, just like we saw trails with the satellites. This is the trail for the moon, and we see the moon is about 10 times that distance, about 250,000 miles, or 300,000 kilometers. So 300,000, that's the time I'm going to turn back the rings for us. This is 100,000, about 300,000 out to the moon. And so if we move out further 100,000, now we're about 1,000,000 kilometers out. We see that this really sort of contains our magnetic environment and its reaction to the solar field. In fact, what's twirling around here like a propeller in red is actually the local solar magnetic field. Well, we have that visualized as well as I pull back. And once again, I'm just going to turn off the powers of 10 for a second, so that we're looking out. We're now seeing orbits of Venus, and then Mercury, Mercury being closest to the sun. And I'm now going to turn on the magnetic field of the sun at this period of July of activity. There were 4 coronal mass ejections, or solar flares. And so what we're seeing is a simulation, once again, that's been informed by the data collection from satellites of the flux of the solar wind and the shape of the magnetic field as basically inferred from various observations. And so I'm going to run time a little faster. We saw Earth, there was a time scale to that, and we're now going to look. This bright line comes out, that's the connection with the Earth. And now we're seeing these activity on the sun. And also we see that there's a spiral nature. That's because the sun is rotating. And so this sort of octopus of field lines that come out from the sun emanate from a very active sun. I'll come up to the sun in a second, but you can see that this spirals because the sun is rotating. And that's really the highway, if you will, for the charged particles coming out from the sun. Mentioning the sun, I'm just going to focus on the sun for a second so that we see that. And just clear my display. I decided to actually kind of leave this up with my menus and so forth. You can see a little bit of the business end of open space. If I come in close, this is a model and then there's a kind of vacant area between this model and the one you saw. Suffice to say, there are other models that connect these, but this is based on images gathered of the sun, and we can reconstruct essentially the magnetic field of the sun and then the events that occur. And NASA does this as a space weather monitoring exercise, so that we can manage if there are any explosive events that might affect satellites that are out there, and could affect a large enough blast could affect the Earth, and so that we monitor that. So let's go out now. We're seeing the inner solar system. I'm going to turn the magnetic field off, and so that we're just looking at the inner solar system. Going to turn the powers of 10 back on, and we've now gone out from like 1,000,000 kilometers out to we're now out to 100 million kilometers, and we're not even to the sun. The sun is 150 million kilometers away. And it's so far away that it takes light about 8 minutes to go from the sun to the Earth. And as I pull back farther, we can see the orbits of Mercury, Venus, Earth, and then Mars. And then there's a tremendous gulf out to Jupiter. And at this point, it's kind of worth talking in distances that we're getting upwards of. This is 100 million kilometers. This out here is about 1 billion kilometers now, and we're getting out sort of beyond Jupiter. And this is the realm of the asteroid belt. If I'll just bring up this and show you the inner and outer asteroids here. And also I can show you the Jupiter Trojans. And just call your attention to this. They sit at a sort of gravitational balance point called Lagrangian points. They kind of look like bunny ears in the way, or bear's ears on this right here. But it's a balance between Jupiter and the Sun. So Lagrangians 4 and 5. And this becomes a sort of gravitational well. I mention this because the Lucy mission is about to go explore several of these. It's launching in October, so this month. And so stay tuned on that. So the inner solar system has many. In fact, the main belt, if I brought that up, it would bring this to its knees. So I'm not going to do that. But as we move farther out, Jupiter is about 5 times the distance of the Earth. We're going out further. And now we can see this containment out here of the solar system. We are looking all the way out to Neptune. Of course, some of us may like Pluto. I was raised with Pluto being a planet, of course, got demoted to minor status or dwarf planet status. But we came to understand that this is really a realm out here of a sort of icy asteroid belt. Here I'll show you the data for the trans-Neptunian Kuiper belt objects. So if this is the orbit of Neptune right about in here, we're now seeing essentially that the solar system is contained within this distance out here. And notice I've left this display up here in the upper left, and it now says about 0.7 light days. So in fact, Pluto takes light about 4 hours to go from the sun to it. But right now we're way beyond Pluto, but I want to come up to this distance range. When I do, we can see we are about 10 light hours away from the sun. So it's about this a radius across here of about 20 or about almost 20 hours, almost 1 light day. And so my point here is that this Kuiper belt and so forth, the containment of the solar system would fit within the light travel time of like 1 day. That's 1 light day. Behind us, we can see stars. And what we see is this bright star over here is Alpha Centauri, and it's 4 light years away. So if we go from here farther out, we're now about 5 light days away. These lines we see here are comets, or perhaps the farthest emissaries of our solar system coming in from a realm, a cloud of icy particles in the very distant outer solar system, which we call the Oort cloud. And it's really kind of theory, if not, but we see it's based on these objects that are still bound by the sun's gravity, but are all the way out here. So once again, paying attention to our distance out here, we're going to go another step, 10 times that distance, and we're coming out to about a light month. And now we're coming out 10 times that. We're now out at 1 light year. And so this ring right here, if I come in closer just above it, is on the order of about a light year. This is going to be useful for us. What I'd like to do now is, if I move around, I see one star out here, Alpha Centauri, is already starting to move. So what I'm going to do is I'm going to bring up our celestial coordinate system. That's the graph you're seeing that's aligned to the Earth. So down here is the south celestial pole. Behind us is the north. Rigel Kentaurus is the official name for Alpha Centauri. And one thing that I also wanted to show before we get too far are that the solar system aligns with, we see the sun go across 12 constellations of the zodiac. So let me bring those up for us now. And we see them in red. And just to point out one of my favorites, I'm actually a Capricorn, but this, if any Scorpions are out there, and Scorpius, this is your constellation. and then Sagittarius over here. And it aligns beautifully. In fact, they sort of hover about where the center of the galaxy is. So let's move out even farther now. We were at about 1 light year at this ring here. And so now I'm going to pull out, and now we see Alpha Centauri coming in from the right. And it's about 4 light years away. It's about 4 1/3 light years away. And so this ring about 1 light year. Let's go 10 times that distance. As I do, you're starting to see other stars come out to play off the wallpaper, if you will. You can see the star Sirius about 8 light years away, the star Procyon 11 light years away. Altair, which is in the summer sky. It's the eye of Aquila the Eagle, and it's about 16 light years away. And then famous Vega, it's a very bright star, easy to see even from Manhattan on a summer night, and it's 20 light years away. So this distance being 10, or the diameter here being 20, about the distance out to Vega. Now, as I pull back, the constellations that we were seeing, of course, are dissolving into sort of 3D distances. In fact, the constellation Orion with its famous 3-star belt, we see it from a perspective if we put it behind the sun, and then the other constellations now deforming. And as I do, we can actually see the sphere actually sort of close off. And if we've been counting here, if that's 10 light years down here, this is 100 light years. This sphere is carefully sized to how far radio waves have traveled since the Earth became radio bright. And what I mean by that is that the Earth basically has been sending out radio signals strong enough to actually break through the ionosphere of Earth since the 1930s. So we're really talking the late 1930s, around the time of World War II, about 80 years ago. And so this basically is this containment of this radio history of Earth sort of moving out. And if we're out here, this is 100 light years distance. And with this, of course, we're out here amongst these stars, and we have the Milky Way band behind us. And then some of you may be wondering, how about discoveries like exoplanets? Let me bring some of that up for us. I'm now going to really complicate the picture here, but we can still see the radiosphere and the 100 light years band coming out here. All these blue circles are basically stars that we know of that are host to exoplanets. And in open space, you can actually go up and visit the different systems. I won't do that unless maybe I have time at the end, but there's a lot I always want to show. And also, if the blue circles, these are the dynamically discovered exoplanets, exoplanetary systems. But if I, once again, just like I did with Orion, if I line up this this patchwork of yellow behind the sun, that is the targeted area of the Kepler mission, just off of the constellation Cygnus the Swan, which is part of the Summer Triangle, and just a little bit off the band of the Milky Way. And so that mission was designed to just stare at one part of the sky and look for eclipsing effects of planets dimming their host stars' light. And so this really indicates that if we looked everywhere, we would just see more completeness like this. So this is an indicator that that most stars that we see are probably hosts to basically planets just like us. Now, remember I showed you Orion, and it was kind of it was blue, these blue constellation lines. You see these blue hexagons, are they hexagons? They're hexagons. But they map out actually stellar birth regions, and one of the nearest ones to us and most famous is the Orion Nebula. If I just turn off basically the map elements for a second, I'm going to come in here and we see the Orion Nebula. It's just sort of out in front of us. We have a 3D model of it in here that we built for production of our space shows. And we see this line out here, which is basically at 1,000 light years. The Orion Nebula is about 1,500 light years away from Earth. And even though we're out here amongst the stars, the band of the Milky Way is still pretty much, we're very much in the Milky Way. But if I bring these data sets back in, we also see yellow pentagons off on the right side of the screen. And they are indicative of areas around the center of the galaxy. We begin to go so far now that we're going to fade up the Milky Way galaxy that we now see, and that we've reached out from 1,000 light years to 10,000 light years in this ring here. And we now know from a lot of astronomical research pretty well how far away the center of the Milky Way is from us. And it's about 26,000 light years away from us. And so once again, this ring sort of allows us to see again, from steps of 10 times greater distance and so on, moving out, that we go from about 10,000 light years, let's go to 100,000. At this distance, we now see the full complement of our galaxy. In fact, we're going to see a lot more. And so at this distance, the radius of this is about 100,000 light years. Our galaxy is about 100,000 light years across, which means if you we're shining a flashlight from one side, you went to the other side to catch it, it would not traveling distance, it would take 100,000 years just to cross the galaxy. Well, okay, so the radius of this is 100,000 light years. Well, let's look at some of our neighbors. In the lower right, we can see now labeled SMC and LMC, those are the small and large Magellanic Clouds. So-called Magellanic because the first European observations of them were from the Magellan mission that first circumnavigated the world. From 1519, the one ship returned in 1521. They started out with 260 men and only 19 returned on one ship. They started off with 5 ships. Magellan didn't make it back. He was killed in the Philippines, got involved in local politics. Never a good thing to do. So if this is 100,000 light years out in this direction, let's go 10 farther out. This is 1,000,000 light years. And why not, since everything's becoming little dots, everything you're seeing is another galaxy like the Milky Way. Every galaxy like the Milky Way has literally hundreds of billions of stars. And if you look at the rate that we're finding exoplanets, easily 1 trillion planets in our Milky Way. Every one of these dots is like 1 trillion planets. This is 1,000,000 light years out to here, and about at twice that distance is the Andromeda Galaxy and some of its sister galaxies. This is what we call our local group of galaxies. So this is 2,000,000 light years, and we've come out. This is now I'm going to pull back, and we see now 10,000,000 light years. Now we're out at 10,000,000 light years. What's going on in the neighborhood around us? Well, there's a lot of stuff going on in the background. In fact, this grouping of galaxies out here, which is about 60 million light years away. So if I come out now, that was 10 million, and now this next circle out here is 100 million light years. About 60 million light years is this sort of nearest massive downtown. We're out in the intergalactic suburbs, just as we are in the galactic suburbs. We're not where the action is, and was probably a good thing. But out here, it's about 1,000 galaxies, and it aligns with the constellation that we call Virgo. So we call this the Virgo cluster. But this larger amalgam of galaxies out here, within 100 million light years distance, as we see here, is the Virgo supercluster. There are, in this area over here, there are twin galaxy clusters of Fornax. They align with the southern constellation Fornax. And so just opposite is Virgo. And so that we see all of this, and they're color coded now so that the hot colors, the sort of orange colors, are where there's a greater density. The aqua is where there's, these galaxies are sort of hanging out in essentially sort of void areas. Now, as I move out farther, this data set that surrounds us is good for about 300 million light years. But we're now gone beyond that. So that we were, once again, if I'll just come in here, if this is 100 million, we're now going to go out 10 times that. 1 billion light years. And we're now into the Sloan survey. Notice how it's sort of hourglass shaped. And the reason for that, if you will, if you allow me this just a second, I'm going to take a deep dive back to our Milky Way. We call it home. There it is. And as I come in, it's edge on. Our observations of the universe, we started out, we're looking from inside a galaxy. And we're looking out to these far distant galaxies that are really dim. And so we look out and our own stars are sort of in the way. And so we get a much clearer view looking one side or the other of the Milky Way galaxy. And that's why this data set is, we're lacking galaxies accounted for in these dark regions. This is just because we've avoided this area. We call this the zone of avoidance or the zone of obscuration by our Milky Way. And so if this is 1 billion light years, we're now going out to 10 billion light years. What are we seeing here? We're seeing various galaxy clusters. We're seeing voids. And so we're seeing a lumpy universe, but there are strands and sheets and voids. It's almost like a big bubbly froth. It almost looks like, like a sponge. It has this large scale structure to it. However, I've been talking about just that we're light years. And I even mentioned that the sun is so far away from us, it's 8 light minutes away. It's 8 minutes in the past. So if we go out far enough now and we're looking like a billion light years out, that and 10 billion light years here, is that we're really seeing things, 10 billion years ago. And so we'll step out even farther now to 10 billion light years, and we're out into the realm of these reddish objects. These are quasars. These are sort of the farthest objects that we can map, and they're from, basically this is light coming from a much younger universe, and we are, we can't help but just be in the middle of this picture, and we're mapping outward. If you were one of these quasars, you'd see us perhaps in the ancient ancient universe as like a baby picture. We're seeing baby pictures of galaxies out at this distance. I've come so far now that from here, from about 10 billion, and we'll step out even farther, we now see the stippled background. This is the cosmic microwave background. This is the echo from the formative event of the universe, the Big Bang. And this was mapped by the Planck satellite. And these are tiny, very minor variations in temperature, but we've mapped colder to blue, warmer to red. This background and its formation in the very early stages of the universe are called baryonic acoustic oscillations from this very highly energetic event. These are sort of quantum effects writ large as the universe expanded in the inflation theory, and that it carried these quantum vibrations out to what makes the universe lumpy on the largest scales that we can see. If I was to pull it out even farther, we would go beyond our horizon, which is kind of ridiculous, and this would be 100 billion light years. That astronomers calculate the distance that this represents, that we see on the order of some 40 to 50 billion light years. And so with this, we've put this whole picture together. I'm going to come back down now through this fairly quickly on back to 10 billion and then a billion, 100. I've gone, I wasn't counting, and I'm within the 100 million light years. We're coming back to 10 million light years, and within a million light years, once again, we're in our local group, and that we're going to come on home. So how are we doing for time? I'm not quite sure. We might want to take some questions. I've covered a lot of ground here. We've seen a lot, but open space allows us to put together these astronomical catalogs. This is all real data that we can contextualize from something we started off in Manhattan, and we've gone all the way out. So when we get in close like this, I usually like to turn off some of the background data sets. I'll do that. And let me I'll turn off the constellations connections, but I'm going to keep on some of the nearby stars. We'll just come in close. The scale of their font is based on perspective, so the bigger if we get closer. And now we'll come zooming back into the sun and back into the glare of our sun. Our outliers of the frozen vestiges of the early condensation of the solar nebula, and getting closer into our star, these Kuiper belt. In fact, now what I'll do, I'm in so close, I'll just bring this up and turn the Kuiper belt back off and come a little closer and come on home. So I also had prepared Mars if there was interest in seeing that. So out here, once again, this is about 100 million kilometers, and where Mars is in this representation in time, because I run this for our simulation in 2012, but we see here's Mars about 100 million kilometers, and the moon is once again 300,000 kilometers. So you get a sense of how far perhaps Mars is away from us. Let me target Mars. Let me do that, and we'll just target Mars. We'll come over to it, and next planet out. Beautiful place to observe. Oh boy, I still got time running here. I'm going to stop time and just come in. It was running pretty quick. Maybe that was what was slowing me down a little bit. However, let's see. We just come in here. Let's get rid of some of the solar system lines. I'm going to get rid for a moment. I'll get rid of the powers of 10 lines because that's all centered on Earth. Let's just enjoy Mars for a second. I'm going to turn off the background of all the rest of the stuff. And what we're seeing here now with Mars is Mars has an atmosphere. It's half the size of Earth. So this part of the quandary of Mars is that it's a sort of frozen desert world, has polar caps, has volcanoes that we see sort of as dark spots. They're sticking up through the atmosphere. And so we have the height map on as well. And so famously, Mars has the Valles Marineris, which stretches about the width of North America, about 3,000 miles across. By comparison, the Grand Canyon in Arizona would be like one of these small tributary canyons I can point out if I get close enough. Actually, these two over here are about the size of the Grand Canyon. This is a huge feature. If I just come up to it, it's about as the deepest part of it in around this area over here, Coprades Canyon. So they each have their different canyon names. The whole thing is Valles Marineris, named after the Mariner 9 spacecraft that discovered it. But it's about as deep as Mount Everest is tall. It's extraordinary. It's a giant fault, essentially. Mars bulged where the volcanoes were. We saw them over on the left as they're kind of coming into approach. And so we have this nice continuous map thanks to NASA's Viking mission, which was in the 1970s. But they, in its extended mission phase, it was able to get a nice total map of Mars. But if I come in close enough here, we get so close to where this map, which is about 100 meters per pixel, we can do a lot better than that. So allow me now to just, let's go to a map that from the Mars Reconnaissance Orbiter, which is even higher resolution. Now we're looking at essentially about 15 to 20 meters, or actually, I'm sorry, it's 5 to 7 meters in resolution. And so as we come into this part of the canyon, this is called Candor Chasma. This is Western Candor Chasma. And if you look at the cliffs, they're incised. We're coming down into the haze of the atmosphere. They're incised in volcanic plains. And so we can see actually volcanic layers. But on the floor of the canyon is very interesting, soft sulfurous sediments, sulfates. And so there's a debate whether this might have been a giant lake in the ancient past. or that these sulfurous sediments, sulfur coming out of the venting volcanoes, but after this canyon had stretched apart, that perhaps airfall coming in, building up soft sediments, then being worked on literally over billions of years at Mars to actually carve away at these sediments. And that carving is rather extraordinary. And I'm coming into a higher resolution patch, which is as good about 1 foot resolution, a 25 centimeter resolution. I have my high school students, I work with the Bergen County Academies, and they've done a number of maps in support of contextualizing these data. And we use a process from NASA Ames. It's called the NASA Ames Stereo Pipeline. It allows you to do photogrammetry, pretty sophisticated, with knowing from a lot of the data from the orbiter of exactly where it was, and using software called ISIS from US Geological Survey. But now we're down in these folded sediments, and they've been worked by the wind and eroded. And so the tallest of these hills are like skyscrapers in a sort of typical city. But that background canyon is on the order of about 7 kilometers in height, about 20,000 feet. And as I get close enough now down here, is that I can actually look at sand dunes that cut across. We'll see. So I'll point these out. These are sand dunes cutting across the exposed layers of rock, coming up to a nice little sand dune cluster here. And so on Earth, we call these, well, and on Mars too, geologically, these features are called yardangs because the winds coming down from the edge of the canyon literally over billions of years have carved this terrain. So with that, as we float over Mars, there's a lot that we could explore, a lot of these high resolution patches across Mars. We're gathering this data on the fly. This is coming in over the internet. I'm sitting here from Cape Cod, where I'm presenting actually right now. This all works, and hopefully it's been blasting out to you guys okay. So I thought I'll shut up and take any questions.
Awesome. Does anyone have any questions for Carter? We will check the live stream.
Great.
I'm not seeing any questions yet, but it is coming in very clearly, just to let you know.
Oh, good, good. I was afraid of that. And because there is sort of a lot in this particular presentation that I wanted to put in just to show you guys what open space can do. I was worried that, well, I was worried the worst that could happen is I crash and have to reload, but it's been pretty stable all day.
Yeah, it looks great. It looks like it is it just like pull around to move, like click and pull?
Yeah, actually, there's as far as the navigation goes, I have a 3-button mouse. So to navigate and turn left and right, this is my middle mouse, and then also I can pull the landscape toward me, and I have friction off, and so that we can glide. And then I can also, with my right mouse, sort of increase my altitude, or I can spin around before I go outside the nice high resolution area. And so I'll just I'll fly over this part of the canyon and maybe go to another high resolution area. Down here in Meliscasma, there's some very interesting erosional features indicative of liquid water across the surface in the ancient past.
So Carter, I have a quick question for you.
Sure.
Your background in terms of it comes from graphic design, is that right? You used to do animation and things like that?
Yes. I grew up in a family of artists. My father, Weston, was a commercial artist, but also a talented painter, and he also was a sculptor. He carved horses, I grew up just thinking everybody's parents probably did similar stuff, and so that was the environment I grew up in. But I was captivated. My dad was also a nature photographer, so we ended up at the Museum of Natural History a lot. And I ended up petitioning my parents to start taking classes at the planetarium when I was 10 years old. So I was captivated by astronomy, mainly because of the space program. I was 8 years old when we walked on the moon and witnessed that. And I really wanted to sort of go into science. I was sort of scared off from the mathematical side of physics and so on, and I settled into, fortunately, through a circuitous route of different things, perhaps after my time at the University of Colorado, but into data visualization. And so I worked at our National Center of Atmospheric Research in Boulder, Colorado, in data visualizing Earth system modeling. That kind of led to the opening of the Rose Center, that job became available, and again, working for the rebuilding of the planetarium, I couldn't think of a better place to be. I worked at NASA Ames Research Center there in Silicon Valley. What I did there was, when I was in college, a group of us, a number of graduate students that ended up landing at NASA Ames Research Center, that we had, when we were all in Boulder, we held a series of conferences called the Case for Mars. We held 6 of them, and the Mars Society grew out of that. So I ended up falling back on my sort of family tradition of drawing what the engineers were talking about. So that sort of technical illustration, and coupled with the love of trying to visualize this accurately and portray the entire universe, was always something I was fascinated by, and it sort of came together with the needs, with this goal at the American Museum of Natural History to try to sort of take on this challenge of what could we do in this digital age of rethinking what the planetarium might be able to do if we were to attempt to data visualize the knowledge that we've gained. So.
This is also fascinating to me, and I totally agree with you. In college, I was scared off by the mathematics part of engineering as well. I ended up going into classics, which I love, and I'm super happy that I did. But here I am as an engineer, not scared of the mathematics anymore. But I'm sorry, I didn't realize my camera wasn't on. But the one thing that I was going to mention is, in my job, one of the things that I do is I work for business intelligence, and we use a lot of data visualization tools that you would think of, like Tableau and Power BI, things like that. It's so hard for me, even as a data scientist, a self-proclaimed data scientist, to just understand how you visualize some of these structures. Like when you zoom into Mars, for instance, something that we don't have as many eyes that we do, like on Manhattan, for instance. Can you maybe go into just a little bit more detail into what it takes to actually make the visualization something that makes sense to the human eye?
Yeah, in fact, what I love about I mean, Mars was I kind of felt that you know, when I was 8 years old, it seemed like, oh, by the time I grow up, you know, I'll be able to go to Mars. That didn't happen. But what we did do is, of course, we've had so many missions there, and all these images come back, you know, and the art of planetary science has really been this technical prowess to sort of go out there and know where we are. In order to sort of, we take a picture, we have to sort of reconstruct where the camera was, to the best of our knowledge, to then apply that image to the geographical context or a global mapping context. And so that involves tracking the satellites, knowing exactly where they are. We know distance really well because just the round trip speed of light. And so that from radio communications, we know highly accurately the distance to spacecraft, and then we can see where it is in the sky from its signal. So that allows us to sort of pin where it is. So in these missions that have mapped our other worlds, where we've gone into orbit, we've been able to have campaigns that have mapped these worlds tremendously. If you think about our mission to Pluto, it was just a flyby mission, but we really covered it quite well. We really saw it extremely well, just on one side, of course, because we flew past. We didn't go into orbit. But as we approached, we saw Pluto turning, and so this campaign of imagery was pretty good. Once you have that data and you're visualizing it, then you can reconstruct essentially a perspective of standing there. I talked a lot about with Mars, okay, the height of the canyon walls and perhaps the height of the hills that were in front of us. But inherent in that is I was not exaggerating terrain at all. And if you have enough information to actually see those terrains, you know, for what they are, just without any vertical exaggeration, it's essentially reconstructing exactly what that place looks like. And so we can pre-visualize. In the case of going to Jezero Crater and Perseverance rover and wonderful Ingenuity helicopter, is that we could look at that delta and that target really closely with imagery that, as I mentioned, is like 1 foot in resolution, actually about 10 inches, 25 centimeters, and see sort of every boulder and so forth. And so when the rover landed, just like previous rovers, we can actually see them from orbit. And so this campaign of being on the ground, being in space, having spatial mapping capabilities is what the space program has really excelled in, and it just leaves this material there for the visualizers to pick up. And when you put this together in a planetarium dome, and it takes up your peripheral vision, it's tremendous, because you really have a sense as though you're just there on the surface. And that's where it gets very interesting. It's like, do we really need to go to Mars to be on Mars? And the way that information being sent back is giving us a very authentic view. I'd love to go if I had the chance, but nevertheless, that'll be really challenging no matter how you look at it. And when I have extended periods of taking people on journeys to Mars in the Hayden Planetarium, we have an incredible display system with the Christie laser that's high dynamic range. It's like one of the best in the world. Is that people end up saying, this is a common reaction, it's like, okay, we've seen enough of Moon or Mars, can we go home? And because you end up in a way, you know, it's sort of like this is a whole world that's just ochre and color and so forth, and you kind of want to come back to the cool green hills of Earth. So you end up you know, wanting to see water, and it's funny, it's just a sort of natural human reaction. We live on the best planet that we know of, and regardless of wherever we go, I think to not take care of our birthplace would be, very unwise.
Well, this is truly amazing. I mean, it's amazing what you can do with data, first of all, and then what you can do with visualization is just truly amazing. I think this has been a testament to that, and really the whole day has been a testament to that. I want to say thank you so much for your presentation, and to OpenSpace as a sponsor. I just wanted to know, for anyone who's listening or is going to watch the recording of this, what's the best way to get in touch with you, to keep track of your work in particular? And I know we already posted the website, the openspaceproject.com or .org, I'm sorry.
It's actually .com.
Is it .com? Let me make sure that we.
.org was already taken.
I didn't write it.
We are open source and freely available.
Okay, yeah, we wrote .com. Okay.
So I was like, well, .com. We're not really a .com, but anyway, openspaceproject.com is really great. And if you're into it and you want to download it and you want to learn more about it, there's also a Slack channel, and our developers monitor that pretty good. I'm on social media a bit with some of this, Instagram and Facebook and so forth. But I would say probably the best way to contact us or me is through our website.
Awesome. Well, that sounds good to me. This has been truly amazing. I'm like mesmerized by the screen right now. It's so incredible, the amount of things that are out there. And you're so right. Like, my natural inclination was like, oh, I wonder if they did this for Earth already. And like all of Earth, because I know you showed us Manhattan, but then I was like, I wonder if they did that. But you're right. The natural inclination is bring me home. Like, yeah, actually, I'm scared.
No, it's and I don't know if we're going over in time and all that, but you asked a sort of leading question. I kind of thought, well, if I had a chance and I was going back to Earth. In fact, I'm going back to Mars, so I have to change my focus out here. Doesn't matter at all. I mean, it's epsilon away. But anyway, okay, so we'll just come on back for a second. But during the pandemic, on Facebook Live, I did about 100 of these programs with friends of mine, musicians, playing, and so it was really just music and me flying. And we fly typically for an hour. And over Earth, because Earth is so beautiful, and it's really, I mean, what matters more than our planet? I'm actually going to just go back to now, essentially, and let me turn off a bunch of things. So ERMS, and I'm going to turn off the powers of 10, even though they've been really nice for us and all that. And I'll just come on back down to Earth. Oh, and I'm over the Pacific. That's the international date line. So what I'm going to do is, oh, actually, no. Okay. I wanted to sort of come down to an area near and dear to my heart. I haven't been there since I was 18. I was hoping to get out there this summer, but let's see. There's California. In fact, you can kind of see some from the Sequoia fire. You're seeing some of the fire there.
Oh, wow.
But I want to go up to the Canadian Rockies. I'm not sure if anybody on the Space Apps team might be from there, but let's come down a little lower and let's see. Hold on. Earth. I'm wondering if OpenSpace is going to be able to take it. Okay, because I've gone all the way out. I come all the way back. And, let's just, I'll turn off that layer. Yeah, here we are. And so we have this nice high resolution, but this particular part of Earth is just so glorious. And let's see. I think I see where I am in the proper place. Is there Vancouver? Yeah, okay. And because you asked, I just wanted to sort of come on down. Lake Louise, Jasper National Park. It's like, oh my gosh, it was just first time I went ice climbing was out there, and it's just like so glorious. And so, with the beauty with this, especially with the cosmic perspective added in, that you can kind of come in and just do this, is really quite nice to just come on down and fly amongst the landscapes of Earth. And this is one place that's particularly grand. So yeah,
this is amazing.
And it's I'm patting open space on the back here because it's done a lot for this presentation this evening. But here we are coming down. I not exactly sure where I am in there, but this particular part of the world is just so beautiful. Like many parts of the world, the Himalayas are gorgeous. Central Asia is beautiful to fly over. And when I do these live events, usually I have friends of mine and sort of responding, "Where are we, Carter? Tell me where we are." And I like to not tell people where they are because they occasionally pull up. And I think part of the magic is getting lost on Earth. That may sound sort of crazy to say, but it's just that, yeah, I mean, sort of being lost and suspended in the beauty and not knowing exactly where you are, to fall in love with it as a planet, especially like, oh, the Sahara Desert is amazing. And who cares what border is there, because from space you don't see that. And the thinness of the atmosphere is extraordinary. And I think to the greater degree that we can democratize, share the astronauts' perspective, that's all for the best, all for the better, because then we all sort of get to see that we rely on one another and we rely on this ecosystem that really we are just sort of a small part of. We're a big part of it because of the effect that we're having on it, but also the fact that we can think, and hopefully our ability to think and solve problems, like just a hackathon like this is like bring minds together and work on problems, and solve these problems that we've made for ourselves.
Amazing. Well, thank you so much, Carter. I hope to one day get an invitation to that live event. That sounds amazing.
Oh yeah.
But
those my friends know that I occasionally bring people in after hours. I shouldn't say that publicly, but yeah, it's just that having this and being able to like fly this in the dome. I mean, hey, it would be crazy not to do that, right?
Yeah, that's true. Well, thank you so much again for taking the time and showing us all about open space and
Sure.
the work you put in and all of the everything. I mean, it was amazing. So thank you so much. And we hope you have a great rest of your evening.
Well, thank you. And you guys too, and have a great hackathon. I look forward to hearing more.
Thank you. And thanks again for being a sponsor. You're
doing great work. Keep it up. Thanks.
All right. And with that, I'm going to hand over the mic to Dominique again. For those of you who weren't on before, Dominique is a co-director of Space Apps NYC with me. Dominique's going to take over emceeing for the rest of the night. And with that, I will say good night.
Okay. Bye-bye.
Oh, Dominique, are you there?
Yes. Sorry, I was waiting for my little mic to turn back on.
Oh, that's okay.
But no, thank you so much, Katelyn, for putting so much work and effort into this entire symposium. I want everyone out there viewing to know that Katelyn came up with the idea that we should bring back our conference this year, and she put in so many hours of work to contact as many people as possible so that we could have this amazing day for you guys. The lineup was amazing. And so I just, this was like the fruit of her labor. And thank you so much, Katelyn, for the work you've done and the thought you put behind this.
Thank you for your support, Dominique, as always.
Okay. And so our next speaker is Divya Prasad. She's from NASA Jet Propulsion Laboratory. And today she's going to talk about hacking in space, luck, creativity, and imagination in space exploration. Some of the greatest discoveries in space exploration have come from extraordinary circumstances. So today, Divya is going to take us on a journey through the history of how space scientists, engineers, and data experts have transformed failures and unexpected discoveries into incredible insights into our cosmic neighborhood. Divya, it's all yours.
Thanks so much for that introduction, Dominique. Let me just go ahead and share my screen. And there we go. Yeah, thanks so much for having me today. I'm really excited to be speaking with you all. So I'm going to talk today about hacking in space. So here's just a little graphic of the over 100 missions that have launched that the Jet Propulsion Laboratory has been involved in. So this is even an even smaller subset of what NASA has produced and what other space agencies have produced. And so we often celebrate when space missions go right? We celebrate launches and flybys and see these spectacular images. And recently with the Perseverance rover, we watched the landing videos. And a lot of times we think that scientists and engineers have everything perfect, right? But what happens when things go wrong or the unexpected happens, which actually happens a lot in space? So I'm going to take a look at 5 different NASA missions and how they were sort of hacked because of things that went wrong or in a direction that wasn't expected. So the first one I've named Devils on Mars, Dust Devils, that is. So back between 2004 and 2010, there was one rover called Spirit rover that had a twin called Opportunity that ran actually until 2018. And these were 2 mini geologists on Mars. They had a bunch of different instruments. They had panoramic cameras, which were sort of the eyes, different sort of geologic tools and instruments to explore their environments. And the idea was that these robots were supposed to be like geologists on the surface in place of us. So what was hacked here? Well, one day in 2005, Spirit suddenly reported that it was receiving a lot more solar power than it was previously. So increased from like 60% to about a 93%. It was very dramatic. So here's a picture of the solar panels on Spirit. This was actually a few months later, but this is a good illustration of how much dust was on the solar panels. And so what happened actually was that dust was cleared off of the solar panels. And so here's an aerial picture of what cleared the dust off, not this exact image, but this big column of dust. So on Mars, because of the temperature gradient, so you have the sun shining on the surface, it's heating up the surface, and the air is actually pretty cold. When you get that difference in temperatures, the air starts to circulate, and then you get a dust devil. And a dust devil is very similar to a tornado. You have those differences in temperatures driving wind velocity and direction. But instead, it's dry. It's not driven by big thunderstorms. And it's much smaller. So then Spirit went on to actually observe a bunch of these. So at the time, we knew that there were dust devils on Mars. We had kind of seen them before, but had not expected one to actually clean off the solar panels. And so this is a video that's been stitched together from individual images. And the sort of hack was with the eyes of the rover, the panoramic cameras, where these engineering photos were taken in sort of stacks to be able to capture these animations. That was kind of the first time that that happened. But then Spirit went on to observe over 500 of these dust devils in 2005 alone. And to this day, Curiosity rover is also streaming back these little videos of dust devils on Mars. And we'll probably have ones from Perseverance as well. So this is the first time that we really got videos like this of active surface processes on Mars. And it was kind of an accident that started with Spirit getting a boost of power one day. And here's a little example of Perseverance's video capturing Ingenuity, its helicopter, kicking up dust. And so there are a lot of things we can learn from these dust devils or from Ingenuity about the sediment on the surface and also the density of the atmosphere and how it moves and the fluid dynamics. And it all started with sort of an accident. So what's the lesson from this hacking? I'd like to think science happens outside of our expectations. And I think that's absolutely true with space. And we'll see that as I continue. So the second one I've called Not in Your Wheelhouse. So Curiosity rover has been operating since 2012. It's been a while. And it's currently traversing up towards a big mountain called Mount Sharp. And on the right, I've shown in green is the pathway that it's taken in the past 9 years as it's going up. This is about until March 2021. So it's traveled a long way. And what it's trying to do is stitch together the story of this area through studying the rocks. So as it's going, it's collecting images, it's taking measurements, much like Spirit and Opportunity, but with a lot more advanced technology to build up a picture of not just the different rocks, but what they tell us about how they formed and what kind of environments must have allowed those rocks to form. So especially looking for long-standing water on Mars, because that would be the friendliest environment for life. And so I like to think as a planetary geologist myself of rocks as a time machine into the history of Mars, and Curiosity is probing this. But unfortunately, over the years, Curiosity rover's wheels have gone through a lot of wear and tear. So looking at this picture on the right, there are all these big holes cut through the wheels. And this has been happening for a long time. So this has been a concern for the rover for its traverse. Have to be very careful, and especially if we want it to make it to the areas that we're most interested in. So what was hacked? We have images of the wear on the wheels, which I've just shown. And we also have images of the wheel track. So this is a really beautiful panorama, looking behind the rover and seeing where it's driven. And so if you take a look at this photo, it's pretty spectacular. You can see pretty far away. And you can see kind of where the rover has turned. In some areas, the soil has compacted in a different way. It's displaced some rocks here and there. All of this is sort of dark. And so scientists and engineers thought, hey, what if we combine these images and started figuring out what the rock is made of? So what are the physical properties of the rock? So on the right, I just have a little grid of some rocks that we've sort of observed or may observe on Mars, largely sandstone and a lot of mudstones, which are exciting because they point to a nice sort of stable water environment, like a lake. And what they did was they have this big working model of Curiosity at JPL. This is actually a picture of Perseverance, but a life-size model of Curiosity with its wheels, and they can test out how the wheel interacts with different types of rock. And when you combine that with the images that it's taken of its own tracks and what the wheel has sort of displaced on the rock, how the soil compacts underneath it, you can actually calculate the likelihood of different rock compositions that it's been driving over. And since we have that really long traverse, if you do that over a really huge period, you can actually see how those rocks are changing and build up even more of that story. So really looking into the geologic history of this area called Gale Crater, and also led it into wheel redesign for Perseverance, because we didn't want that to actually happen again, even though we learned from it, right? So what is the lesson? Everything can be a learning opportunity, even obstacles, even slight disasters. The third one I have is, I love this story. Smile, you're on Juno Cam. So the Juno spacecraft is currently operating. It's a probe to study Jupiter and its environment. So studying the surface of the clouds and also the interior of the planet over a period of time. It arrived at Jupiter in 2016. It's studying gravity and also microwaves and other wavelengths, as well as the sort of fields and particles and magnetic field around Jupiter. So this is the first sort of dedicated mission that we've had to Jupiter that's been a long-term mission. So here's an example. You can see how big it is. And here's a list of its core instruments. So it's really focusing on Jupiter and all of these physical properties. And the eyes, what I call the eyes of Juno, were almost not included. So the camera wasn't a priority as a science instrument. And it sort of got tacked on later. People argued that it would be useful for outreach because we hadn't really had a dedicated mission to Jupiter. We'd had a lot of flybys, or we had, I mean, there was Galileo, but this would be much higher resolution. It would be a lot closer. So people argued that, okay, having a camera would be really useful for just lay people to appreciate this planet. And the images would be released online after every single flyby of Jupiter, and anyone could process them. And they really encouraged people to form a community to process the images, share how they process them, make art out of it, even try to pick out things, follow the how the Great Red Spot changes, whatever interested people. And they held a forum for that, and they said, put all of your work here and talk to each other and share it. So what was hacked about this? Well, here's a really spectacular image from someone who does a lot of really amazing Juno Cam processing. And so this is a really great example of just the impact of the camera itself. I think it's such a poetic image. It evokes like Van Gogh and a lot of painters, and it doesn't look like scientific data, right? And just an incredible close-up photo of Jupiter, and very striking. And I'd like to say that I think that impact itself is worth it. We don't need science to make that worth it. But as these images came down, a lot of scientists found them very useful. So here's an example of this person also processes a lot of Juno Cam imagery, of doing a sort of time series of seeing how different cloud decks move over time or rotate. So this was pretty cool. You can get watch the surface change over the course of the orbit. And there's a lot of science you can extract from that. Here's another, this is a really beautiful view. I just love sharing Juno Cam images. So this is the south pole of Jupiter. There are a lot of these like vortices and cyclones going around, and incredibly magnificent, but also, again, very scientifically useful for people unlike me who study clouds and atmosphere dynamics and fluid dynamics on planets. Here's another just incredible image processed by Jason Major of really high altitude cloud decks on Jupiter, I think close to the equator. And again, very, very striking. But these are really important because you can actually start to measure the heights of these cloud decks, and higher altitude storms on Jupiter might be producing lightning, which is something that we observe with other instruments on Juno. I really love this. So the original image of the that's presented here was actually static. It was processed by Justin Cowart. And what happened was scientists took velocity vector fields, so basically a map of the expected velocities at the surface of the Great Red Spot, and applied it to the static image to actually animate it to see what it would look like. And I thought that was a really nice confluence of the art and the science of bringing it to life for lay people, but also having scientific applications. And this is actually pretty recent. This is a lot more in my wheelhouse. This year, Juno had some flybys of the biggest moon in our solar system called Ganymede, which is about the size of Mercury. And Ganymede is really exciting because it probably had or has a subsurface water ocean. So it's considered what we call an ocean world, these sort of icy, rocky moons or bodies in the solar system that probably have some sort of ocean underneath, and their surfaces have these very interesting features that we don't really see anywhere else, but are evocative of tectonic features on Earth. There's some sort of resurfacing that's leading to smooth areas. There are all these lines everywhere that are crisscrossing. So this activity has probably been happening over a long period of time because there are new ones over old ones. And a lot of craters have been erased by some sort of activity. And so this is exciting because we haven't really gotten close views of Ganymede in a long time. And this is leading into the Europa Clipper mission, which I work on, which will launch in a couple of years, and also the European mission JUICE, which will study Ganymede, Callisto, and Europa. And so that's really exciting. We almost didn't have a camera on Juno, and it was sort of this last minute addition, and now we're getting incredible science from it. And also we're getting incredible impact to people. So I think the lesson is all data can be good data, and non-scientists offer important perspective and skills. A lot of people have been involved in processing JunoCam images, have been really passionate about sharing their skills with each other, of doing citizen science in collaboration with scientists using these images. So I think it's pretty amazing. I think this is a great example of how the line between science and art doesn't really exist. I'm just gonna take a drink of water. So my fourth one is called Moonraker, which is a bit of an homage to James Bond because the new movie came out this week. So on the left, we see a sort of shadow and some bright material coming off. And I want to say this is some of the images that like got me into planetary science. So I just love this. This animation was processed by Emily Walle, and I want to talk about what that is. So the Cassini probe was designed to study Saturn and operated between 2004 and 2017. So just about 4 years ago, it actually crashed into Saturn at the end of this really amazing campaign. That was just sort of the final flights, and it did these great dives between the rings. And much like Juno, it was similar to Juno in that it was studying Saturn. It was also studying many of the moons of Saturn. It led to the discovery of many more. It studied the rings, the interaction between the moons and the rings, and the plasma environment around Saturn. Just an incredible mission. That's why I'm here today. I watched a TV show about Cassini when I was in 7th grade, and I said, I want to work on space missions. So I have deep love for Cassini. So the spacecraft, again, similar instruments to Juno, and kind of similar to a rover, I'd like to say, because even though we can't land on Saturn, we can't really, or at the time we couldn't land on the moons of Saturn. This is sort of like a flying geologist, is what I say. So if you had a geologist in flight, what could they study? So there are radar instruments to study deep below cloud decks in Saturn, and also the moon Titan, which is about the size of Ganymede and has thick clouds, studying the fields and particles and dust and plasma and magnetic fields. Amazing camera system, a dedicated camera system to take images. So yeah, very similar to Juno, and this mission just collected so much data. It was just amazing. And so this is actually my background right now. It revealed the diversity of moons. So I mentioned ocean worlds before, and Cassini kind of expanded what we considered of ocean worlds. So at the time, this is when I was a child or before I was born, but probably at the time we had the thought there were maybe 3 or 4 ocean worlds that we'd been considering, but I think Cassini expanded that quite a lot. So this is a really beautiful picture. Cassini's cameras were really, the folks behind them were really dedicated to creating images that were appealing to the public, that were artistic and beautiful. And I just love this image. So you see Saturn's rings right in the middle. And here's a moon in the foreground and some moons in the background, including some little ones that are sort of irregular. And so a lot of these moons were they had these strange potentially tectonic features, these long sort of lines scraping across the surface. And so they really challenged us of thinking of these moons as sort of these dead bits of rock floating around Saturn. They clearly had some sort of dynamic history. And so one such moon, I love this video. This is actually from 2017, but there are earlier images and animations of Cassini flying towards this moon called Enceladus. And again, here this mysterious glow coming from the south, like I showed you earlier. So let's look at Enceladus. So Enceladus is about the size of France. So if you want to think about ocean worlds, and Ganymede is about the size of Mercury. This is a very tiny rock. But the surface is very bright, which indicates water ice composition. And it's also really smooth. So you have features of racing craters, racing each other. There's some sort of surface resurfacing. They're active processes or recently active processes. So 20 million years ago, which is recent for geologists. And maybe pointing to liquid water underneath the surface. So we had images of Enceladus from telescopes and I believe from flybys, but nothing quite spectacular as this. So this is an image of the South Pole. If you see these, this is sort of contrast enhanced, but you see these blue stripes going across the surface, these very deep ridges. And the hypothesis is that as Enceladus has been flying around Saturn, it's being pulled in multiple directions, not just by Saturn, but also by another moon called Dione. And as it goes around, it's getting crunched, it's getting pulled outwards and then crunched inwards. And that keeps happening over and over. And it's kind of stressing out the South Pole and causing localized warming. And when you get that kind of warming and you have water underneath the surface or maybe even ice underneath the surface, then you might get these massive explosions outwards. So the hypothesis is that there are geysers like we see on Earth on the massive scale, and also these sort of like curtains that open up, these jets that come out. So Cassini captured these images, and it was this really exciting mystery. So what was hacked here? I love this. There weren't dedicated instruments on Cassini to fly through a plume and collect water from it, because that wasn't expected. But there were 3 instruments that were used for other things, to collect other very small things. So the particle spectrometer was, it's actually a collection of different instruments, but generally is supposed to collect particles zooming around Saturn and analyze their composition. The ion and neutral mass spectrometer is supposed to do similar, but with smaller particles, ions. And the cosmic dust analyzer is supposed to analyze cosmic dust. So these 3 different instruments were not meant to really study plumes coming out of any moon the size of France. So they were supposed to look at ions being accelerated by the magnetic field of Saturn, and to study the general environment of the Saturnian system. But because they study small things, because they can collect little bits, they're actually really useful. So scientists and engineers came up with this cool idea to actually use them to fly Cassini low over these jets and collect these particles and actually figure out what those particles are made of, if it's liquid water, if they're organics, if they're salts. And could that point to a nice warm ocean that's happy and friendly to life? So they did that. And here's just a little picture flying over the nice warm tiger stripes, which is their nickname at the South Pole. And on the right, in the upper right, these are results from the ion and neutral mass spectrometer. So showing the possibility of methane, water vapor, maybe simple organics, CO, complex organics, and CO2. So these were really low detection rates. It was very hard to do, but the data seems to be suggestive that there's something exciting there. We can't really say definitively, okay, there's a nice warm mushy ocean under there that's liquid water and potentially has bacteria kicking around, but we can say that we probably should fly a mission there. So in the bottom right is, this is from a different instrument. This is one of the sub-instruments on the spectrometer called CAPS, just sort of mapping out. I thought this was pretty cool as Cassini went through mapping out these plumes. So all of that led to this hypothesis of this very, very, very tiny world being potentially an ocean world with either a global ocean or like a local lake or just warm, squishy ice. And maybe if there's an ocean, maybe it's salty. The composition may be pointing to water interacting with rock, which is what we want to see because all of those chemicals that are leached out of rock are really great for life. And we see that in our own oceans when we get black smokers and white smokers and these really rich organics that can form more complex molecules or be used by bacteria in the depths to basically survive without sunlight. So this radically changed our idea of what it meant to look for life in the solar system. We kept thinking, you know, there's Mars, maybe there are worlds like Ganymede or Europa, but this tiny little rock that really shouldn't be active was pretty active. And this feeds towards how we might sample plumes in the future, such as with Europa Clipper, which I again mentioned, which is sort of similar, but also very different. It's about the size of our moon. Maybe has plumes, we don't know. There's some data suggesting there's something coming off of Europa. So that kind of chance encounter and some ingenuity have led us here. We are rethinking of what it means to look for life and what kind of instruments we need to do that. So what's the lesson? Creativity, I think, is the key. It's important to both science and engineering, especially when unexpected things happen. The final one, I really like this story because it's less planetary science. And I've called it Hello Darkness, My Old Friend, where darkness is the darkness of the cosmic optical background. So I'm going to explain this picture on the right. The picture sort of shows this glow looking into the night sky, and that glow is called zodiacal light. And zodiacal light is basically the light that is interacting with dust and particles, like I've mentioned, that other that space missions sort of look to collect and study, where you have the light from the sun and also stars traveling to our eyes. It's bouncing off of all of these particles. And it's beautiful. It's also makes looking out into the universe very difficult because light is a bit of the enemy of the astronomer. So to talk about something completely different, there is currently a mission called New Horizons, which was built to study the unique environment and surface of Pluto. So this is a planetary mission, a lot like Cassini and Juno, cameras, magnetometer, radar, dust collector. So it's a very similar idea. And New Horizons it had its flyby of Pluto in 2016. So these are the best views of Pluto we've had to date and will have for a while. So this is a beautiful global mosaic of Pluto, and there's the heart of Pluto. This was very exciting, and I'm not going to even talk about Pluto. I'm just going to pass it by, but I will share this photo just because it's amazing. This also radically changed our understanding of Pluto, of what it means to be an active world. This is potentially an active world way in the outskirts of the solar system, where the energy it receives from the sun is so little, we think it probably shouldn't even be active. But we found what could be nitrogen glaciers here and these smooth plains and evidence of resurfacing. So it could be an ocean world even. But forget Pluto. New Horizons is still flying and is one of the farthest out spacecraft ever. So this figure shows our little solar system. Here's a little disk around our solar system called the Kuiper Belt. And this is like a sort of disk of the reject material that didn't become planets when the solar system formed. And so here's New Horizons. It was 2015 that it passed Pluto. And so the only other spacecraft that have reached this far from the sun are the Voyager missions, and also someone's going to bug me about this for not knowing, I think Pioneer. But currently, or maybe as of a couple of years ago, it's on the order of like 5 billion miles away from the sun. But New Horizons still has energy, it's still going. So what happens now? That's a good question. A lot of people are asking. So recently, past couple of years, what was hacked? I talked to you about the zodiacal light. And the zodiacal light is very pesky. It's pesky for spacecraft like the Hubble telescope, which I have right here, which studies galaxies and sometimes planets and a litany of other things. And zodiacal light is kind of the enemy of Hubble when it wants to look at very dark things. So why do we care about how dark the universe is? So the light or the cosmic optical background, so sort of the glow of the universe, tells us about the history of the stars. It's kind of like the remnants of stars that have existed. And to study that, we want to be able to escape any sort of light pollution that's coming from Earth or from the sun or from zodiacal light. Hubble can't really do that. It's too close to the Earth. It's in the inner solar system, right? So the question that some scientists asked was, can New Horizons actually just see better than Hubble? So here's a little illustration of zodiacal light in the background. New Horizons nicely pointing elsewhere. So when it was at 4 billion miles away, New Horizons sky that it was observing was about 10 times darker than the darkest patch of sky Hubble could see. So scientists took measurements, they took these images, basically, so not images of a planet as intended for this camera, but the sky, and subtracted the light of the Milky Way and other noise or expected light from certain stars. And there was a glow afterwards. It was very, very faint. And some scientists on the paper related it as if you were maybe camping outside and a mile away, someone else opened their refrigerator. That would kind of be the level of light that it was seeing. So that glow was measured. And essentially, they concluded that unseen galaxies they weren't accounting for, and can't see, are making more light than we thought. And we don't know why. Are we missing galaxies? Are there more galaxies than predicted? Are there things that we aren't modeling? This is kind of an interesting question of how dark the universe is and how we can understand the history of the universe and galaxy formation and light. So I thought that was pretty cool that this mission that was already so ambitious to study Pluto, to have the single flyby in 2015, is also being used to look at our very origins. So what's the lesson? I think there are a lot of lessons. I'd like to think that the biggest lesson here is to try new things and learn as much as you can. And I think that's a nice way to end, because I think that's what space is. It's always about trying new things. It's always about learning as much as you can under the constraints of limited technology or limited data or money or extraordinary circumstances of having solar panels be covered in dust and your rover dying, or a crash, and doing the best that you can. And I think there are a lot of life lessons there too. So I'm going to wrap it up there. And thank you so much for having me. And there's my contact information if you'd like to get in touch. And yeah, that's it.
Wow, thank you so much, Divya. I was just leaning into the camera, into my view, looking at all the pictures. I was really, like you said, like I didn't see really a distinction between art and science, especially looking at the UnoCam rendered photos. I was like, this just looks like artwork. It's so beautiful. And to think that the camera almost never made it on board, it makes me sad. It makes me wonder what other things we've been missing, because we thought, this camera, this tool didn't have importance. Let's see if we have any questions. One question, I am going back earlier to when you were talking about the rover on Mars and having the geological history via rocks. One individual asked how many kinds of rocks were identified on Mars through that, through that project, the hack.
Ooh, I'm not sure about that specific hack. That's a good question, and I should look that up, but I don't know. There have been lots of different types of rocks definitely identified by Curiosity that have been like surprising. I think we expected sandstone, we were hoping for mudstone, and Curiosity basically saw mudstone in the first 100 days. And then it started seeing some really interesting, like chemically altered rocks later on, like hematite. So the interesting thing with studying like the physical properties of those rocks can tell us a lot. So even if it doesn't give us even if we know the composition, it can also tell us about, okay, how porous is it, or are there impurities, or is there, how rapidly does that change? We can like build up what we call the stratigraphy at a really, really fine scale. So the stratigraphy is that nice like column that I showed you with all the little layers, and that kind of represents going deep into the history of a geological area. So if you drive anywhere in the mountains or something, and usually on these nice winding roads on the sides, you get the cliffs, and sometimes you see those layers. It's kind of representative of that. So if we can even mark tiny changes in like, okay, the strength of the sandstone's changing, maybe the content of certain minerals in there is also changing. You're really like really refining that geologic sequence, which may not be exciting for everybody. But it is very interesting when you're thinking about how water might be changing, especially because the question of water on Mars is still a bit funny. We don't know if it lasted a long time in a stable environment, if it just rained every 1,000 years and then dried out completely. And so all of those like little things can actually point to those answers. So I kind of avoided your question, I realized, because I don't know, but there you go.
No worries. I mean, I think it's really fascinating, and to know that, individuals are trying to replicate some, like, part of science is not just looking at what's going on outside, but really getting those images back, getting that data back, and trying to replicate it to understand, like, what does this mean? What does this look like? What impact does this have on our planet? Do we have something comparable? Because you talk about the mudstones, and it's like I didn't even think about that. Like, oh, that is a really interesting way to kind of indirectly identify, is this an ocean world? Is there water there? How long has it been since it evaporated, if it's gone? That's really, really cool. Another question I had, my own personal question, was when we were talking about the UnoCam and how they created the open forum for individuals to come and render the pictures and do things like that. How important are like citizen scientists in understanding or making sense of the data we're getting back from all of these expeditions from the rovers and the satellites?
Yeah, I think they're getting more important, and I love to watch that. I think we're starting to see more importance being placed in getting citizen scientists involved, and I think it's something that the astronomy community has been doing for a while. What's the website? Galaxy Zoo, I think. So it's one of those like zoo websites where citizen scientists can go in and try to identify things. Basically, when there's a massive amount of data and it's more efficient to have people do it than a computer, or it's like too fiddly for a computer to do. And so citizen scientists can actually help process all of that data, whether it means actually processing it or recording things or identifying things. And that can feed into, that gets like the quantitative data out for scientists to use. So I think it's been something that's happening in astronomy, and I think JunoCam was kind of like the first sort of move where it wasn't meant to really be a citizen science project. But if you go on, there are people tracking changes in the surface and potential lightning strikes in the images. And so I'm hoping that we see more of that. And I think there are a lot of very, very talented and dedicated image processors, especially who go into like old Cassini archives and rover images and look for active processes, or just make art out of it, or just amateur geologists who like to speculate what's happening. And I'd like to see more of that interact with the academic and formal research, because I think it's important, because all of these missions are publicly funded, and really at the end of the day, we do it for all of us. It's not just for me in my apartment typing on my computer. It should be for everyone. So that's my little plug. I'm hoping that we see more of that, definitely. And I know that's something that like the rover teams emphasize, that releasing images as they come down instead of holding on to them, which we used to do in the past, is really important, of making sure the public has access to them. So again, like blurring those lines between who's a scientist and who isn't, and art and science, I think it's just really great. It's a great aspect of what we do.
I agree. I think that's so important. And I guess another reason why I brought that up, because I felt that as you were discussing, it kind of reminded me a little bit of what we're doing this weekend with the NASA Space Apps Challenge, and how they're encouraging people to use their open data sets to hack and basically see things that maybe were hidden, or things that we weren't necessarily looking at, because a lot of times when you have projects, they're structured a certain way. So you're looking to investigate certain things, test certain hypotheses. You're not really thinking about maybe all the different stuff around it. And so I like to say to our participants, or now I like to call them, like citizen scientists, because they're, in a way, that's what they're doing. And I just hope to see more of that, like you said.
Yeah, it's really great. I was reading through the hackathon projects, and I had a really similar thought of, it's wonderful. It's great that you're doing this. So.
And then I had another question, because tons of questions actually, because as these things were popping in my mind. Earlier we were watching Carter, Emmett, and show us about open space, and demonstrating a lot of really cool things we could do with it. And he was showing us how, when we kept expanding our view of the galaxies and our neighboring galaxies, it kind of looked like an hourglass. And the reason why we weren't seeing galaxies and universes on one side was because of the Milky Way. And you were talking about this really cool hack about how maybe we're starting to see images of hidden galaxies because of new horizons, and so I was wondering if you could go a little bit more into that, and just what people are speculating, or what they think, or what the next steps would be, and explore.
Yeah, that's a great question. So I think I sort of have two answers. So for that specific quest, in a way, again, a bit outside my wheelhouse and being like astrophysics. So the idea is that we have an estimated number of galaxies that's based on what we can observe and what we can't observe, basically. So we know what we can't observe, and then we have to model how much we can't see based on the light of the Milky Way and other factors, and then basically plot out that trend and say, okay, well, here's the actual number, and it's around 3 trillion galaxies, which is a lot. And so the idea is that if this glow is a bit unexpected amount of light for the number of galaxies we expect, and there are probably more galaxies than we realize. So I think on the astrophysics end, again, I'm not an astrophysicist, but it probably goes into how we model the universe and galaxy formation. So I don't know about future work for them. I think it'd be interesting if they continue to collect these observations from New Horizons. And I also know that there are other applications for using New Horizons, really great camera, to do interesting astronomy, for example, like looking at specific targets, because again, it's so dark out there. So I don't know the specifics. I know that New Horizons kind of focused on checking out the next like Kuiper Belt object, because it already flew past one, and it's planning to do, I think, more. But it'd be really cool to see. I've been really excited to see what astronomers do with the data, because why not take advantage of it, because it's there.
That's pretty cool. Thank you. I'm sorry if I was going a little bit out of your wheelhouse. I just
no, that's
sort of
okay.
connecting dots, because I'm like, we're
Yeah.
watching this, and these people are presenting really cool things here, and I'm just connecting dots along across the different presentations from today. And I also was curious, you mentioned that for with Cassini, it had revealed diversity of moons, and I wanted to know if you could talk a little bit more about that. Just what was the concept before there was diversity of moons? What was this monolithic idea about them, and then how did that evolve, and what are the implications of that?
Yeah. Oh, that's my favorite topic ever. So, yes. That's why I'm a scientist. Yeah. So we knew that there were diverse moons in the solar system, let's say. So based on ground-based telescopes and like the Galileo mission and Voyager, which flew in the 70s, and did the 2 Voyager spacecraft did these flybys of the Jupiter and Saturnian systems, but also Uranus and Neptune, and caught sight of moons as well. And currently our view of the moons of Neptune and Uranus only come from that. So we sort of had a picture of diverse moons before then, absolutely. I mean, at that time, before Cassini. And Galileo gave us a really, really fantastic view of especially Europa, again, before I was born in the 90s. So I don't want to say like we didn't have a view of diverse moons. They were considered kind of a wide range. So when we look at our moon, we see mostly a volcanic surface. Let's say magmatic surface. There was a lot of magma on the surface. You have these highlands, you have these lowlands, and that was probably the main process on there, that there was magma. And then over time, there was no atmosphere. There's just this soft, mushy stuff on the surface called regolith. And then when we got close up to Europa, we saw all of this evidence of resurfacing and tectonic formation and stretching and compression, and potentially pointing to water beneath the surface. And I think that was a major step towards understanding diversity of moons, where Voyager sort of caught sight of these things at a distance, but here it was in like really fantastic, the best resolution we've had before Europa Clipper. And I think what Cassini did was kind of reveal that Saturn had its own like solar system of bodies, where you had these tiny moons that were sort of like the moon. They didn't really have anything happening, and then you had other moons close to the rings that were funny shapes that had clearly been stretched and flung about. There was Titan, which is like a planet unto itself.